Morty, we've got to turn the project in early.
Hey everybody, how are we doing today? So we're in for some fun. I see everyone in the chat. Remember, so we do have someone probably watching today. I don't know if they want to say hey in the chat. They might be watching and seeing how we do this new online format. And so it's so good to see everyone here, checking their points. Good to see Adam. I saw Carson. I saw Ashley and Kaylee and everybody. So yes, Jill is here saying, hey, we're gonna make Jill a mod right here. So Jill, you get some of the mod powers. So what it is, if you'll notice all this kind of fun stuff we have going on right now, it's some new things I've been trying out, is that the students actually get points by participating. Thank you, Luke. So the students get points while participating right here. So once again, if you are chatting right now, once again realize that we might be taking some screen grabs from this so they can be used for the Haslam Alumni Magazine, I believe. Oh, well, thank you guys. Carson, you're awesome. And I miss seeing you guys. Carson and Walker, you guys sit over there on the right in the classroom. I can all of a sudden disappear if I go over here. There's just a border there where I disappear. We'll pretend that doesn't exist. Hey, Sydney. So Sydney sits over there on the right. Sydney, you sit about 2 rows up. Like, I miss seeing you guys. So we got so many people in the chat. Good to see we got everyone. So it's really fun seeing everyone in the chat right here. We mod as many students as we can. We got Tracy right there. Tracy sits right row front side. Oh, I miss you guys too. So I know Adam, you sit in the back middle, right? I remember you'll answer some questions. You missed class. We got it right here. And it's so good. I love all the positivity to start. So kind of what's going on right here is one of the things we've added that I think the students really enjoy. Julian sits in the middle right there. Oh man. I know, and I'm so glad you guys are enjoying this. And remember, we will probably be taking some screen grabs of this right here. So I could pretend I'm talking about one of the big concepts here. We'll do a screen grab right here, but I'm not asking questions. Oh no, I'm blocking the slide. I gotta be away from it. I gotta be like, here's the concept right here. We're talking about the concept, just being like, hey, with the beard. I'm gonna go shave it and come back. So this is the quarantine beard. And once again, what you're experiencing right now, and I wonder, this is how we present data right here. What you're experiencing is how we've been running our class, especially the students have been seeing, thank you, Tracy, so much, all these new things. And I want to thank UT really, because we've even got new things. What is this? Insanity. If it's still working, it should have just said insanity. And then I can go over here and I can be like, welcome to Stat 201. Jake likes quarantine. I thank you so much. Her and go and grab a snack. Good job, Kara. We're just having a little bit of fun. Usually we do at the start of class, especially since we're online right now. We really, hey Brad, hey Isabella. We like to say hey to everyone. We like to start with some real good positivity. Once again, here's what I want you to do. So for Jill in the chat, I want you guys to say hey to Jill. I want you to say hey to Jill, ask her how she's doing. We're all quarantined right now. So everyone show Jill how we tag people in the chat. So when we're talking to someone, we can ask them a question or we can say hey to them. Good vibes. Remember, use the tag on it so we can, so there we go. Adam's tagging her right there. 1,000,000 points. We got everyone. Awesome. So you see everyone's tagging you, which is really cool about this. When you do the @ at somebody, you can then see that they've kind of talked to you. I love it. I like that you like it. So it's really cool how this is a very like interactive chat. And what I have is you might not be able to tell, is this is where my screen is at. The camera is over here. So I rarely look directly at the camera. I know, right? But you guys are crazy. You guys are fun in the chat. The chat is so fun, and we're all so positive in here. We start off the class. Everyone gets 1,000,000 points right there. And then once again, what we also have, and just to make it clear, is we have the points function right here, where the more you talk in the chat, every 5-minute interval you talk, you get 5 points. So there's a point system we have in the chat. Then there's also Brian's crazy point system, which go towards your extra credit. But it should tell me in a moment from Streamlabs how many points I have. Oh, well, thank you guys so much. I really appreciate it. You see, I have 405 bucks, which means I've talked a total of something. I can't even do math in my head today. Talked 81 times, I believe. So I've talked 81 times in chat in 5-minute intervals. So other people can check their points too right now. Sometimes people do that throughout the chat. So so here we'll start off the lecture right here. And let's put out some big news first. So here's our news of the day. We'll start with news of the day, then we'll start to lecture, and we'll start getting to some questions right here. The news of the day is the project is due when. I want to see it in the chat, 1,000,000 points in the chat. You got to tell me when the project is due. Now be careful. The project is due one day, when's it due, and when's it due for extra credit. Friday, Ashley, you get 10 million. You're first on right there. Ashley is right. Is it the 22nd is the extra credit day? So I would like to say, I see right there, Kaylee says for extra credit, due Wednesday for bonus. You guys know what's going on. You're putting in the chat. It's due Friday for regular credit, but get it in Wednesday for bonus. Remember Rick Sanchez. So we got to turn the project in early. We're going to turn the project in early. We're going to get our bonus. We're going to get the 107. That really helps out our grades. So Friday, the project is due for regular credit. Great job in the chat right there. And Wednesday, the project is due for extra credit. Now, yesterday, we did a huge help video. So did anyone use yesterday's video that we went through a lot of the problems? I also did it on last week. But anyone watch yesterday's video and pretty much get a lot of the project done? Yes, I got Peyton right there getting a lot of the project done. Melissa and Sarah and Molly. Yes, all these yeses in the chat. Awesome. So I will remember have office hours after this. So work on yesterday's video. Ask me questions. Come to office hours after class today at 5. So still have it pulled up. That's awesome. So I really appreciate all the hard work you guys are doing. I'll hang around, member, after the next class. Finished it. Awesome. I submitted it last Friday. It was due for extra. Nice. Oh. Sorry, Jake. Good job, Jake. Well, now you're done. You got time to relax. And so the last big announcement is we are working on the final. Please remember that tomorrow night we have an assignment due. Chapter 17 is a lot of jump work. It's a lot of equations. We have an assignment due on Friday, and we will be averaging your quizzes with your test. So by doing your quizzes, you're greatly helping your test grade. I like Adam says chapter 17 was fun. Million points, Adam, right there. So you're really helping your test grade a lot. There is one drop. So if you made a mistake, and there will be a Kahoot, we will definitely have a Kahoot. So we will do another Kahoot. We'll have another review. So there'll be a review. There'll be a Kahoot. We'll have lots of fun. Join in. We might even do it on Twitch. I'd love it if we could have like 200-300 people watching. Tell everybody, and we'll maybe do it on Twitch. We'll see. I'm always trying these new platforms, and I'm trying to improve my setup. Is the drop included in the test average? Yes, it is. So you could make a 0 on one and hundreds on the others. Great questions in Tyler Miller. Million points each question. The drop will be included when we average it in. So if you make 100 on all but one, you will have 100 average. So that is so key. Please try to make as high as grades as possible, and so start them early. Start looking at chapter 17 today, and it would be really bad to not do a single quiz, like to just not do it. That'd be worse than turning the project in late. Your top priority, I know it sounds crazy, is probably to do really well in the quizzes. Of course, you want to turn in the project. Turning it in early is even better. But your top priority right now, I would say, is to make as high of grades as possible on all the quizzes. Because if you have 100 quiz average, what is the lowest possible test grade you could make? Million points first person in the chat. If you have 100 quiz average, what is the lowest? Boom, Sean right there, million points, you got it. So you have put a boundary. You can't get less than a 50. So the final is mostly from the last unit and some questions from the others. It's everything chapter 14 and beyond. Chapter 14 beyond. Great answers in the chat. Million points, all those answers. I am starting to enjoy learning jump. Tracy, that's awesome. Well, so my question was, Tracy, to repeat, if you have 100 quiz average, you cannot make lower than a 50 average because, boom, Raneem, amazing job, 10 million points, Raneem right there. Raneem just wrote the equation. We'll be averaging them together. So we'll add your test average with your quiz average. So if you were to have 100 quiz average and made a 0 on the test, like you just didn't take it, which you shouldn't do that, you would make a 50. So you put a boundary. If you get a 60, you'd get an 80. So there you go. All you have to do is make a 60 on the test, which many of you made like 70s and 80s. If you make an 80, you make a 90. So Melissa, 10 million points right there. Great answers. I love it when you guys are helping each other in the chat. That's what we do here. So Jill, you're experiencing what the class is like. We have people asking questions. We have people answering questions. And I love you guys so much. I'm gonna pat my onliners because the next session is online, and they were trained from the start how to like interact in this, and you guys caught on so quickly. So you guys are a testament to we could take this and do this with any class, especially midway through the semester. But the other class, they're just as talkative, and it might be because there's more, but they started out online, so I see a lot of engagement between students. And so I love it when you guys tag each other. Million points right there. Tracy tagging Melissa saying, hey. Okay, online is best. I know, it's good to have friends. You guys are so positive. This is my last aside. It's a quick story. I had two students, Luke and Cullen. Does anyone know Luke? What is Luke's last name? It starts with a T, I believe. And Cullen. Does anyone know Luke and Cullen? I think they'll be fine with me telling them this story. But Luke and Cullen, is that? No, it's other Luke, right? Wait, Luke, are you here? Is this Luke? It's another Luke, right? So Luke and Colin were in my 2-1 class a year ago. Is that the right Luke? Is that Colin's friend Luke who started UT No? Am I right? Are you here in chat? Is this right? Yeah, that's Luke. Whoa, Luke is whoa. So Luke and Colin, if I'm correct when I tell this story, you guys were in the online class. Colin was at Disney doing his internship at Disney. Great internship, had a great time. And Luke and Colin met via that class, talking in the chat and everything. And we did it via Zoom back then, but we were still trying to make it as engaging as possible. And they then started UT No, and they met via an online class and just built a organization from it, student organization, and all that great stuff. So I'm really happy that we have this sort of people getting to know each other and interacting. That is Brian's 10 minutes of welcome to class and having fun. Oh, you're totally messing with me. I was like, yeah, I don't, because Luke was in the class a year ago. But yeah, totally. My memory works on a very visual format. So your name is Luke with a T and about the same right length of his. So now that we know what's going on, you're welcome, Raneem. Are you guys ready to learn the last chapter for the test? Is everyone ready for the last chapter on the test? Are you guys ready? Here we go. So, if you remember going way back to the very start of this right here, and I'm going to move myself over a little bit more. Going way back to the very start of this right here, we were doing categorical data. We were doing categorical data. And so now we're going to do this again. So the goal of this chapter right here will be to analyze 2 categorical variables. I want you to take a note right now, huge note, that the goal in this chapter is to analyze 2 categorical variables. 2 categorical variables will be analyzed in this chapter. Does that make sense? This is a huge part of this chapter. Previous chapters, I want to see it in the chat for 1,000,000 points. In a previous chapter, we analyzed 2 means. Jake, amazing, 10,000,000 points, Jake. So analyze 2 categorical variables. When we analyze 2 means, the 2 means were what? Now be careful, if you analyze 2 means, you have what 2 types of variables? Who knows in the chat, when we analyzed 2 means just last chapter, we had a this variable. You're basically right. Peyton, you're so close. Everyone's saying, oh, careful. Remember, 2 quantitative is QQ. So when we have 2 means, who knows for 10,000,000 points? 2 means is when one variable is, someone's going to say in the chat here in just a moment, one variable is quantitative and the other one is what? There you go, Sarah, 10,000,000 points right there. When you do 2 means, it's like analyzing the GPA of freshmen and seniors. Does that make sense? But then I want people in the chat, everyone gets 10,000,000 points if you answer this. I want you to put an example of a question that we could analyze right here. I'm going to give you an example question, then I want to see you in the chat give me example questions we could do. We could analyze people's favorite ice cream flavor by where they were born. So this is this chapter right here. We can analyze someone's favorite ice cream flavor by where they were born. So what is something else we could analyze? Like how about, let's see, your class level, favorite baseball team by birth month. Boom, you got it. That might not have an association, but Luke, 10,000,000 points, first person right there. Let's see another one in the chat. That could be anything. We could analyze I keep thinking Steve Born. We could analyze your hair color by your beard color. My beard, well, that's 2 categorical variable. What sport they like by what state they live in. Yes, and we might see a lot of like northern states might be more into hockey where it's colder. Favorite burger by hometown. Amazing, Isabel. You know we like talking about food here. Favorite pie by where they live. Eye color by favorite TV show. Amazing job. 10,000,000 points. Favorite movie by gender. Favorite footwear brand by gender. Favorite place to travel by the state you're born in. You understand how this works. If you are putting 2 categorical variables in the chat like Sydney just did with favorite NFL team by the state you were born in, which there probably would be an association. I want you to think about what you're saying right here. If there's an association, then knowing where someone was born would give you information about their favorite football team. If there's association between gender and favorite color, then knowing someone's gender would give you information about their favorite color. Favorite book by religion, if you know someone's religion, you might have information about their favorite book. Eye color by state they were born in. So that one might be where there's no association. And that's a great answer to Kara. 10 million points. Great job. And everyone else gets those 10 million. Because state you were born in is probably not significant in your eye color. Or maybe it is. We got to look at the data to find out. So you understand why we'd be using this here with two categorical variables. So what do you see right here? We're back to the Titanic. Always going back to the Titanic. We have here where people were located, first, second, third class and crew on the Titanic. And then we go here in their survival. Nice answer, Molly. So do you think, yes or no in the chat, I want to see the chat floods with yeses and nos, or which one is correct, that somebody's survival on the Titanic was kind of dependent or independent of their class? What do you think would be a good way to phrase it? Somebody's survival on the Titanic would depend. I think you guys are saying yes for depends. Yep. Someone's survival on the Titanic would depend on the class they're in. Nice job, Madison and Laura and Kara and everyone, and Molly and Julie and Sarah and Ashley. Great job. And what do we notice here? William, great job. And also Jackson right there. So what do we notice right here? You'll notice that this one does not line up with this one. We got to use different colors. We got to go with the black pen right here. This one does not line up with this one, nor does this line up with this. These don't line up. And this is the original way we looked at this to see if there was some sort of association going on right here. Look at the big gaps right here that create what we would call a discrepancy. That's what we call it in the upper level statistics. Exactly. And another thing, Adam, that really depended on was your age. Children were more likely to survive. Women were more likely to survive. And people in first, it's like you'd want to be a baby female in first class. That is your best chance of survival on the Titanic. So it all depended on a lot of factors right there. And you really don't want to be in crew. Now, what if someone said to you, on the Titanic, the most people who lived on the Titanic were the people in the crew. And Peyton, great question. The more they don't line up, the more dependent they are. The more they don't line up. Women and children first. And the more they don't line up, the more dependent they are. And I'll draw a picture in a second to make that very clear. So what if someone told you the most people who lived on the Titanic were in the crew? Is that true or false? The most people who lived on the Titanic were in the crew. Is that true or false? The most people who lived on the Titanic were in the crew. Oh, we stumped her. True. 10 million points right there, Ashley. You're like, it doesn't sound right, but that is true. That is very, very true. But then when we look at the proportion of crew that lived, if you compare the proportion right here, we're going to draw a big line in here. But if you compare the proportion, that's a divide line. Which of those do you think has a better proportion? It would be first class. First class has a way higher proportion of people who lived. So even though it's true, great job everybody in the chat. So, well, that's the thing. On the ship, the most people who lived were in the crew. Out of everyone on the ship, of all the different classes, the largest amount of people came from the crew who lived. But that's due to the crew's disproportionate size. You can see the crew has a disproportionate size. There was tons of crew on the ship. There was almost as much crew. It was like 40% crew and 60% passengers, it looks like, or 33-66. There was a lot more crew than everyone else. And because of that, the crew had a lot more people survive, but the crew had a much lower proportion. So largest class was crew, exactly right there. Kaylee, 10 million points. Amazing answers in the chat. So here's what I want to point out. I'm going to give everybody, we're not going to do neural nets today, I'm going to give everybody the opportunity to take test A or test B. So in scenario 1, here is test A and here is test B. So we'll draw it like this. And I'm going to put it like this for now. Now that's not perfectly lining up, and I'll explain what these lines mean here. So here is the fail rate, and here's the fail rate. Here's the pass rate, and here's the pass rate. So what we're asking is somebody passed or failed the exam. You want to use the black pen. So pass or fail, and if they took exam A or exam B. Does that make sense what I've drawn right here? It would be like maybe 20% of people failed exam A. Space pen is back. Luke knows what's going on right there. So we have 20% of people fail exam A and 21% of people fail exam B. Now, do you think your performance on the test, which is this right here, here's your performance on the test, do you think your performance is dependent on the exam you took? If you'll still want exam A. But maybe these differences are just due to what? These differences are small, and they might just be due to random chance. So I would say that maybe, I would say it's independent. Maybe these are just great job right there, Aneem. You know what's going on. We got some great answers in the chat. that these differences are due to random chance? Maybe. We can run the statistical test. They're not dependent. Sarah, 10 million points. Amazing job, Sarah. Let's make Sarah a mod here too. And remember, email me if you're not a mod, if I don't recognize your name, and we'll make you a mod. So here we go. Now how about scenario 2, which we're going to keep that same pass-fail axis. And so let's look at this right here. Here is scenario 2. In scenario 2, which exam would you like to take? People are already going to start answering in the chat again. So we've got scenario 2 over here, and we've got test A and test B. Which exam? They're already saying A. Lexi gets 10 million points saying A right there. Give me A. Luke says, I like it. Molly wants the hard test. Molly's going for B right there. We got a few that like that Molly gets 10 million. So we've got exam A. You notice the pass rate of exam A is much higher. So don't worry about it. It's I like it right here. I love all the chat. So Madison makes an amazing point. In example 2, somebody passing and failing the exam is dependent on what they took. If they took exam A, they were more likely to pass, and they took exam B, they were more likely to fail. Does this make sense? That this gap right here shows us more dependency. The probability of failing if you took exam B might be something like 80% failed, where the probability for this one right here, exam A, might be something like 10%. So you're way more likely to fail exam B than you are to fail exam A. That's awesome, Tracy. I wish I could always do the poll, the student. We got the vote options, but those take a moment to have set up, and a lot of my examples are on the fly. Oh no, that's crazy, Luke. So does everyone understand right here? Graphic A shows us that these two are probably independent. So these two are independent right here, and these two are not independent. This is a good example of when things are independent and things are not independent. So we have right here the example of not independent, because you would say my performance depends on it. Not independent is the same thing as saying your grade would depend on something. So remember, not independent means dependent. I just like saying not independent because it's the complement of independent. So the larger the difference, the more likely it is to be not independent. So Tracy right here, the larger the difference, the more likely it is to be not independent. Small differences on the far side, which I can't reach to, it's off my green screen. Small differences are likely to be by random chance, and then the two variables would be independent of each other. So the small differences in example 1 all the way over here are likely to mean that the two are independent, because those differences are likely by random chance. Like imagine if someone came to me and said, Brian, it's not fair. 20% of your students got A's and 21% of another professor got A's. So my students 20% got A's and 21% of another professor who teaches 201 got A's. I might say, well, those differences are rather small. They might just be by what? By random chance. Now, but imagine if only 2% of my students got A's and 90% of someone else's students got A's. That's a huge difference that would probably not occur by random chance. Very unlikely. We're talking about p-values here. Nice job, Isabella. 10 million points. You guys know I love random chance. That's all what statistics is about. So, impossible. But the p-value would be very, very tiny, Luke. 10 million points, Luke. We're going crazy with the points. Remember, come to class live, get all these points. So, how are we going to do this right here? So what we have going on right here is how we're going to write out our null and alternative. Now, we got to slow things down a bit here because this is a huge major note. Have your... You asked for it, Luke. You get it. We're having so much fun today. So here is a timestamp in this video. How to write your null and alternative. Writing your null and alternative is just going to be written as simply x is independent of y, and x is not independent of y. I will do this first one for you, and then you do the next one. You ready? You're going to practice writing your null and alternative here. Here's the first one. Somebody's survival on the Titanic is independent. I can't write. That's why I don't write too much. Someone's survival on the Titanic is independent of their class. Someone's survival on the Titanic is not independent of their class. Did everyone hear that right here? And all I'm doing is putting one word between them. Someone's survival on the Titanic is independent of their class. Someone's survival on the Titanic is not independent of their class. So now you have to solve for me. Remember, this is someone's grade, and if they pass, or someone's test, and if they pass or fail. So let me make this very clear right here. And let's put here everything we need to know. So you need to figure out what's going on here. So we have version A or B. So this could be version or test they took. So we'll call this version. Someone's version of the test. And whether they pass or fail. So we'll call this grade. So I want you right now to go ahead and write the null and alternative in the chat for practice. So go ahead and write the null and alternative using the trick I just showed you. Write the null or the alternative for 10 million points. Someone's grade on a test is independent of their class. Someone's grade on the test is not, yeah, and then this one is going to be version. Or class, give them class A, class B. Someone's grade is not independent of the exam, is independent of the exam. Nice job. Does this make sense? Right here, null. Someone's grade is independent of the version of the test. Someone's grade is not independent. Lexi and everyone, 10 million points. You are getting it. You are writing out the null and alternative for this right here by just adding in one word between these. You just need to put independent between them. So you just need to put independent and then do not independent. Someone's grade is not independent. Be careful. The null is that they're independent. Jayla, 10 million points. The null is that they're independent. So for the null, you could do it X or Y, it doesn't matter which way you would do first. Someone's grade is independent of their version. The null is someone's grade is independent of the version of the test they took. The alternative is someone's grade is not independent of the version they took. Nice job taking notes in the chat. Really good practice right there. Everyone's getting the 10 million points. We've gone crazy on the points. So we've got this right here, and we know how to do the null and alternative. That is step one of all the statistical tests we've been doing. So we know how to write our null and alternative. Guess what? It's time for conditions. Show everyone in the chat, show Jill today that you know how to do your conditions. When we do condition one, what do we do for condition one? Condition one. So if someone doesn't know how this class runs, there we go. Macy's already said it. Condition one is random, which means we randomly select it. Now there is the assumption condition. So everyone's saying random in the chat. Everyone knows condition one is random. And of course we have to honor you with some randomness. So we've got here condition one is random. So what does random mean? We need to randomly select this. The Titanic data probably doesn't pass that, so it's not really a perfect statistical test. But condition one means we randomly select the individuals, which condition two, what's condition two? What is condition two? And I like to do them in this order because we always use these right here. 10%. And the Titanic probably doesn't pass that either, which means that, nice job right there, Julian, less than 10%. So, and we just say 10%. You can say 10% on the test or notice the 10% condition, but we want to sample less than 10%. Sarah points out of the population. That's what's going on right here. We sample less than 10% of the population. Titanic really doesn't pass that because it's like a one-time scenario thing. So we don't pass the 10% condition. We don't pass the randomness condition. It's not a perfect test. It's got issues. A statistician one time said to me, it's not how many conditions you fail, it's how much those conditions matter. So he's like, yeah, you're going to probably fail some conditions here and there. And so next we have condition oh, Luke. Luke said pause, and Luke is right. We pause. Kara, 10 million points. Macy and everyone's right. We pause, and we pause on condition 3 because this is where we don't do it from like boom, boom. We don't just go through, and we don't go to condition 3 without thinking what kind of data we're dealing with. So we pause before condition 3 because we're dealing with two categorical variables. So the third one right here is always dependent on the data we're using. And the third condition will be count data. So we see right here, condition 3 is count data. And guess what? People always ask me, how do you know you meet condition 3? You meet condition 3 because it's two categorical variables. So everything everyone told me earlier about like favorite sports team and like where you live and your eye color and your hair color, all these things right here would pass because both variables are categorical. Does everyone understand how we pass the count data condition? It is count data. So this is the condition, count data condition, which is your third condition. It is count data if you have two categorical variables. You always pass it there. It's like once you see this graphic right here, if you see either of these graphics, you have count data because this is two categorical variables. So I see these graphics. I'm like, okay, we have count data. What is count data? Count data refers to these values right in here. These are the counts. Those are the counts of how many people are for each class. That's all it is, Isabella. Great clarified question for 10 million points. We're going crazy with the points today. You just need two categorical variables. That's it. To check this condition, I would simply say survival and class are both categorical variables. We're good. So we have two categorical variables. And so that's the thing, Raneem. Great question, Raneem. This one will not be success, failure, or nearly normal. This one, and I want you to think about this, Success failures for categorical. And here's the crazy thing. Here's the fourth condition. There's a fourth condition today. In success failure, how many successes and failures did you need? I'm giving the answer away. In success failure, how many successes and failures did you need for 10? You're right, Raneem, 10 million points right there. So now we're going to divide that by 2 because we're doing 2 variables, and we need at least 5 expected cell counts. Don't worry about calling this the sample size assumption. The words in red are the most important thing here. You see there's 4 conditions. That's what we'll use is these 4 conditions. Condition 1, random. We randomly collected the data. Condition 2, 10%. We've sampled less than 10% of the population. Condition 3, pause. Think about what you're doing. Think about the test you're doing. We're going to use count data for condition 3, and that just means both variables are categorical. We're good. Condition 4 is going to be expected cell count. Call it expected cell count frequency. I just call it expected cell count. And it says we need at least 5 expected cell counts. So that should really bring up a question right now, like, what are these expected cell count things? Well, let's do an example here to think about what expected cell counts are. Okay. So Brian is going to give a test. And let's say here, we're going to do Brian's online class and Brian's in-class students. So you guys are the in-class and we got the online. So we've got the online and we've got the in-class. So we've got online in-class and then we've got pass and we've got fail. So we've got the 2 different groups here. Does everyone understand this is 2 categorical variables? What condition does this pass because these are both categorical variables? I want to see in the chat, review question. And this wouldn't totally be random and it wouldn't pass 10%. But what condition did this pass because these are 2 categorical variables? 10 million points, who knows? Count data paid and you get it right there. Awesome job. And Lauren and Raneem and Anna, there we go. Nice job. So it's count data because these are both categorical. Now let's say we'll do a nice and easy question. Brian takes a sample of 100 students here and 100 students here. And we have 100 here who pass and 100 here who fail. Sorry, the test was really hard. I'm very sorry. So we gave out this really hard test right here. We'll change some colors to make this look easier. But we got pass and we've got fail. And I bet you already know how to do an expected count. I want you to look at this right now and I want you to tell me how many students from the online you would expect to pass. Sorry, I made a mistake down here. This is online and this is in class. How many students from the online would you expect to pass? Half of my students are online, half of my students are in class. Thank you, Sarah, right there. 10 million points, Sarah. 100%. Well, remember, you guys are the in class. Ah, but wait. Kara gets 20 million. We've gone crazy with extra credit, but Kara, you're all right. Because think about it, half my students are online, half my students are in class, half my students pass, and half my students fail. So I know it's crazy numbers. We could fix it and make it look a little bit nicer. How many, let's try this here. You ready? Now 90% of my students pass and 10% of my students fail. I was doing the percentage. So now 90% of my students pass and 20% of my students fail. How many online students, remember they're half my students, how many online students would you expect to fail now? How many online students would you expect to fail? How many online students? Steven, you're right. I want you to just keep in your head right now that only 10% of my students fail. Does everyone see that only 10% of my students are failing? Does that make sense? 10% of my students fail. So if these are independent, what percent of your online students would you expect to fail? I'd expect 10%. So we could change the numbers and do it all differently, but we're actually doing a pretty simple equation right here. Let's show the equation we're doing to get the expected. The equation we are doing is called, let me write here in black right here, row total times column total over grand total. And I did this with the other cost a little bit. This is equal to the expected. First person to write the equation in the chat that I'm using right here to figure out the number in this cell gets maxed out on extra credit. You get maxed out for the whole semester. You could stop talking. I don't encourage you to stop talking and stop learning. First person to write the equation with the numbers in it. So you have to identify, pause the video here later. Some people come back and watch these and pause the video. I want you to write the row total in here. I want you to write the column total, the grand total, and you should be able to find for the expected. Now that is the answer. Who's got it? You get maxed out. I'll say your name. You'll get it. Who's going to write the equation first? Who's got the equation? Then I'll show you the trick to solve it. And you probably need the grand total. Let me put the grand total here. I think Raneem did it. We might give it to Raneem and Lexi. Let's check their answers. Okay, I'm going to check Raneem and Lexi's answers. Raneem and Lexi were first 2. And so Raneem and Lexi, I'll do another one. So why not? First 5. Everyone up to Sean. Okay. There we go. Okay, we're done right now. Okay, Ahood got it. Okay, there we go. Mine was wrong. Oh, no. Okay, well, we'll give you another shot at max extra credit. Okay, so it's cut off right there. But let's check how to do this. You ready? Space pen to the rescue. If you're looking to solve the answer for a cell, you take the row total and you take the column total and you times it by each other and you divide. Does everyone see how I've written the equation right here where I've circled what I need? It's literally how it lines up. When you look at how it lines up into this cell, it's the numbers that line up into it. You've got a row total right there, you've got a column total, and then you take the grand total, which is everything. So row total is literally this row right here. We use a slightly different color. So you've got the row total, you've got the column total, and then you've got the grand total. Oh, that was horrible. My arrow there was bad. There's the column total, and then there's the grand total. Does that make sense right here, what we've done and how we've garnered this equation? Does everyone think they can solve for an expected and understand what is going on right here? Like if I said, write the equation. Let's try another equation right here. I want you now to solve the equation for the expected where I have 160 online students, 40 in-class students, and I'd like for you to tell me how many online students would you expect to pass? How many online students? I'm going to try to quick solve it in my head right here. 90%. So, okay, I've got the answer. Who here can solve this out? Did you max out for the semester? I think you might. Let me check. Sarah, you maxed out. You were in there, Sarah. You got it. Nice job, Sarah. So what is the expected now? Who can solve this equation for the expected and put it in chat? We'll max out 3 more people. Molly got it first. Molly is maxed out. 2 more people. Peyton, and then one last person, and Ashley. There we go. And Isabel wrote the full equation, so I'm maxing out Isabel too. Isabel wrote the full equation, so she definitely earned it. Definitely put the extra time in there. I like it. Great job. Everyone else is getting 10 million points. We'll try to do a few more max out on extra credits. You guys are doing excellent. You need to circle your numbers and then times them together and divide by that. Does everyone understand how to find the expected? No, I quick solved it in my head. I did the following. To solve it, which this is not what I suggest you do, but here's how I solved it in my head rather than multiplying, is I said 90% of my students pass the test. What percent of my online students, if these are independent, what percent of my online students would I expect to pass? If these are independent, like someone being online or in class, then what percent of my online students would I expect to pass? 90%, Sean. Amazing work. So what is 90% of 160? It is 144. And I subtracted 10% off of that to get that because 10% is 16. 160 minus 16 is 144. And that's how I checked the number into my head to know it was 144 when you guys were putting it in. So don't worry. You don't have to solve things in your head. And we do give you the equations on the test. But this is just telling you what you would expect by random chance given they are independent. Does that make sense to everybody right here? What we just solved for is, hey, if these two things are independent, what would we expect? And there's that key word right there. What would we expect if there's nothing going on? And I would expect 90% of my online students to pass, just like I'd expect 90% of my in-class students to pass. You know what's so cool about this? One last trick is if you get the answer here of 144, you can actually solve. That's a horrible 144. We'll try again. That's better. 16%, and then you would expect right here 4, and you'd expect right here 36. So if you notice, and this will come back later, if you get one answer right here, you actually get all the numbers. And I'm alluding to a concept which we'll be talking about very soon again. So all of these expecteds must add up to the totals that they have respectively right there. Can you repeat what E is? E, great question, is expected. It is what we would expect by random chance if these two variables are not associated. We'll try and do. So E is what we would expect via random chance if these two variables are not associated. So if there's nothing going on between someone being online or in class, I would expect 144 of my students to pass online, and I'd expect 36 to pass. And think, what is 36%, or what is 36 out of 40? 36 out of 40 is what percent of 40? 36 out of 40 is what percent out of 40? 36 out of 40 is what percent of 40? It's just the same. You got it, Tracy, right there. 10 million points, Tracy. You're right. It's 90%. So it's 90% right there, which is what we expect. We expect 90%. And once again, you don't need to think of it that way. You can just solve it via the equation, row total times column total over grand total. So if you solve this equation right here, you will get 36. Solving this equation equals out to 36. Great job on the expected. We know how to solve it. If that's on the test, you should be like, get that question perfectly right. Great stuff. That's what the expecteds are. And they just tell us what we would expect. Here's all the equation stuff. There's the, whoa, I'm just going to hit the microphone. There's all the equations. Did I miss a question, Tracy? Repeat it if I missed it. And so now, here's where things get a little bit crazy in this lecture. Not that they've already not gotten crazy. But with this right here, we want to somehow see how far our estimates were off. But I need 2 students in class right here I'm going to give a job to. You ready? 2 students are going to get a job. Can you explain how to use the formula again? Yes. So you have to take the row total times the column total over the grand total. So you do the row total times the column total over the grand total, and you'll get an expected for each one of these. So in each one of these, I have to rewind time here, this expected right here is obtained via this number times this number over this number. Do you see how that is the respective row total and column total over the grand total? So that's the equation I've written on the screen for that one. And then to do the equation for like something like this one right here, you'd have to take its respective row total over its expected times its respective column total. I can't say respective. And then you do the grand total right here. That makes sense right there, Lexi? Awesome. This formula will be given on the exam, row total times column total over grand total. And you can see each one gets its own unique formula. This bottom left one would be 160 times 20 over 200 right there. And that would solve to this one right here, because that's where it kind of meets up when you zone in on it. And hopefully that makes sense. And always remember to ask a question if you got stuck on it. So I'm seeing that the boxes, which rows, which column, total spaces for sure. Did this help make sense of it, Tracy, right here? Does this make sense of it? How we know how to solve the equation? Oh, you were doing different. Oh, that good. Yeah. And if you get it right, that's what's all that matters. And you will get the equations on the test. Nice work there, Tracy. So I need 2 people in class. Who wants a job? You guys know we always do examples. You get a job. And so who wants to be the first person to get the job in class? Let's see here. We got Sydney, and who else? We need one more person. Tell me points. And Melissa. Okay. So Sydney, I tell you that I need help with, let's say, grading papers. You're now a graduate student. Both Melissa and Sydney are graduate students, so they can grade papers for 201 students. And I say, okay, we need help grading papers. I will pay you $10 an hour. It's not that bad. I mean, grading papers, you're just sitting around, you're grading. You can have on music, you can have on TV shows. So, Luke, sorry. We'll hire you next, Luke. So not that bad. But Sydney, when I go to pay you, I pay you $110 an hour. So Sydney, I want you to tell me, what did you expect to get paid, and what did you observe getting paid? What did you expect getting paid, and what did you observe getting paid? You expected this, and you observed this. I know, right? Molly's like, holy mackerel. Go on strike. Oh, no. So we have here that you expected $10, you observed, and there we go. We've got the expected and we've got the observed. So that is only a difference of $100, right? I say only. I mean, in pay scale, if that was like a car difference, that'd be very tiny. Exactly. Rick and Morty on. Best thing ever. And so now, I think it was Melissa was our other person. Melissa, I need you to work the whole semester to grade. And so this is a lot of time. It's probably going to be like 100 hours. And so, Melissa, I say I'm going to pay you $1,000 for like 100 hours worth of grading. It's just like 2.5 weeks, $1,000. You're like, okay. So you might be like, $10 an hour. I mean, that's not the best, but you're like, get to grade, get to watch some Rick and Morty. And I know what Brian, like how he helped out other people, like Sydney only expected $10 and got 110. So Melissa expects $1,000 right now for a whole semester of grading, right? She's getting paid by the semester. And then Melissa get ready for this. You ready? Everyone, who's ready for this? You guys say you're ready in the chat. I need to see some raise in the chat. Who's ready for this right here? You ready? No one's ready? They're ready. Tracy's ready. Melissa gets paid. Instead of $1,000, she gets paid $1,100. Melissa, how do you feel about the $1,100? It looks like everyone's ready in the chat. $1,100. How do you feel about that, Melissa? Wow. So Melissa's getting paid $11 an hour. I'm ready. Some SpongeBob right there. So, how does Melissa feel about that? Does Melissa feel like she got the same sort of, just an extra hundred? Which I say just an extra $100, but if. But think about this: who was more excited? They both only saw a difference of $100. Who do you think would be more excited, Sydney or Melissa? Both of them only see a difference of $100. Oh no! So both of them only see a difference of $100. Only both of them see a difference of $100. Sydney was more excited. So you know what we need to do here with this example? What you heard is what we need to do. This is why we get the very famous equation observed minus expected squared over expected. Because tell me, what would both of these equations solve out to if you solve out for Melissa and Sydney? What would both of their equations solve out to? And you can put it in the chat as a squared, or I'm trying to think. Okay, I know the answer to it. What would both of these, you bet, Calzone, so good to have you here. Calzone's the fan favorite. We're talking about the chi-squared test of independence. So Melissa saw a difference of $100. Sydney saw a difference of $100. What would it be? I would feel good. Money is money. You're so awesome, Melissa. So right here, what would both of their equations solve out to right there? If you solve out for Melissa and Sydney, what would they both solve out for just their difference squared? Does anyone know? Remember, Sydney expected $10, got 110. Melissa expected 1,000, got 1,100. So what would both of their equations solve out for? Oh, great question right here. Because it can be negative. This will always put it in positive units. So it'll always be positive. And it'll be 100 squared. You guys are all right there. It's 10,000. So it'd be 100 squared or 10,000. So we square it so it's no longer negative. It's always positive differences. This is why the chi-squared values are always positive, because what it would be is we'll get, if we add them together, they would equal up to 0. So I'll talk more about this in a second. Great question, Luke. 10 million points. Great question. But watch this. I want you to think about this. We'll have to add in a white pen right here. So let's add in a white pen and do the following. Let's solve out. No. There we go. So let's solve out the following and solve out for, who is it? We'll solve out for Sydney's chi-squared first. So we need Sydney's chi-squared. Sydney expected $10 and got 110. And she, down here on the bottom, has her expected. Can anyone solve this right here? Sydney expected, truthfully, it doesn't matter which way you solve them. Let me fix this up because it's observed minus expected. She observed 110, and she expected $10, and she expected 10. So that is 100 squared over 10. Does everyone see that right there? That's 100 squared over 10. Now, when we do the other one, let's solve the other one right there. 1,000. Nice job, Sydney, right there. So 10 million points, all those answers. Now, when we do, we have observed on this one right here is this. And then expected is this. So you expected 1,000. She observed that. And then we put expected down here. There we go. So now, solve out this one, and what do you get? This one is much smaller, and it's a much smaller chi-squared. Now, it's still pretty large, but we get a much smaller chi-squared. And the chi-squared is a standardized way. Oh, yeah, and great job. Good to see you, Ahud, right here. It'll be 10. So this won't be done as a percent. It'll be done as a number right there. That is the chi-squared value right here. So that is the chi-squared value. So remember, Sydney had one that I think was 10,000. And Melissa's was 10. So who was more shocked? It would definitely be the person who expected to make $10 and got paid 110 an hour. And still, the person like Melissa was very happy. But if you look at the relative standardization of this, it's going to be that Sydney was way more excited than Melissa. Melissa's still excited. She didn't expect this. This was very unexpected. But Sydney's excitement is way more. Does this make sense that all we're doing right here, let's look at the equation. The equation is literally the following. So we got to erase now. This equation, what it seeks to do is take something up here, and I will max out someone on extra credit if they can tell us. All this equation is taking a difference. Oh, no, I don't. You got to say it for me now. It's just looking at something up here. It's taking a what and doing what to that. All of these equations that we keep doing. First person. I had said part of it. First person. It's just that something. Yes, Peyton, you are right. Peyton, you are totally right. And Jayla, Peyton and Jayla, first two, I'm giving it to you two right there. So is taking a difference. You get max extra credit. Great job. It's standardizing a difference. Does that make sense? It's taking a difference and standardizing it. Um, exactly. And Melissa, you're exactly right. Because what she expected and because what she observed, and then we standardized by what she expected. Excellent job right there. Because her expected was so much smaller than yours, we're standardizing the difference by what we expect. So it's like, imagine if you go to buy a Ferrari and the Ferrari they say costs $200,000, but then when you go to buy it, it costs $210,000. You're like, well, wait a minute. And they're like, well, that's not that big of a difference. But if you go to buy like a used car and you expect it to cost 5,000 and then it costs 15,000, that's the same difference. But which of those would you be more shocked by? The Ferrari costing 200,000 that now costs 2010, or the used car that costs 5,000 that now costs 15,000? Peyton, you're exactly right, and Tracy, you're right too. The used car would be more shocking, and this is just like a z-score. It's a test statistic. This is the chi-squared. It's a standardized unit of measurement to have us observe differences right here. If we write in a z-score equation, you'll see the similarities. We would have observed minus this right here, and we do p naught, q naught over n. I have to write very small right here, over n square root. So this is a z-score, and you'll notice the top part is just a difference. There's the difference. And the bottom part is how we standardize it right here. We can write in one more equation. Let's put it off to the side here. We've got our sample mean minus our hypothesized mean. Sorry, my handwriting's so bad over the standard error. It's the worst handwriting of the day. So up here you have a difference between the two values. It's just a difference. And then we have this, and we have this, and we have all the same things right there. So one thing I want to point out right here, and let me do a little erasing, is we see that all of these right here, this solves to a t, this solves to a chi-squared, and that solves to a z. So these are your three test statistics in the class. This is a review now. Your three test statistics are the t, the z, and the chi-squared, which we can use as standardized units of measurement. So you see right here on the far side, the one proportion z-test. You see on the very far side, a one sample mean test, and then you see the chi-squared. That is a chi-squared right there. It's the Greek symbol, the chi right here. I do a little loopy tail on it. And chi-squared. Nice job, Lexi. 10 million points, Lexi. Thank you for helping everyone on the chat. That is the chi-squared right here, which is the whole point of this. And so we've got one last thing, and we're basically done with everything we need to know about the theory of this chapter, and we'll start solving two problems here. So what are we going to do? Is if you notice, we're going to take all of the cell chi-squareds and sum them up. So there you go. Nice job, Hayden. So we've got all of the cell chi-squareds that we find solve for the Pearson chi-squared test statistic. So all of the cell chi-squareds will solve for the Pearson chi-squared test statistic, and we simply add them up. So let's take a look at this right here. Oh, we put in different distributions. Now, one thing I want to point out, let me show you this. The chi-squared is its own crazy, crazy thing. So let's pull up statdistributions.com. And let's take a look at it right here. So statdistributions.com, we got on the screen, and let's do it. Okay, so with statdistributions.com, we're on the chi-squared, and the chi-squared has with it degrees of freedom. Here's a chi-squared of 1, 2, 3, 4, 5, 6, 7, 8, 9. But watch this. Watch this. This is kind of weird. 20. What is this starting to look like to people? It's starting to look more and more what? It's starting to look more and more this. Who knows what this curve is starting to look more and more like the normal. And so don't think that the chi-squared is the normal curve, because does this curve right here look at all normal? I mean, it's very right skewed. You guys got it. It starts to look normal. So it's almost, I don't have a Mr. T saying with this one. Nice job in the chat. Million points, all those answers. This starts to look more normal with more degrees of freedom. And there's some calculations I can do in my head, which I won't do in the class, but there's ways you can memorize how the chi-squared works and looks and manipulate it. So good stuff. You understand that the chi-squared is just another distribution, and we have to know the degrees of freedom. We have to know the degrees of freedom for the chi-squared. What is the other distribution? First person says it gets maxed out. What is the other distribution we have to know the degrees of freedom? Only the first person. You have to know the degrees of freedom for the other distribution known as the what? What other distribution do you also have to know the degrees of freedom on? Yes, right there, Tracy, you're maxed out the T distribution. You got it. Only first person we said this time. Tracy, you got it. You know it. The T-scores, you also have to know degrees of freedom. And the chi-squared, you have to know degrees of freedom. Normal has no degrees of freedom. T, chi-squared, and F, which we're not going to talk about today, but the F would also have degrees of freedom. It has 2 sets of degrees of freedom. So cool. It's the ratio of 2 chi-squareds. So we won't talk about F today, though. That's a whole nother lecture for a whole nother day and a whole nother class. So you guys know I love talking about the advanced stuff. It's so much fun. Okay. And so here we go right here. How do we get these degrees of freedom? It's rows minus 1 times columns minus 1. Does everyone see this formula for degrees of freedom? It's rows minus 1 times columns minus 1. This will be given to you on the test, but better yet, I'll show you how to solve it. Do you remember earlier that I actually solved the degrees of freedom right here? I want you to say this with me. You got to put in the chat for a million points. This is a 2 by 2. We can reduce it down to a 1 times 1, which is 1 degree of freedom. Did everyone see what I did? This is a 2 by 2. And then to find the degrees of freedom, we just drop a finger and we say 1 times 1. So this is a 2 by 2, which means we turn it into a 1 by 1, and then we have 1 degree of freedom. Put in the chat for a million points. Practice it right now. This is a 2 by 2. So that means it turns into a 1 by 1. Luke, great job right there. And Kaylee, you are practicing it. And then so when you reduce it to the 1 by 1, you get 1 degree of freedom. Nice job there, Sydney. Let's say Brian comes up with a 3 by 4. So Brian has a 3 by 4 right here. How many degrees of freedom? First person gets maxed out to tell me the degrees of freedom on this. First person to tell me the degrees of freedom, here, I'll write it here, and I'll make sure we review it. Lauren is the first person. Nice job right there. We'll do another one. Walker, you're so close, but Lauren got it. And let's do this. It's 6 degrees of freedom on this. Do the trick right here. You ready? We have to do rows minus 1. So how many rows are there? There are 3 rows. And then we have to see how many columns there are. And we'll do different colors on these. So there are 3 rows and 4 columns. So the formula is rows minus 1 times columns minus 1. So once again, nice job, Kaylee, right there. I know you're so close, Walker. We'll do another one. Don't worry, you guys are doing great. So we have 3 by 4. So everyone see I'm holding up 3 or 4. Now drop your fingers. You get 2 times 3. And it doesn't matter which way you do it. Math goes either way right there. So this right here is rows times 1 times columns minus 1. And remember, this is a 4 by 3. Okay, one more quick extra credit one. We're going to do this one in our heads. Brian has 101 rows and 3 columns. What are the degrees of freedom? 101 rows and 3 columns. First person, I'm going to say your name out loud. Who's got it? 101 rows and 3 columns. Sean right there gets the max. You're right. Sean said 200. And so Sean did the formula in his head right here. The reason I chose, nice job. Everyone else gets a million points. Nice job. Sean did the formula. Let's write here 101 rows. So we have 101, and then the other one, and that'd be minus 1. And then I said 3 was the other one. So there we go right there. It would be 100 times 2. So you just have to drop each number by 1. Does that make sense, everybody? It's rows minus 1 times columns minus 1. Excellent work right here. Great job. And so let's hop back. Let me record that. Do you guys hear? Does it say insanity when I say this? Here we go. Insanity. I think I see it. I don't know if it said insanity or not. I recorded that last class. Did it say insanity? Oh, it did. Good. See, watch. Just for a little bit of fun. This is our 10 seconds of randomness. We can go back. And then I can, anytime now, I can just go like back. Play it right there. I have it way off to the side, so I need to fix that. Yeah, I know. Oh, with the echo? Back. That's our 10-second break right there in class. So lots of fun with it. Oh, and email me about the max out extra credit. Awesome. We're gonna get to solving some problems right now. We got our 1-minute break. Let's solve some problems right here. Okay. So we know how to write our null and our alternative. We just put independent between them. And we're going to use all this to find a p-value here. So let's run through 2 or 3 different problems right here for the last 15 minutes of class. So we're going to take the chi-squared, graph it on the distribution, and get the p-value. That is our last step to the 4 steps of hypothesis testing, which I want to make something very, very clear at the end of this. I'm going to put a link to a video series that I made, and I want you to watch that and learn it. And I might just bring it up here in a moment, but check that out here in a moment. We'll go to the applet here to solve and do the equation. So you'll just solve on an applet like I was just doing a moment ago. So once we get this chi-squared value, we will literally go in with the chi-squared value and plot it in here, and it'll give us the p-value. Remember, we've reviewed that when we do a test, we get the t-statistic, and it gives us the p-value. When we do a test, it gives us the t, and it gets us the p-value. This time we do the test, and we get the chi-squared, and it gives us the p-value. And we will be doing that after class, Melissa. So come back by after class, and we will be doing that after class. Great stuff right there. And so now, let's take a look at our last few examples in the notes. Here we are. The sigma means that you're adding up all the cell chi-squared. So you'll see that right here, Sean. Great question. You'll only use a right-tailed test because we're only looking at something that's as extreme or more extreme than the differences we observe. So it'll always be a right-tailed test on the chi-squared. Always right-tailed test on the chi-squared. And you'll see right here the sigma happening. Now remember, do you remember our trick? Maintenance is independence of the type of car someone has. Maintenance is not independent of the type of car someone has. So all you have to do is do that trick from earlier to start this problem out and put your word independent between them. Maintenance is independent of the type of car someone has. Maintenance is not independent of the type of car someone has. At 5, we'll be doing homework assignments. And then we go right here. So what do we do first? We solve out for all of the expected values. Now, this is a lot of work. Usually we do this in jump. Nice job right there. And so this one would actually be a 2 by 3. And then how many degrees of freedom does this have? Excuse me. How many degrees of freedom does this have, which will tell us the chi-squared distribution we are using. So first person gets maxed out. How many degrees of freedom? Who knows? Walker, you got it this time. Walker right there. Sydney, I've been seeing you in second so much. Sydney, you also get also. Sydney, you've been right there in second every time. So there we go. Great job. And we'll do 2 more max out extra credits. I know, right? So we'll try to max out 2 more people. Get ready for the questions. These are our last 2 lectures, and this is a big one. So how did they find that this is 2 degrees of freedom? Well, one thing you can do is you can actually delete the rows and columns. This is another trick I sometimes do. Can anyone see the 2 degrees of freedom right now that are right here? These are the 2 cells, and it's technically any 2 cells like that, but I'm trying to show that there are 2 degrees of freedom by deleting. Oh no, I'm so sorry to hear that, Kara. So we have right here the degrees of freedom. Or you can rewind. That's one of the great things is you can rewind live and you can watch it later. So we have right here the degrees of freedom are 2 for this. Very important to know for this. We solved everything down here. If you notice that this formula right here is merely row total times column total over grand total. So we have row total times column total over grand total. Row total times column total over grand total is how we're getting these numbers right here. That is the equations being used. Once we get the expecteds, another max out thing right here. We go and we get the expecteds, and then we use the expecteds to get all the cell what's. Maxing you out on extra credit. First person to tell me. Who knows? Only the first person's time. Use all the expecteds to get the what's next. So step 1 is get your expecteds. Step 2, no one's said it yet. No one's gotten it. Once we get our expecteds, we'll find all of the what's. Well, we already have the counts. No one said it yet. You'll go from your expecteds to your what next. Once you have your expecteds, that's showing how to get the expecteds. Answer's on screen now. Who knows? Once you go from, use your observed to get your expecteds, use your expecteds to get all your cell. Julian was first there. I think Julian was first. Julian gets the chi-squareds right there. And Walker said it fully, but Julian got it first. So Julian is right. All the cell chi-squareds. Does that make sense? These are all cell chi-squareds. This is the observed for this cell, the expected for this cell over the expected. Observed minus expected squared over expected. We get all the cell chi-squareds. So write this down. You ready? Step 1 is to have your observed. Step 2 is to have your expecteds. So you find, yep, you got maxed out, Jillian. Great job. So you have your observed, 1. You use your observed to get your expecteds. So you see we then found our expected, step 2. And then we use our expecteds to get our cell chi-squareds, step 3. And then the 4th step is to do what to all the cell chi-squareds? And this is what I think Sean was asking about earlier. What are we going to do to all the cell chi-squareds once we get each cell chi-squared, which was found via the formula observed minus expected squared. Observed minus expected squared. We're going to sum them up. You are totally right. So each one of these was this formula right here. But then we're going to take all of these and sum them up. Sarah, you are right. Nice job, Sarah, right there. We're going to sum them up. We're literally going to take all of these and sum them up. Does that make sense? We're just going to take all of these right here. And this is the formula Sean was asking about earlier, where we take all of the cell chi-squareds and we get what is called the Pearson chi-squared test statistic. Now be careful. This is a chi-squared, which is kind of like a T, kind of like a Z. They're all standardized differences. The Pearson chi-squared test statistic, which I'm pointing to right here, which is found via this method. There's other chi-squareds. We're not going to talk about them. But the Pearson chi-squared test statistic is found by summing up all the cell chi-squareds. How do you get the cell chi-squareds? You have to do the observed minus expected squared. And then once you get this, you have to know the what for this. You have to know what for every chi-squared. It's what. Max out. Who's first? We have to know the what for this. You have to know the what for this. For every chi-squared, you must know its what's. Walker and then Sarah. Sarah, if you're not maxed out, you're maxed out. Let's do one more. Madison, you're maxed out right there. So we got it. Man, I want to max out every... Don't worry, I'm going to be really nice with the extra credit. I'm going to be super nice. If you're reading what I'm saying, I'm going to be as nice as I can with the extra credit. I just see so many of the same names in chat, and I'm so proud of you, like Miles and Jada and Lexi. I'm so proud of you guys right here, being so interactive. Thank you so much. This is our last big lecture. Come to next class. You were right. Then you're maxed out. And I missed it. Awesome. Nice job right there. So how many degrees of freedom are there on this? There is 2. Don't worry. I'm going to be super nice on the extra credit. If you're sad, don't worry. I'll be super nice on the extra credit. Brian will be very, very nice. So it's been a crazy semester, and I'll be as nice as I can be to everybody on the extra credit. I like going to these applets right here. We see 2 with the chi-squared value. So we're going to go over to this applet. We're going to put in our degrees of freedom. Then we're going to put in the value right here. What is going on? Something weird's going on. Oh, haha. There we go. I put in the wrong values. You're welcome, Isabel. So, Isabel. Sorry. You guys crack me up in chat. So I have here 2 degrees of freedom. I have my p-value over here, and I have my chi-squared right behind my microphone. I'm totally blocking the chi-squared. There's the chi-squared and the p-value. Let's just jump out of the way here. I can't do it. The microphone's just going to block it. No, we can fix that. We can scroll down. Now my head's blocking it. There is the p-value for the test right there, and we see that this is going to have us reject the null. So I want us to think about this here. We've got one more example after this, and we'll finish right on time. We start on time, we end on time. So when you look at this right here, and you see this p-value, and I want you to say this in the chat. The Pearson has your p-value. Here's the chi-squared we got by summing everything up. Remember, the chi-squared was the sum of all the cell chi-squareds, and they're all right-tailed because we're always looking for a difference that's more extreme than the difference we observed. So we always do a right-tailed test because we square the differences. So we're looking for discrepancies more extreme than what we observed, which that would always be a discrepancy greater than. The smallest possible discrepancy, great questions, Luke. The smallest possible discrepancies would be 0. I don't know why it's not showing up on the chi-squared graphic. It should show me a 0 on here. It just doesn't want to. I think they changed their applet because it used to show 0. But 0 is the smallest discrepancy you could see. So 0 is where the chi-squared would start at, and then it goes all the way out, and you could just keep getting bigger and bigger and bigger discrepancies. So if you were to get a chi-squared of 0, then your mosaic plot would look just like this. Is when you get a chi-squared of 0. Can someone tell me what the discrepancies are in this? In this mosaic plot, the discrepancies are literally what? Because I lined it up perfectly. The discrepancies here are what? The discrepancies are what between the groups? They're 0. And that would make your p-value what? Your p-value would be 1 because these differences are super likely by random chance. There's no differences we observe. Any differences between the 2 groups in that mosaic plot I just did would simply be by random chance. So the p-value here is 1, and the degrees of freedom would technically be 1 for this. If you're wondering why there's 1 degree of freedom, well, it's a 2 by 2. And if it's a 2 by 2, 1 times 1 is 1 degree of freedom. You can do my other trick where you delete off an L out of it, and you'll see there's only one area where that's the 1 right there. So 2 by 2. That's a huge review right there. I know I did that really quickly. A lot of really great in-depth questions in the chat. So thank you for those in-depth questions right here. Good, Kara. That's awesome. And so now we reject the null if the p-value is low, all that good stuff. I want us to interpret what's going on here. We rejected the null that someone's car type is independent of their maintenance that they get. We reject the null that someone's car type is independent of the maintenance they get. So with that in mind, which cars do you think are more likely to only get regular maintenance? First person maxed out, who gets it? Which cars are more likely to only get regular maintenance? Because we're saying that the car type is dependent. Toyota right there. Tracy, you are maxed out. Nice job right there. Exactly. Yoda, I like that job right there. So Tracy's maxed out. Man, it's just like, I will be super nice on this credit. I just keep seeing so many names, and I appreciate you guys. Everyone else gets 10 million points. I promise I'm going to be super nice. If you've been, the likelihood of you getting maxed out on extra credit, if you've been here while we've been online and participating, Sarah, you're awesome, then you're more likely to be, I will be super nice. Remember, I only do it up to 2 points, so it's basically like the difference between a B plus and an A minus, but that's very helpful. So I will be as nice as possible. Here we see the differences. This slide just literally details the differences between each group. We see given something is a Toyota, Toyota's 14.6% were expected to have regular and unexpected maintenance. And then we see here, given something is a Toyota right here. So you'd have to go to the row percentage for Toyota, and you'd have to see across here, there's the row percentages that are these associated percentages here. Because this is given something is a Toyota, and this is literally going back to a conditional distributions. Give you all the points. Here we got the last two slides right here. Let's do it. It's just one more example, like I was saying. We get to end with Swedish fish and prostate cancer. Amazing stuff right here. Awesome. Don't screen grab this for the online. Like, what are they teaching those students? Okay, so I want you guys, we'll just call it cancer right here. I want you guys to write out the null and alternative hypothesis, and we'll do that after class right here. I want you guys to write out the null and alternative hypothesis for this right here. The null and alternative hypothesis. So remember, do your trick. First thing right here, write out your null and alternative. Who can do the trick? First person gets maxed out. Who can do the trick right here? I want to see it in the chat. I want you to pause the video and practice. Who's got it? Who has got the fish consumption independent of prostate? Get Lexi right there. Perfect job, Lexi. You earned it. You're totally right. You just put the independent between them. You know how to look at this and read it, and you got it. Snay, you got it. Sunny right there. Cancer is independent of fish. Exactly. I'll take that right there. So you got it also. Yes. Amazing job. You guys are doing such a great job. And dependent, yes. Got the alternative in there. Amazing job. Great job on these nulls and alternative. Jada, I've seen your name so many times today. Jada, I'm maxing you out. Let me see here. Next person who answers gets maxed out too. Right there. Miles gets maxed out too. Miles, you get maxed out too. So amazing job right here. And if you're wondering, there might be a delay, but there we go. And so Madison was between them. John and Madison, just so people wasn't thinking I was cheating right there. John and Madison also get maxed out. Okay, we're done maxing people out. You ready? Lexi, you are maxed. You are maxed out. Great job. We got 3 more minutes. Let's finish this off. And I really appreciate all this interactivity. Remember, that's what makes an online class. I want you guys to take this excitement you've got and bring it to your other classes. We'll max out some more people, I promise. Come to next class if you're not maxed out. If you're not maxed out, and still come to next class. We're ending on a high note right here. Take this energy, whatever your next class is, and bring it to the next class. Okay, we need to check the count data condition. Are both of these variables categorical? Yes, it's count data. Remember that? Both variables are categorical, and it's a contingency table, so it has to be categorical. It has to be count data. Random. Okay, did we randomly select these people? Maybe, I don't know. I don't know the answer to that one. Is this less than 10% of all Swedish men? I'd assume that 6,272 is less than 10% of all Swedish men. Expected cell count. This is one we actually have to check right here. Oh, thank you, Jada. You guys are awesome. This one we actually have to check. So let's take this. And I'm going to show you a trick right here. So here we go, and we need to look at the expected. Please look at this. These graphics could be on your final. All of these here are expecteds. But here's a trick. The trick to know if we pass the expected is we need at least 5 expected for all of these. All of these need to be greater than 5. So I could look at this. We'll put in a green pen right here. And I could say this is greater than 5. That's greater than 5. Or, so I could check them all. Or I could look at the smallest one. The smallest one would be located here and here. And so I can solve this equation right here. 124 times 466 over 6272, and that will equal that number right there. That'll equal 9.21. So that equals 9.21, and so we get right here the expected cell count is larger than a 5 for the smallest. So we have now figured out that the smallest one is bigger than 5, and so we do pass. The smallest one is bigger than 5, and we do pass. And I'll finish up this example right here, and then we'll take, and since that's greater than 5, they all have to be greater than 5, but Anna, great question. If the smallest one is greater than 5, they're all greater than 5. It's like saying, let's see if everyone is over 18, and so then if the youngest person's 19, then everybody is older. So that's what we'd have right there. Quick math and great stuff right there. Ronald, good to see you in the chat. And last but not least, we get here, we need to find the chi-squared test statistic. Now, the chi-squared test statistic is found by adding it up. Great question. Why are there 2 blanks? Because sometimes we do that on the test and we have you find the answers. So sometimes on the test, we will blank these out and have you find them. Rondell, I think you were in your last semester, and it's so good to see you back. So we love seeing people in the chat. We love having visitors. And I'm going to put something in the chat at the end. I'm going to ask you guys for a favor. So if you add together all of these cell chi-squareds here, all of these values right here, if you add them all together, you will get the following value. Last person maxed out on extra credit. We're going to go for 2 more minutes. What value, if I add up all these values right here, what do all of these values add up to? You have to look at this slide right here. What do all of those values add up to? What do all of those values add up to? What do all of those values add up to? Oh, they won't add up to 1. These are all the cell chi-squareds. They won't add up to 1. Who knows what all those... It's on the slide here. All those values add up to the chi-squared. There we go. Sarah, you are right. Sarah, you might be maxed out already. Did anyone else get it? We'll see one more person here, because Sarah, I think we've already maxed you out. Macy gets it. Macy is maxed out too. That is the answer right there. That is the sum of all of these values right there. All of these values are cell chi-squareds. The sum of all the cell chi-squareds is this value right here. So now we would go to our applet. I need someone to tell me the degrees of freedom for this. We'll be very careful. Last 2 questions of the day. First person gets maxed out on extra credit. What are the degrees of freedom for this right here? Be very careful. What are the degrees of freedom for this? I see this, Lauren, amazing job. You're maxed out. It is 3. The reason is because this is a 4x2. It's a 4x2. There is 4 here. Be careful. Don't use the sum columns. It's a 4x2. Be careful. A lot of people will make a mistake and count the total columns. And we'll do office hours at 5. You got it. So there are going to be 3 degrees of freedom. Great job on that. You guys learned that very well today. And so we need to take this, the chi-squared, and go to 3 degrees of freedom. This is our last thing. So we go here, degrees of freedom 3, chi-squared 3.677. Is that p-value large or small? Is the p-value high or is it low? It's our last question of the day. First person gets maxed out. Is the p-value high or low? High, Sarah, you're maxed out again. So the p-value is high. Just let the null fly. So guess what? We would conclude that the 2 are independent of each other, and we think the differences we see between... Does that look pretty independent? Remember the first graphics we saw? Does this look pretty independent, like the amount of fish people eat is independent of whether they get prostate cancer? It does to me. And so, and don't choose it because of this. It's just, it's kind of consistent with what we said, that we think the differences we see, even though the never seldom got it more, we think these differences are just due to random chance. There is differences here, but the differences seem likely by random chance. I'm going to put one last thing in the chat right here. I think I've got it pulled up. But if you could, let me pull this up right here real quick. I'm asking a big favor, and you can do this or not if you want. But I've got a video that I want people to watch. And if you can take the time, especially when we're doing the next class right here or whatever, I've got a really good playlist I made with 6 videos in it. And so let's go over here. I'm getting so many ads now. I didn't do it because, well, I put ads on it, but still. But remember, everything we make on ads, we've almost made our first $1. Everything we make on ads, we will be giving back to students. So let me pull up this video right here and put it in the chat. So this video right here is me doing the full lecture from today. See you, Walker. So here's the full lecture from today in a 30-minute video where I go through and I do a problem from scratch. So you're welcome. Yeah. Good class. Awesome. Good seeing you here. Enjoy your time. I really appreciate it. And thank you, everyone, for watching this. And great job. So that video right there, I think, is one of the best videos. I walked through a 30-minute example. And yes, and if you could like the video, comment on the video, that helps us with the analytics and all that good stuff. So awesome stuff. I really appreciate you guys so much. And is Jill still here? She might have taken the screenshots. Kara, good to see you too. You're welcome, Kara. Good seeing everybody. Head on out. We went 3 minutes late. I'm sorry about that. A lot of great questions. Ahood, good to see you. Jill, what'd you think, Jill? Did you have some fun? Did you enjoy the class? We go pretty crazy. We've got our imagination. Imagination. I gotta put that over my head more. 2 seconds. Let me fix that. There we go. Oh, now it's right over my head. Good. Yep. That will be so helpful. You're welcome. Well, thank you, Jill. I appreciate it. You guys treat me too nicely. So email me about the extra credit. Oh man, that's Yeah, no, and I'm glad because Ronald, you were in the class last semester, and you're just swinging by to say hey, right? I'm gonna move myself back over here a little bit more. Oh, there's I've got a light right there. You can see the full everything. So there's a light. So I put the light right at the edge of the where it is. So there's a light right up there. That's where we got that light. Bri squared. I'm gonna go. I think someone called me B squared one time. Ronald, yeah. I know. I did it. Abby was the one who kept asking because we kept saying Matt. Oh no, I turned it off. And then we go, oh no, I moved myself over, so I'll send this one back. Imagination. Okay, we gotta do it right. I can't. Well, it's reversed. So I gotta go. Oh, see, it's so hard being reverse of yourself. So I gotta. Here we go. Gotta be like. See, it's hard if I have my hand. I gotta be like, with your imagination. I'm not gonna ever get my hand perfectly on that. Where's the unicorn? You guys, I don't know. I got bored this weekend, so I made some stuff. That was cool. Why didn't we have that last semester? I'm sorry, Andrew. We have the randomness button this semester, so we got randomness. I've even got control over my lights, but I don't want to change my light right here. Oh, well, thank you. Actually, that's what Jason and Mark Collins call me. They're like you can. Anyways, sorry. People are very nice to me. That's all I want to say. People are very nice on how they treat me and how UT has been amazing. And I want to say this. Uh, I know I really like Jason helped me with that. And I think we'll have Jason next class. I'm gonna try to get him in here so we can have Jason for a review. So if Jill's still here, she could see that we have the interview screen. I'm gonna look a little bit weird here. We can go to the interview screen right here. Oh, no sound? Oh, no sound on it. Oh yeah, I redid it. Oh, you're awesome, Juan. So I'll have to fix that. Let me fix that while we're doing that right here, and then I might go grab a quick snack. So we got Julio's picture up. Let's fix this. So we should be able to do it really quickly. You ready? Let's go to the interview screen again. So let's go over here to interview. Okay, now you should be able to hear me over here. Okay, cool. I didn't have what we did. Now we have audio, right? So now we should have audio. Cool. I redid it. We've got a lot of new cool stuff. And where can we do it? So we're gonna do it. We're gonna go. Here we go. We're gonna go. Back. Oh, check your points. Yeah. So we've got new. Oh, I'm probably still echoing. Welcome to Stat 201. Okay. So we got so many fun things right here. Which models are today's notes on? Today's notes are going to be on chapter. So if Jill's wondering if she's still here, we're just hanging out, relaxing between class right now, and people are checking their points. What did you end up doing for green screen? I went and bought one with my own money. UT got me a lot of stuff. You can see it's an actual green screen right here. So I'm actually behind an actual green screen right now, and I'm too afraid to turn the filter off lest it like mess it up. But I have an actual green screen. I think it's an Elgato. So I went and bought a really nice one. So then I just bought it right away before I was like, I bought it with my own money. I was like, what the heck? So, but UT has bought me so much. Like, I have bought like I spent like 5% of what's been spent on me, and so I'm very appreciative for that. So when I needed something, I was like, I just went and got it because I didn't have the ability to get stuff yet. And also, I will say this: I'm so glad I got it when I did because green screens were like, I think they're still sold out. I think it's very hard to get a professional or a good green screen right now. So if I had waited, not that I had to wait very long, but I started to be like, if I don't order this, it's going to take forever to get there. It was shipped to me in like 2 days. Yeah, they're harder than toilet paper to get because green screens, people are doing a ton of online stuff. I've ordered a few things. A few things are taking like some of them are taking about a month to get here. Like I'm still missing some stuff I ordered, not missing, but it just hasn't arrived. So I really appreciate UT helping out this. And the Switch is hard. Yeah, I've heard Switches are hard to get. So that's such a bummer. Well, good job for Nintendo. I've got my Nintendo Switch. I've had it for a long time. Nintendo Switches are awesome. So yeah. Oh man, and I bet Switch Lite is sold out. Switch is sold out. Yeah, I was watching a really great YouTube channel called Only in Japan, and he's a guy who went to Japan to teach English. Met his wife there. They recently got married like a year ago or so. And so, has anyone heard of the channel Only in Japan? If after this you're on YouTube, it's awesome. Thank you so much, Jill. So good having you. Well, games are on Switch. One of my favorite games is one of my favorite games. People keep buying them and reselling. Oh, that's such a bummer. That's so ridiculous. They need to do like wait lists on stores and start selling them. Yeah, go check out Only in Japan. It's such a cool channel to check out. Go to Only in Japan, watch it. Amazing channel. Yes, that's awesome. Yeah, and so I guess I'm gonna go probably grab some orange juice. We got orange juice back. And I'll be right back here. So check your points, and I'll be right back here early. Awesome. So good to have you. I'll be back here. Had some OJ. Yes. I'll be back here in just a moment. See everyone soon. Be back. I'll be back.
Morty, we gotta turn the project in early.
Hey everybody, how are you doing today? We are good to go, and we're all here. Good to see you, Hannah and Yuting and Megan and Christina and Logan and Madison. Everybody, good to see you. We are on our final major chapter for the course. And so we've got a lot of fun stuff. We've already shown some of the fun. We can now, say it with me, we can use our, oh no, it went away. The rainbow went away. We can use our imagination. And it just goes away. So we got it right there. And hopefully it should be playing a sound effect when I do that, hopefully. We've got our randomness button back in full force. You know randomness is back right here. So we've got everything working again, just getting the home studio set up. Good to see you, John, everybody. We've got A+ for creativity. And this was Brian spending like an hour on Saturday night being like, how do I possibly make a rainbow appear over my head? We've got our imagination right there. And we've also got, we were recording stuff earlier. Let me turn on. I'm going to totally leave on the sound effect. We can go back. Oh, it does show it's coming across. Back. Cool. So welcome to Stats 201, everybody. Just go right here. We can turn up or down our echo right here. We've got all this good stuff. Yes, have them continue the project, Connor. Just have them make a mention of it, that we don't have enough success in Let me turn off the echo. It's not in the best spot for me to turn off my echo. I know, we're having lots of fun. So once again, if you heard me sing earlier, I'm sorry about that, Brian. The echo is in no way distracting. Good. It's now turned off. There's different things I can do with that, but I've now got a much better sound mixing board. I can literally mute myself. I can see where my sounds are at. It's going through a different mixing board. So, hey, Julio, good to see everybody. Now, once again, if you heard me talking between class, I bought my green screen, but UT has been so nice and helped me out so majorly in being able to deliver our class in the same sort of quality that we were doing during the semester. So I hope everyone feels like that this is pretty similar to what you were watching at the start of the semester. This is what we wanted. We wanted me to be able to do our class like we've been doing, and hopefully you are enjoying this. We're going to start talking about some major stuff right here. We've had our little bit of fun, 3 minutes of fun. Now let's start talking about some serious stuff. When is the project due for regular credit? Julio, Tracy just broke 1,000 points. Yeah. The same. I know, I miss them too. I miss it too. I think Barbara's right, the 24th. That's right. This Friday. So over the summer, I know I should totally stream video games. I might. You never know. Might just stream some video games on 201. So that'd be pretty crazy. I think I can do it. I think I could emulate it and do it. I think you can emulate Nintendo games, right? You're allowed to do that. I've got a Nintendo. I've got Mario. So why can't I emulate it? So Wednesday for extra credit. Nice job. You guys are so awesome. I had to it's like, you guys just put all the answers in the chat. It's awesome. Keep it up. Keep responding. We're going to max out some people on extra credit today. Friday is when the project is due for regular credit. Wednesday is when it's due for extra credit. Nice job on all those answers. How long does the entire project usually take? 2 to 4 hours, I would say. 2 to 4 hours. Oh no, Andrew. Sorry to hear that. So awesome job right here. Keep talking in chat. Remember, that the more you talk, like Zach saying that everybody's awesome, the quote from me, you guys are so awesome. The more you talk in chat, the more points you get. And I will say this, last class is giving you guys a run for the money because, man, they were so talkative. It was awesome. There was constant answers. I love it. And you guys are doing excellent. You have such a good start today. We're going to do some maxing out on extra credit today. So stay tuned. Talk. Jay knows it right there. Jay gets 10 million points right there. So guys, check your points. Say, hey, will you have another live help for the project? I will be doing live office hours tomorrow from 10 to noon. So we could focus on the project then because it's the day the project is due. And then also we're having office hours right after class where we usually focus on homework assignments. Does that make sense? After class, we'll probably focus in on homework assignments that are super likely to be due or more likely to be due. And then, awesome. Yeah, Julio's right. Keep your mind busy, work out, do schoolwork, everything. Julio, get 10 million points right there for the positivity on it. It's awesome. This is the second to last lecture right here. And Caroline, you'll start getting some points here. Check it out right here. And you are right. Feel free to join in. So good to have you. S Productions right there. So Hill Productions, you can watch and learn. We're going to do some chi-squared tests of independence. I think you do get points. So Caroline, you could check that here in a moment. But the more you talk, the more points you get. And so remember, we're using Streamlabs to check our points, so you should be able to see your points and see how everything's going. Reading the Man in the High Castle? That sounds awesome. Oh, Haley, I'm so sorry. Well, you can always swing back by. We have some people who come by every once in a while and check out our class. And then we can do chapter 19 after this. Any other questions about what is going on? We're in the first 5-10 minutes of class where we talk about what's going on in the world and just make sure we understand before we start doing the lecture here, which we'll start doing very soon. Does anyone have any questions about the final? Will be online. It will be through Canvas. So you will log in, do the final, and take it on Canvas, much like the other one. Can we do chapter 17? You bet. At the end of class, after class, we will do it. Sydney, great suggestion. Now, something I want to point out. I asked this to the last class. First person to answer gets maxed out on extra credit. Get ready here. Get ready for the question. First person. We can do that. Yeah. So here's the big question. Your quizzes are averaged with your test. Yep, Neil, you are correct. Your quizzes are averaged with your test. If you make 100 on your quiz average, what will you get on the final no matter what? You'll at least get this. You can't get lower. Oh, everyone's saying true. You can't get lower than this. 50, Julio gets maxed right there. He's right. Julio's first right there, 50. You can't get lower than a 50. Everyone else gets 1,000,000 points. Great job. Nice job. So remember this. It's so key to do the quizzes. I was telling the last class that I actually think that the quizzes are more important than turning the project in early. Now, you should still turn the project in early. Turning the project in early can get you 7 extra points. Do it right, turn it in early. But the quizzes are so important. And we will be doing quizzes after class today. That's usually what we focus the after class work on. We'll probably be doing project tomorrow from 10 to noon. So please do the quizzes. Not doing the quizzes is taking away a huge advantage. And remember, we will do them in the videos. Wait, oh, you were? Thomas, and we're giving it to you too. I think I might see it differently because maybe the way the chat goes. But yes, so Thomas, I'll also give it to Thomas right there. I think just the way the chat goes, I might see the names in different orders just by the way the internet's doing its thing. But I could take a screenshot and show you right here just so you think I'm not making it up. Watch it actually be that you were first. I'll be like, oh, I will show you right here. Let me go to screenshot. There's a neural net. And so people think you're like, you're editing that screenshot. Brian, you're cheating. You're editing the screenshot. And actually, here, I'll do the full. So we're not editing it. So here is what I saw right here. So there was right there. That's what I saw right there were the answers. And it's so weird. I've had other people say that too. Like I was first. I think it's when it floods, it can be so quick that sometimes it shows it to me in a different order than you guys see. So sorry about that, but I will take your word for it. I will take your word and I will give you the points right there. You're also maxed out. Would it be possible that the quiz reopen like exam 2? We won't be reopening them. We won't be reopening them. So here's the biggest thing. Now, yeah, we won't be reopening them. I don't foresee that. Yeah, that was because of the internet and everything. We were doing that for 2 and everything. That's so weird. Yeah, it's like internet, and I don't know why. So thank you everyone because it's so weird. But so the biggest thing is don't expect a quiz reopen. Don't expect that. So do them when they're due. Is the final during the same time slot? Yep, we'll be doing it over like a 2-day period. I need all these quotes, Zach, written down. We'll be doing the final over a 2-day period, so you will have a lot of time to do it. There's one dropped. There'll be one dropped. Is there any other major questions? Who else has any questions? I'm moving myself to the side here to start the lecture. And I hope we still have productions here. They're free to watch and everything and learn and ask questions if they have related questions to the material we're doing. It is on Lockdown Browser again. You can use your own calculator. It's on Lockdown Browser and you can use your own calculator. The 2-day period, it'll be very similar to the last exam. It'll be very similar. But how do you find the statistical significance cutoff? Jeff, I don't know which one you're talking about. You might be talking about alpha, Jeff. I don't know exactly. Alpha is when you do statistical significance. Alpha is statistical significance. Yeah, and I can do that after class if you like too, Jeff. Great question. Alpha is usually 0.05 unless assumed otherwise. It'll just be open for 2 days, Haley, and we'll probably do it like the day of. And I'm trying to think which day we have it on, but we'll probably do it on like the next one. You can do it right. And the study guides are already up. Oliver, great questions. We've got a lot of study guides up. Let me show you this right now. If you click on this, open it in a new window. But this right here is today's lecture in like a Cliff Notes 25 minutes video. This lecture, this is a little like Cliff Notes version of it. It's like, don't go over to that video and start watching it now and be like, it's 25 minutes. I don't got to watch today's lecture. But that is a Cliff Notes version of today's lecture. So if we still have our visitor here, they can check that out. They can watch this. And that is a Cliff Notes version of today's lecture that covers everything and talks about why and how to use it. You also go to the playlist there, so you can open that in a new window. I suggest watching that, and I might do a way for everyone to get extra credit by watching all the videos and turning in a bonus this weekend. So if you don't get maxed out on extra credit, I'm thinking of a way, and I want to talk to the other instructors, but I want you to watch these videos. I want you to know which test to use and when. The test will be on Canvas. How can we see our quiz average for the groups? It should show it. I think it should in Canvas. You guys are awesome. Madison, thank you so much. Any other last few questions? We've had our 11 minutes of fun. I know I do have it on that video. I will say that because those are my general purpose videos. And do remember, Stats One's about to make its first $1. But here's what you can do to help the channel. You can comment on any video. So anytime you watch a video, throw a comment down below it. Maybe it was something you learned, or a suggestion. Put a like on the video. It's literally the like, comment, subscribe. The more you like the videos, the more you comment on the videos, the more we get organic views that the algorithm will kind of put into us. And so I really hope these videos are going to be used by like other universities or other people's. So those are my like really professional videos where I talk very straight to the point and we go straight through a whole lecture. And if other people start watching those from other colleges and we start to generate some views on them, everything starts going, like all the money we make, which we've almost made our first $1 in 1 week. We're making about $1 a week right now, $1 a week. But hopefully we start making like $2 a week, then $3, and $5. And that'll all go into things like tutoring. I think, is Connor still in the chat? Connor is one of our tutors, and Connor is still here. You can say hello to Connor Moore right there. He's one of our tutors, and we want to become kind of self-sufficient. And $100 a week would be awesome. Then we could literally put $100 a week into tutoring. So the more you like the videos, and pizza parties, we've totally talked about pizza parties too, because I would love that. And so once again, I can turn on the donations to stream, but I'm a little bit afraid of that. John, I'll have it on probably next. I was looking at that. I don't want you guys to donate money to me, though. I don't want you to do that. I was thinking that students might start doing that. They might start giving me like $10, $20 just for like randomly, like they might start super chatting. I might turn that off after I turn it on. I'm a little afraid of that. And I don't, like, I would never want this to be like something where it's like, I'm only going to answer questions via super chat, because some streams do that or they recognize those first. I don't want someone to be like, oh, I'm so stuck and I got to pay Brian $2 to answer my question. That would be really bad. Like, really, that would sound really bad. Like, you might, yeah, no, John, well, I appreciate that. And I should have like a disclaimer, and everyone should know it, that like super chats, one, I'll probably read them all at the end of the stream unless they're like super pertinent. That's usually what a lot of streamers do if they get a lot of super chats. Not that we're gonna get a lot, but I would never want anyone to think that we would prioritize though. Oh my gosh, Brian, you're awesome, and I love your name. You got a great name right there. So thank you, Brian. You are awesome, and we are glad to have you. And always feel free to ask questions. You can email me at bstevens@utk.edu. And so I'm glad to help out, Brian. I'm glad you found a lot of useful videos. Comment in the videos, like the videos, and we will, we appreciate you. We appreciate you being here. So tell us what you like and tell us what will help you, and we'll try to make great videos for you. We have now figured out, I don't think I said that, Zach. We have now figured out what is going on. Jason Cam, I think we'll be back next time. So come next class for the exciting return of Jason Camera right here. Right now, we have Julio on. We have Julio Cam, but Julio camera. So we'll go back to interview screen right here. So here we are, but we don't have Jason coming yet. And there's my light right there. You saw my light. Okay. It is time to start lecture. Let's get started here with the lecture. Let's do it. Okay. Comparing counts. What are we talking about? We are talking about today the chi-squared test of independence. So the chi-squared test of independence is where we are going to compare counts, and we will compare two categorical variables. The most important thing for you to know right now is that in this chapter, everything we will do is with two categorical variables. So I need you, and the first person who does it gets maxed out extra credit. I need you to tell me a test we could do. I'm going to come up with a few, but you can't steal my answers. So here's a test we could do. You got first person gets maxed out. We could do where someone was born and their favorite sports team. So there we go. That is where someone's born, their favorite sports team. What's another test we could do with the variables? What's another test we could do? We could do someone's eye color and see if that explains their hair color. Favorite food and favorite color. Abby right there gets maxed out. Gender, high school. I guess high school they went to. There we go. That's another one. Hair color and gender. You are right. Eye color and favorite movie genre. So there we got favorite college, where you go to college, and favorite food, state and gender, favorite food and favorite place to eat. Exactly. Oh man. You know what? I would love anything more than now. Taste of Thai. And Taste of Thai going there with Chelsea. I would just like to go to Taste of Thai with Chelsea. That would be amazing. That means you have 2 points on your grade, because maxed out extra credit is up to 2 points. So you are maxed out on extra credit right there. Taste of Thai with Chelsea, exactly. And so right there, and you did spell it, yeah. So and be careful, height is quantitative, so we have to use 2 categorical variables. Favorite sport and food preference, all of these right here. State of birth and favorite food, all of these right here. Social media platform, and if you own a cat or a dog, things like that, because that's all categorical. All of these need to be categorical. Does everyone understand here that we have 2 categorical variables, your state and favorite food? Excellent work. Does everyone understand what this chapter is handling is 2 categorical variables? That's the theme of the day, right, Zach? So hopefully football gets started up again. Our goal for this is to test to see if there is a Julio's right, you could put, we actually call it it's to make something discrete, discretization. I can't say it today. It's to make discrete, so that's when you take a quantitative variable and make it discrete, discretization. So that is how we say it right there. And let's look at some examples right here. You ready? So I'm going to give you guys the opportunity to take either test A or test B. So here's the thing. I have here test A or test B, and I have if people pass the test or they fail the test. So I want you guys to tell me, oops, that's the wrong color for that one. Space pen goes in the good area. Space pen's always happy. Who wants to take test A? Who wants to take test B? We've got example 1 here. Who wants to take test A? And who wants to take test B? Andrew wants B. He wants to show me he can pass it. Andrew wants to show me that he can pass test B. And think about this. We have the test someone took and if they pass or fail. So we have here the version, and we have here the grade. So we see a lot of A's right there. Test C. Abby says test C. And so we got some great answers. Million points, all those answers. Excellent work. Let's go here to example 2. Now, it's the same variables again, but I want you to see something. This time, what is going on with this one? What is different about Brian's graphic right here? Now we've got the version A, version B, and then we've got the pass-fail up here. Oh no, where's Space Pen at when you need it? There we go, Space Pen, we missed you. And so now we go here and we go to pass and we go to fail, and hopefully I'm not blocking it. Good, I'm not blocking, and we go to version A or version B. Now, which of these, and it's basically equal, I do it a little bit off. The tests are equal with pass and fail, pretty much. The differences here, first person who says it, are probably just due to what? The differences between those, now more people pass test A. There needs to be a shirt where, I like that, Thomas. Oh yeah, Thomas, I might do the Minecraft server this weekend. I might do it. I think Snay said it first. Snay said random chance. Snay is 100% right. And once again, I promise you, I'm choosing who I see first. Snay is right, max extra credit. These differences look likely by random chance. These differences here look what by random chance? Unlikely by random chance. Those differences there look unlikely by random chance. These differences right here look likely by random chance. So what does that tell you about the p-values on these? If we were to do a test on this, the p-value on this one would be very what? Now, these look likely by random chance, so the p-value would be very what? In this one I'm pointing to, this one looks likely by random chance, so the p-value would be very high. This one would have a high p-value, and this difference right here looks very unlikely by random chance, and this one would be low, because you're saying that the differences we observe were unlikely by random chance, and here the differences we observe were likely by random chance. Does that make a little more sense on the p-value to say, yeah, I think the differences between these two tests right here are just by random chance. It's very likely that maybe 15% of people failed here and 16% of people failed here. So I think these differences are probably by random chance. So over the far side, which I can't point to, it's off my green screen. Whee! The far side, the differences are unlikely by random chance, so the p-value would be low. Very important stuff here conceptually with what we're doing with this, that we understand this is the chi-squared test of independence. So let's start talking through the notes here. We'll just have them disappear for some reason. And let's see if we can figure out if something here is significant. We are back to the Titanic. We're going back. There we go. Back. And when we go back to the Titanic, you'll notice where were the most people alive? First person gets maxed out. Where were the most people alive? In the first class, second class, third class, or crew? Where were the most people alive? First, second, third, or crew? I think Jacob got it. Jacob, you were right. Jacob was first, and Jacob's right. It is crew. Now, I'll have to answer this one because we're still getting first class. Crew had the most people alive, but first class, if you divide this right here, had the highest probability of being alive. So if you see that 212 out of the 885 were alive in the crew, where 203 out of the 325 in the first class were alive, you'll see that the first class had a higher probability of being alive. So given someone was in the first class, they were more likely to be alive. Just like your example over here, given, in example 1, given you took test what, you were more likely to pass, first person. Given you took test what, in this example, you were more likely to pass. Given you took this test, you're more likely to pass, first person. Who gets it? We're going to see a lot of this answer really quickly. Given you took, Lindsay got it right there. Lindsay, you're maxed out. Given you took test A, you're more likely. And I will be putting out, I think, to maybe max everyone else out. So, and I do suggest doing this. I'm going to max out a lot of people. But given you took test A, you were more likely. I'll put out an announcement regarding how to get maxed out, and it'll be related to the videos. But I know, but the videos I think are very helpful, and you can skip ads. You can, but like the videos, comment on the videos. Let's see if we can get them being used by a bunch of people around the United States and universities, which would be awesome. Okay, so here we are. We need to know how to write the null and the alternative. Now, I know everyone's thinking, okay, when we write the null and the alternative, we need to do these 3 steps. We need to do the null, and then we need to write a population parameter. Then we need to do our equal sign. Then we need to do some hypothesized value like p equals p naught or mu equals mu naught. All of these things right here is what we usually think about. I'm going to make your life easier for just this one test. This is the only time we don't use statistical notation. It's the only time. I'm holding my hands up like this. Like, please use it only this time. This is a superpower you only get to use. The not using statistical notation superpower, which I bet we all wish we could use all the time. But we're going to go right here and we're going to do the simple thing of following. You ready? You're going to look at this right here and you're going to put one word between these. You're going to put one word between these. You're simply going to say independent. That's all you're going to do between these. That's all you're going to do. You guys got it in the chat. You know what's going on. So watch as I do this right here. The version of test someone took is independent of their grade. The version of test someone took is not independent of their grade. The version of test someone took is independent of the grade will make. The version of test someone took is not independent. That is the alternative. So you guys got it. And I want first person to write out the null for this test right here gets maxed out. Who knows the null for this test right here? Who knows the null for this test right here? First person to write out the null for this test. Well, that's going to be the null that we assume. Abby, great question. This is what we're going to write out the null and alternative, and the null assumes that they are independent. Great question right there. The null assumes that they are independent. Survival is independent of class. I think so right there. Zach got it first. Nice job, Zach. Survival is independent of class. You got it. You just put it right between here. Does everyone see the trick Zach is doing? All we have to say is X is independent of Y. Survival is independent of class. Nice job, Summer, right there, and Marina and Joelle. Survival is independent of class. What is the alternative? First person to see right the alternative gets maxed out. Who knows the alternative? I think Julio's already maxed out, and he wrote it. Got maxed out early on today. Who else can do it? Who can do the alternative? So remember, the null is survival is independent of class. Dylan right there gets it. Nice job, Dylan. Survival is not independent of class. You got it. All you have to do is the null is X is independent of Y. The alternative is X is not independent of Y. Nice and easy. You got it. Great job right there. So guess what? We're back to conditions again. You guys ready for this? We're always ready for conditions. Condition 1. I need to see in the chat. No, you're awesome. No, I keep typing, Julio. We want all the answers we can. We got random in here. I should see random start to flood the screen. Where's my random flood? Where is it? You guys get the random button. As soon as the screen fills up with random, you guys get the random button. You have now achieved it. Condition 1 is random. You know what's going on. Wolves are cool. If Jason was here, he'd tell us wolves are cool. There's our wolf right there. Class mascot right there. Wolves are cool. So, Jason will be back. Jason will return. I just had an idea. I should have made that this weekend. Okay. It's copyright music. I don't want to do that. So the 10% condition, awesome, Summer, amazing work right there. The 10% condition is that we need to sample less than 10%. That was totally a light bulb moment. The 10% condition is we need to sample less than 10% of the population. And then what do? Crab Rave, the guy said, I think that everyone can use it. He wants people to use it. Like, he put out that music and it's like, no one's in trouble for copyright over it. So now it became a huge thing. Because I think he did, because he didn't want people getting copyright striked for it. So now everyone uses it and everyone knows Crab Rave because he was like, use it up, do it up, use Crab Rave everywhere. So smart guy, made a really cool song and then told everyone to use it and everyone knows Crab Rave. So unless all of a sudden I start getting copyright. Pause. Everyone knows what's going on with pause. So condition 1, random. We randomly select our data. Condition 2, we have the 10% condition, which is less than 10% of the population is sampled. Condition 3, pause, and let's think about it. This time, it's actually on this side. Sorry about that, guys. This time, the condition right here is count data. Condition 3 today is count data because we're dealing with 2 categorical variables. So how do I know if I pass the third condition? I simply look. This is categorical, this is categorical. Does everyone understand how I'm passing the third condition right now? To pass the third condition, literally if you have these graphics, you pass. So the third condition is count data, and we pass the third condition if both variables are categorical. And I pass because survival's categorical, it's categories, and class is categorical. So you pass the third condition count data if both variables are categorical, and by virtue of there being a contingency plot and mosaic plot. So does everyone understand that? We need 2 categorical variables, but that's what this lecture is about today. So every time we do this, we will pass the count data condition. What would we have? And this is really good. These conditions are to make sure we're doing the test properly. Elizabeth, million points right there. These are to make sure that we're doing the proper sort of statistical analysis. If we don't pass these conditions, then our test will be inherently flawed and it won't make good predictions about what we're doing right here. So I hope that answers, because these tell us if we're doing the right sort of statistical test. If we fail the randomness, then we probably are not. Our tests are going to have bad results, as in we can't generalize our results. So if you fail these conditions, well, 1, you either can't do the test. If you remember earlier, great question, Elizabeth. What was the condition QQ for? You guys remember QQ, straight enough, no outliers, plot doesn't thicken? What is QQ is kind of like CC because it means both variables must be what? QQ straight enough, no outliers, plot doesn't thicken are all the conditions for what? First person gets maxed out. Tell me what these were the conditions for. What were they all the conditions for? Yep, correlation or another one. I'll max out Abby right there. Correlation or both what? Correlation and QQ straight enough, no outliers, plot doesn't thicken is for regression. J gets maxed out right there. J, you're right. It's for the last one's for regression. So QQ means both variables are quantitative, and if you don't have 2 quantitative variables, you can't make a scatter plot. You can't do a scatter plot, and if you don't have 2 categorical variables, you can't make a mosaic plot. So literally, you have to pass QQ to do regression. You have to pass count data to do a mosaic plot. So if you don't have categorical data, you can't do this. I know, what a throwback right there. So QQ was one of our first conditions, and then count data is basically CC. Does that make sense right there? What if we have, I'm going to max out someone else. What if we're doing a test, this is a good review, and we have a quantitative and a categorical variable, like this is the Y variable and this is the X. What are we doing right here? And I'll drop some hints. So this would be like if we want to test the price of certain products, like the price of bread at I'll take histogram's pretty good, but what kind of test are we doing? It's like the price of different brands of bread at Walmart versus the price, there we go, Rachel got it right there, the price of different brands at Publix, price of bread at Publix. So we would have here, think about it, we have here store, so we got Walmart, and we have Publix, and then we have, so this is store, and then you have your price. Does that make sense right here? What's going on with this graphic? This is side-by-sides box plots, doing a comparison of the differences between the means, and it's because one variable is quantitative, the y variable price, if you notice that is on the y-axis right here, and then we have the x variable store, which is categorical. So I highlighted too many things, but this is what we have going on right here, and it all comes down to the variable types. That's why knowing your variables is so very important. So you'll notice these small, subtle differences right here. Box plus is the difference in the means. Sam, you are right. Sam, 1,000,000 points right there. Great answers in the chat. Excellent, excellent work. And today we are doing 2 categorical variables. So why do we need to use these conditions? To make sure we're doing the right test. The chi-squared test of independence requires that we have 2 categorical variables. It is a requirement that these variables here be categorical, and they are, because we couldn't do it if not. And then we have condition 1, that they were randomly selected. Titanic doesn't really pass that. Condition 2, that this is less than 10% of all people in the population. Doesn't really pass that. And then we have count data, condition 3, which we just talked about, passes because class and survival are that. They're both categorical. And last but not least, we have condition 4, which is expected cell count. Now, remember how success failure worked? Success failure is that we need at least 10 successes and 10 failures. But now, since we have 2 categorical variables, we only need 5. You guys are cracking me up. So I see Davey put out a video related to something you said earlier. I have to see what that is. I don't know about that thing yet. So Davey504 put out a video. Check out some Davey504. I don't know. I'd love it if you did like I think I told you guys last time. But the expected cell count condition right here is that we need at least 5 expected cell counts. So you might be wondering, what is an expected cell count? What the heck is an expected cell count? Well, it's what we said it is. It's how many we expect. So, yep, expected. Make sure Abby put expected before it, because that's like the huge keyword to know. I'll just sometimes call it the expected cell count condition. So the big word right there is expected. If it doesn't pass a condition, yes, if it doesn't pass a condition, mention it and continue. Julio, great thing right there. If you don't pass a condition, mention it and continue. Don't end your project if you don't pass a condition. Let's go here and let's look at some data. So Brian has his online students and his in-class students. I want everyone to tell me right now, how many expectations we have? Yes, exactly, Catherine, you're 100% right. This is the classic chi-squared test of independence. My pen moved, I don't like that. Well, it's gonna be moved. Okay, here we go. Haha. Okay, Brian has online and in-class students. Does that make sense? Brian has, of his online students, so here's online, here's in-class. We'll put it below it. Here's online, here's in-class. Here's the amount of students who pass. Here's the amount of students who fail. Brian has 100 online students, 100 in-class students. 100 students pass, 100 students fail. Let's start out very easy right here, starting out. So don't go too crazy. I know the numbers are not pretty right here. You might be saying, Brian, why did half your students fail? I don't know. I can't tell you. I don't know the answer to that. I want someone to tell me how many of my students, like what percent are online? What percent of Brian's students are online? Just take a moment to think, what percent of Brian's students are online students? 50%. You got it. 1,000,000 points right there. We'll do next question. Get ready for the next one to get maxed out. I can't do it because it's a repeat answer. So 50% of Brian's students are online. What percent of Brian's students pass the class? Just out of all of Brian's students, what percent of Brian's students pass the class? 50% of Brian's students pass the class. So what percent of Brian's online students would you expect to pass his class? What percent of Brian's online students would you expect to pass? Just if you didn't know anything, you'd expect 50%. We'd expect 50% of my online students to pass, right? Because just think, if 50% of Brian's students pass, well, then I would expect 50% of his online students to pass. And look, we can write that in here. I'd expect 50 to pass, 50 to fail, 50 here to pass, and 50 here to fail. If you notice, that's 200 right there. But let's change the numbers. Let's go right here and say Brian now has 90% of his students pass. So now 90% of Brian's students pass. Do you remember I just said 90% of Brian's students pass? So first person gets maxed out. How many of Brian's online students would you expect to pass his class? How many of Brian's online students would you expect to pass his class? How many of Brian's first person gets it? Who's got it? Brian right there. Other Brian gets it. You're right. 90. And Julio's got the equation in the chat. Nice job, Julio. You know where this is going. So now you just figured out, you said 90, you'd expect 90%, you expect 90. But let's make it a little harder here. You ready? Now Brian now has 1,000 students. They said, oh gosh, we're gonna get Brian every student. Let's do it. So now Brian now has 600 online students and 400 in-class students. And we see here that once again, 90% of Brian's students pass. Okay, who here can tell me how many of Brian's online students you would expect to pass now? How many of Brian's online students would you expect to pass now? Remember, 90% of Brian's students pass, so what percent of Brian's online students? But you have to tell me how many. And I have the answer in my head. Who can tell me? First person gets maxed out. Zach, you are right, 540. But so Abby, really great question right here. And thank you for saying you're confused. Abby, million points right there. Just thinking about Brian's online students. If they're just like every other student, then what percent of Brian's online students, just as a percentage, would you expect to pass? You'd expect 90% of Brian's online students to pass. Does that make sense? Just because if there's nothing going on right here, I'd expect 90% of Brian's online students to pass. So then all we have to ask ourselves is, what is 90% of 600? And so everyone's putting in the chat right now 90% of 600, because if, Brian's online students are like every other student, well, he's 600 online students, I'd expect 90% of them to pass, and there's the answer. So that's how does that? Good job, Jeff. Nice seeing everyone here saying it makes sense. I like that. Now, the way we solve it's going to be a little bit easier here. Here's what we do to solve it. Julio put the answer in the chat, and I like it because knowing this formula helps out a lot. It's row total times column total over grand total. Now, if you notice, we're kind of doing this formula right here because what we did is we did 600 times, and then we had 900 over this right here. So we kind of wrote it out ourselves in a little bit different of a way. So do you see how I've just kind of moved around the numbers a little bit? Let's show the numbers I'm highlighting right here. Here's the row total, column total, flip-flop. And then all we're doing is just taking these numbers and dividing them by the grand total. So we were doing this mathematics without even knowing it. And what does this equal up to? It equals up to the expected amount that we expect for Brian's online class to pass the test. This is how many students in Brian's online class I expect to pass the test. And so does this make sense to everybody right here? It's just row total times column total over grand total. Row total would be this one right here. That's the row total. And the column total is this one down here. And the grand total is this right here. That's the grand total. What is the denominator? It's grand total. That's a G. My handwriting's really bad. And so that's a G right there. That is grand total. Thank you for asking right there. Barbara, you get a million points for asking. And Brian, you get a million points for answering, helping out. I love it. So this right here, let's do a separate question. I want you guys to tell me how many of Brian's in-class students do you expect to fail? How many of Brian's in-class students, and first person to write the formula, first person to give the answer, and first person to write the formula get max extra credit. How many of Brian's in-class students do you expect to fail? Lindsay, Zach's already maxed out. So Lindsay got it. Lindsay said 40. 40 is correct. And who's got the formula? I think that's the formula right there. Yes, Ren got the formula. Exactly. Ren wrote the formula in the chat. And then if you remember the name I said earlier, they also got the 40 right after Zach. Zach, amazing job. Zach's already maxed out. And Lindsay got the other one. So does everyone see here what you do? Is if you're looking for this cell right here, it would be these numbers. There you go. There's the formula. You're already maxed out. Oh, we'll find another person right here. Justin's right below you. Justin gets maxed out. So there we go. There we go. Yay. And so, and so we go right here, and we see that we have row total times column total over grand total, and we do this. I'll back in 10 seconds. Oh, wait, here we go. And so we have here the expected. Does everyone see why this is called expected? Does this make sense to everybody on why this is called expected? It's saying to you, if nothing's going on between these variables, I expect that we would have 40 students in Brian's in-class fail. Just if nothing's going on, I'd expect 40% of his students to fail. I'd expect 360 to fail to pass here. I'd expect, we've got this, so 540 here. And I'd expect 60 here. And you know what's interesting? Exactly. Nice job, Zach, right there. You know what's interesting? What do 60 and 40 add up to? 60 and 40 add up to 100. What do 540 and 60 add up to? They add up to 600. What do these two numbers add up to? 900. So we see here that it works out that all of these expected values are what we expect if the two variables are what of each other. If the two variables are blank of each other, then we will get, we will see numbers close to this. Who can tell me? It's one word, you get maxed out. Exactly. Independent. Abby got it right there. Abby, you are right. And Marina, amazing comment. Maxing out Marina and Abby, because Marina was explaining some stuff right there. I like that. You got it. Great job. So if these two variables are independent, this is what we would expect right here. Awesome, awesome, awesome work. So let's go back to the notes. And so what do we have going on? We are going to find these expected values with the following formula. So all you have to do is follow the formula on the screen, which is what I did. Row total times column total over grand total. And it'll find what you would expect if the two variables are independent of each other. If the two variables are independent, we should see numbers kind of close to that. Now what we're going to do is we're going to take this difference right here. We're going to take this difference right here, and we're going to look at it. But here's a problem. We have Zach, who's going to go buy a Ferrari for $200,000, and when he goes to buy it, the Ferrari is $210,000. Zach, are you freaking out? Zach saved up for a long while, and they said the Ferrari's $200,000. He goes and buys it, and it's $210,000. He takes a loan after the last 10. Zach is freaking out. I don't know that 200,000 and 210. You might be like, it's a little bit higher than I thought it would be. But now, I love it right there. We're proud of Zach right here. Great job, Zach. Not that a Ferrari is the measurement of how you're doing life. But now we're going to do the following right here. Let's go right here. You're going to pay for it in toilet paper. You just throw them a roll of toilet paper and you say that'll cover the 10,000. They're like, oh my gosh. They hand you back another 5,000. Like, because they're like, we owe you money now, Zach. They just give you another Ferrari. Zach, you're awesome. And so now Zach expected his Ferrari to cost how much? He expected his Ferrari to cost $200,000. And then it ended up costing $210,000. Does that make sense right here? Zach expected his Ferrari to cost this, and then he observed it costing this right here. So Zach expected it to be $200,000, and he observed it costing $210,000. So Brian has been saving up for a long while. He's going to go buy a car, but he's got to go buy a used car. He's not as awesome as Zach. Brian expects his used car to cost $2,000. We're getting a 1999 Honda Accord, or maybe a 2003 Honda Accord. So Brian's getting a 2003 Honda Accord, and then when he goes to buy it, they tell him, nope, doesn't cost $2,000. It costs, wait for it. It costs $12,000. So it's 2003 Honda Accord. So Zach's going to buy a brand new Ferrari. So brand new Ferrari, and Brian gets the Honda Accord right here. So what are the differences between both of these cars? What are the differences between both of these cars? What is the difference between basically, Abby, you're getting it. The difference for both of them is 10,000, which is the residual, basically. Abby, amazing job right there. Abby, we're maxing you on extra credit, too. That was a secret answer right there. Great job. That is the difference between both the cars is $10,000. But which of these is more unexpected? Which of these differences right here is going to be more of a like, what? Like, imagine Zach going to buy the Ferrari for $200,000. They tell him 210. He's like, and then I go to buy it for $2,000. Like, it's $12,000. I'm like, what are you talking about? But couldn't someone just say to me, it's both a difference of 10,000? I mean, look at this right here. Both of these right here are just a difference of 10,000. Both of these differences are merely $10,000. But this is where the chi-squared comes into place. The chi-squared, which we'll use for categorical data, but I think this example makes it make more sense, will show us which of these is more unusual. The formula for the cell chi-squared, which we'll use for categorical data, we're just using it for quantitative for fun right now, is going to be observed minus expected squared. Now, what is, in all instances, the observed minus the expected, which it doesn't matter which way we minus them. I know for someone watching this, it is observed minus expected, but we're going to square it, so it doesn't matter. Does everyone understand that once we square this, it doesn't matter which way we subtract it? So that's why we square it, because then the difference, positive or negative, doesn't matter. I like that right there, Zach. So that is the difference up here. So this is the top part of the equation, is 10,000 squared. But for the Ferrari, it'd be over 200,000 because that's what they expect. And for my car, the $2,000 car, it'd be this. So if you look at this, when you standardize this, the one, oh no, I've done it. Let me zoom up. The one that will be more unexpected is going to be the Honda. The Honda is way more unexpected. I wrote something wrong. This is the Honda one. I knew I was blocking it and my brain went off. What is the formula for this for? This is observed minus expected squared over expected. Does everyone see that as the formula? Observed minus expected squared over expected. So this number right here is just the difference between the observed and the expected. It doesn't matter which way you subtract them because you will be squaring it. So technically it's negative or positive, but it doesn't matter because you square it. So when you square it, difference squared over original, exactly. Now I want you guys to think about this. This is another maxed out question. You ready for it? And so what is this right here? This is just a what between two numbers, and then we'll do what to it. That equation is just a what between two numbers, and then we're taking that thing and doing what to it, first person. And this will give us a cell chi-squared. Great question right there, Anne. It's a difference, and what do we do to it? You got to say the full things. It's a difference that we're going to do what to next. You got to say the last part. We're going to take the difference and what it. Everyone's saying difference. Everyone's getting a million points of the difference right there. It's a difference that we will then, starts with an S, difference that we will then, standardized difference. Rachel right there, got it. Rachel, nice job. It's a standardized difference, because guess what? Everyone keeps asking, what does this give us? This will give us cell chi-squareds. So this is a cell chi-squared. And here's the thing. I've got enough room, I think. We can do other formulas just like this. So other formulas we can do just like it are the following. I'm going to get a brand new sheet of paper and go up here at the top. Remember how we have observed minus expected squared over expected? That's a cell chi-squared. So that's a cell chi-squared. That's a chi symbol right there. Well, guess what? We can do p hat, color changing pen. And this will solve out to a what? What does this solve out to? This solves out to a what score? Oh my gosh. It's not the bottom of the equation. If I think and talk, you guys ever tell me if I make a mistake, tell me. Does everyone see the top of this equation and everything? That's just a difference divided by something that standardizes it. You guys got it right. That's a z-score. And then we can put another equation down here. Of course, we get space pen out. You know it. We can go here and go y bar minus mu naught. And that's just a difference. The top part of the equation is a difference. Then what do we do to the difference? We take the difference and we standardize it. So let's do s over square root of n. And there it is right here. This equals to a t. And I like that we use the same color right here because we can do mean 1 minus mean 2. So here's what mean 1 minus mean 2 over the standard error of y bar 1 minus y bar 2. And this is equal to the 2 sample t. So we've now done it. We've written out our 4 tests right here. Here is, let's highlight them. This is a 1 sample t test. This is a 2 sample t test. This is the 1 proportion z test. And this is the chi-squared test of independence. This is when you would ask a question like, let's compare the price of bread at 2 different grocery stores. This is just looking at the price of bread overall to see if it's above a certain value. This is when you compare the proportion of people who own a cat to like 60% or something. And this is when you have 2 categorical variables. Let's put a huge note on here that this is quantitative categorical. This is going to be, let's make it very clear. This is quantitative categorical for this one. This one is only quantitative. This one is only categorical. And this one is categorical. So this is when you would use these different tests. This is a really great cliff notes right here of when to use each test. So what is the only combination I'm really missing on here, and what would we do for that? What is the only combination I'm missing? You get maxed out. The only combination I'm missing, and what would we use for this? This is an amazing cliff notes version, I think. QQ, Ren, you're right. You're maxed out, Ren. You got it. So QQ would be when you have regression. And this is, if you understand this, you have learned a lot in this class. So let's just put numbers on them. This is a great cliff notes, especially for tools and techniques. So number 1 is the chi-squared test of independence, which is used for 2 categorical variables. Number 2 is going to be a 1 proportion z test used when you have 1 categorical variable. Number 3 is the 1 sample t test used when you have 1 quantitative variable. Number 4 is the 2 sample t test used when you have a quantitative y and a categorical x. And number 5 is when we have quantitative, 2 quantitative variables, and we do regression, linear regression. So maybe we should go ahead and plot a space pen line through it because space pen's awesome. Awesome. That is a mega review right there that we just happened to come across because guess what? Guess what we have on this slide? We have the chi-squared test of independence a difference standardized. Yes, great timestamp. I love it when you guys put timestamps in. Thank you so much. The variable types. Oliver, great question. The variable types tell you what to use. You have to look at, and that's why the first thing we cover is variable types when we play Mario Kart, because we cover what are the variables, and then if you know you have two quantitative variables, you know you're doing regression. If you know you have a quantitative and categorical, you're comparing means or medians probably. Like if we did some advanced stuff, you might compare the means or the medians and use different types of tests to compare a measure of center for the groups right there based on categories. So it really comes down to what are your variables. And how do we know to use the chi-squared? We know to use the chi-squared because we have two categorical variables. Now, it's nice and easy to remember that when you do the chi-squared test of independence, you will then find all the cell chi-squareds. After you do that, you will then, and these will be on the formula sheet, you will sum them all up. So everyone follow along right here. Thomas brings up a great point. The first thing is to have your observed. So, oops, we're about to see the example. The first thing you will do is you will have your observed. Sorry, we'll go to that in a moment. We'll go to the next slide. The last thing we need to know about the chi-squared right here, my brain jumped a moment. The last thing you need to know is the chi-squared is a lot like the t-curve. The t and the chi-squared both have with them degrees of freedom. So here's the chi-squared, and you'll notice it'll either be very right-skewed or it'll start to look more normal. We probably won't see that much in this class, but the chi-squared is just like a t because it has degrees of freedom. Did everyone hear that? I want to see in the chat. The chi-squared is just like the t. It has degrees of freedom. Not just like, but it has that same sort of thing. It's a distribution that will have a certain shape based on the degrees of freedom. So the chi-squared is a distribution like the t that will have degrees of freedom. Just like the t, it has degrees of freedom. Amazing note right there. Just like the t, the chi-squared has with it degrees of freedom. So you can see right here we have the normal, no degrees of freedom with the normal. We have here the t-curve, which does have degrees of freedom. We have the chi-squared, and not for this class, there's the f, which is the ratio of two chi-squareds, and the f has 2 degrees of freedom, 2 types of degrees of freedom. We won't do that in this class. It's a ratio of 2 chi-squareds, but just like it, yes, just like the t, the chi-squared has degrees of freedom. You got it. Now watch this. First person to tell me the degrees of freedom on this gets maxed out extra credit. Here we are with our example. The formula for the degrees of freedom are rows minus 1 times columns minus 1. So to solve for the degrees of freedom, you have to do rows minus 1 times columns minus 1. Zach already got it. Who else is going to get it? Someone else. Zach's maxed out. So it's rows minus 1. So we right. There we go. Who else? Brianna's not maxed out yet. Brianna, you're maxed out. You got it. Rows minus 1 times columns minus 1. You ready? Here's the trick. This is a 2 by 2. So what is, if we drop a finger and do 1 times 1, we get 1. I'm going to do one more for you. You ready? Okay, so now Brian's going to draw. I'm going to solve this one myself. You guys might solve it as quickly. I'm going to pause for like 10 seconds. I want people to start putting the degrees of freedom. First person who gets it, gets it. So I want you guys to tell me the degrees of freedom on this one. Who can tell me, Brian, this is a something by something. First person gets it. There's this many degrees of freedom. Audrey, you're right. Audrey's maxed out. Audrey got it. This is a 2 by 3. And thus we would have, my brain's breaking. 2 by 3 turns into a 1 by 2. We have 2 degrees of freedom. 2 by 3 turns into a 1 by 2, 2 degrees of freedom. You can also delete off this right here. I'm deleting one row and one column, and we'd get the following. And that right there is the 2 degrees of freedom. It's not exactly those 2 cells, but you can view it visually this way. So let's say we were to do a 4 by 5. 4 by 5 is how many degrees of freedom? So 4 by 5. 4 by 5 is how many degrees of freedom? First person. A 4 by 5 is how many degrees of freedom? So rows minus 1 times columns minus 1. Sophie is right. First person. Sophie got it right there. So 4 by 5 would look like this. And you can check your answer by deleting one row and deleting one column. And this is a 4 by 5. So 4 by 5, when you do 4 times 5, you reduce it down to 3 times 4. And 3 times 4 equals 12. And then check your answer in here by seeing if there's 12 boxes and you've done it properly. Does that make sense on how to find the degrees of freedom for these problems? It's literally the amount of rows minus 1 times the amount of columns minus 1. This formula right here will solve for the degrees of freedom, and the degrees of freedom tell us which chi-squared we are using. So there's different shapes to the chi-squared. It looks differently depending on which one we're using. So we might be using a chi-squared with 1 degree of freedom, 2, 3, 5, 10. And so we literally just solve out for the degrees of freedom, and then it'll tell us in the applet which chi-squared we are using. Like when we put in here 1, 2, 3, it'll solve out and it'll show out which one we're using. Does that make sense there, Brian, and other people who are wondering? It literally draws it out, like when we go to the t, putting in the degrees of freedom for the t solves out which t distribution we're using. So it's like the specific t or the chi-squared. I know, it's so fun. You guys know I love graphing stuff. You guys know that's my favorite. So the degrees of freedom tell you the specific one you are using. So is that you can't pass out the max extra credit. That's a good question, Zach. Great job, and thank you everyone for participating so much. Like the video, comment on the videos, and I'll put the link to the playlist in the chat again. The more you like our videos, the more you comment on the videos. Anytime you see a video, if you can like on it and comment on it, that's my real big thing of advice. Any video you see, if you hit that like button, if you hit that comment button, that really helps out the channel. I mean that. This is me, and even if it's not an ad video, because I won't put that on lecture videos, I'll never put an ad, and we get more ad revenue, and then we can do the pizza parties, we can do that, and maybe like, especially with me traveling back and forth with Texas, I could be like, Brian's in town, time for pizza party. And I'm good at negotiating pizza party prices. Like, I like calling places like Domino's or Pizza Hut or Bren's, or if we had a Hard Knocks pizza party, that'd be amazing. But I could maybe have them do like, we could buy 15 pizzas and they could donate 5 or something. You work for Domino's? Yeah. And if Domino's, because I know they'll do like $4 or $5 pizzas for like organizations. So if we did a pizza party, or if they were to donate some, Hard Knocks is absolutely amazing. I wonder when Hard Knocks will be open again. Hard Knocks is my favorite. It's pricey, but it's, oh my gosh, the sweet pea or the pulled punch or the, what am I thinking of? The bone crusher. Hard Knocks would be amazing. Well, so if you want to help with the channel, check out the videos, especially the ones with the ads. But any video you watch, go down there and just hit like on the video and add a comment underneath the video, because that helps the algorithm right there. You got to go get Hard Knocks, Zach, as soon as you can, as soon as they're available. It is like $15 a pizza, but oh my gosh, it is so worth it. I would told there would be Domino's at one thing on a. Oh, Little Caesars is good. Little Caesars is really good fresh. If you get a hot and ready pizza and you eat that, oh, so good. And you get a dipping sauce. You guys know I'm always hungry on stream, so yeah, exactly. Awesome. So we know what it's gonna. We got our middle lecture break. We're good to go. Let's hop back into this. You ready? So here we are. So like, comment, subscribe, all those YouTube things we say. So we have right here that something is either independent or not independent. That's how we write the null and alternatives. So right here. That is too crazy, Jay. That is too. Crack me up, Jay. So we have here that's large values of chi-squareds. Let's look at this. Are going to give us a small p-value. So let's look. If we put in a very high value of the chi-squared, the p-value starts to go down. If you put in a very low value of chi-squared, the p-value starts to go up. We got the pizza fights going on here now. Deep dish versus everything. I would love some deep dish, but I'm a New Yorker, so you know I'm partial towards my thin crust. You got to fold the pizza over and eat it like this. I don't know what accent that is. So if I try to do New Yorker, it sounds like New Jersey pizza. So oh, I'm gonna stay on track here because we got about 20 minutes left and we'll finish up. So with this in mind, is the chi-squared the same as the f? No, the chi-squared is not the f. Great question, Abby. The chi-squared is its own thing with its own distribution. So the chi-squared is its own distribution right here. So the chi-squared, if it's very large, will lead to small p-values. And if the chi-squared is, if the chi-squared is very small, it'll lead to high p-values. So taking a look at this right here, we're going to test some cars right here. Let's take a look at the cars and see what's going on right here. I need someone to write the null and alternative out. William, you're breathtaking. What is the null and alternative? You guys are awesome. What is the null and alternative? I can't remember how to do this. I'll give you guys a hint on the screen, but you guys got to help me out. You guys got to help me out with this null and alternative. I'm trying to figure it out. Who can help me? Zach's got it right there, and Elizabeth. I think we're maxing out Elizabeth right there. Maintenance experience is independent of the type of car someone has. Exactly. Great job. Maintenance experience is independent of the type of car someone has. And then the alternative would be maintenance experience is not independent. Oh, it's literally on the screen right below. Remember, we got to practice this. We got to get it down. Maintenance experience is independent of the type of car someone has. Maintenance experience is not independent of the type of car someone has. All you have to do, like we've been practicing all today, is just put independent between them. You go between these two words and you write in here independent, and you have survival is independent of class. Survival is not independent of class. And thank you for all of our visitors today. We don't mind if you come by and say hey. I've been told I look like John Wick before, I guess, especially with the beard. You know, if we got Keanu Reeves to do an open, that'd be awesome. Keanu Reeves and Davey 504 to do our opening. So, it's not going to happen. So, I say that and then it happens. So, what do we have going on right here? Get ready. The first thing we're going to do is we're going to look at our observed values. Our observed values are how many cars we literally see getting regular and unexpected maintenance. Awesome, Logan. And then our expected values are solved via the formula row total times column total over grand total. We're going to max someone out on extra credit. If you're following along, you should know after you get the observed and get the expecteds, what do you get next? Correct, Abby. You're 100% correct, Abby. 100% correct, Abby. After we get the observed and the expecteds, Barbara, I will take that for max extra credit. You can totally find the degrees of freedom right now. And there are 2 degrees of freedom. You can find that. I will take that. That is a good answer right there. You can find the degrees of freedom. There's 2 degrees of freedom because this is a 3x2, and then it turns into a 2x1. Who else knows what we'll find next once we have the observed and the expecteds? Elizabeth, you are right. We're going to find those cell chi-squareds. So once we get all of these observed and these expecteds, we will get the cell chi-squareds, which are all behind my head. Now, what do we do to all the cell chi-squareds? Once we have all the cell chi-squareds, so remember, observed, expecteds, cell chi-squareds. So what are we going to do to all the cell chi-squareds? Who's going to get maxed out by telling me what I'm going to do next to all the cell chi-squareds? I see it right there. Joelle and John said add them up. And also I'll go John right there. They are going to take the sum to get maxed out. Everyone up to Jeffrey gets maxed out. So I think yes. And Emma, why not? Okay, I'm going to stop. But we're going to add up all these right here. And here's where we got to pause and understand what's going on. This is the Pearson chi-squared test statistic. This is the Pearson chi-squared test statistic. Let's review. We have all of our observed. And from the observed, we will then get all of our expecteds. So we did row total times column total over grand total to get all of the expecteds. Row total times column total over grand total to get all of the expecteds. From all of the expecteds, we then found the cell chi-squareds, which were observed minus expected squared over expected. So we had to do all the observed minus all the expected squared over all the expecteds to get all the cell chi-squareds. From there, we took all the cell chi-squareds and added them together to get the Pearson chi-squared test statistic. I know it doesn't say Pearson chi-squared test statistic, but that's specifically what it is. Last but not least, this is a 3x2. So a 3x2 turns into a 2x1. There are only 2 degrees of freedom here. So from here, we have the chi-squared test statistic and we have the degrees of freedom. So with the chi-squared test statistic and the degrees of freedom, what am I going to go? I'm going to go to a what now to plot this? Who's going to get maxed out by telling me, Brian, you should go to a what to plot this? I should go to a what to plot this. Who knows for max extra credit in the chat? Brian, you should go to a what to plot this? Max extra credit on the line here. Who's first? I'm only going to call the first person's name. You got it. Brian starts with an A. Close, Oliver, close. Oliver, I'm maxing you out because you took a shot and no one's talking. Basically, and you're kind of right. Oliver's kind of right. So applet right there is maxed out. You got it right there. It's the reason we're not going to go to the T applet is because we would go to the chi-squared applet. So you would do the T when you get a T, but we're going to go to the chi-squared applet, and we're going to put in 2 degrees of freedom. Put in the wrong spot. I did that last class too. And then our chi-squared test statistic was 10.828. And there it is right there. We could round it. But the p-value, which is behind my head, is very close to 0. The p-value, I can zoom in and bring it up here a little bit. There, it's behind my head. Why? There we go. It's very hard to see. If we get maxed out, you can keep working. Tell me. Make sure to email me and say, Brian, I'm maxed out. So make sure to email me and say, Brian, I'm maxed out. So make sure to email me. Okay. So we have done it. We have done the chi-squared test of independence right here. All we'd have to do now is plot it and get the p-value, and there's the p-value. Now the p-value here is low, so what are you going to do to the null? The p-value here is low, so what are you going to do to the null? The p-value is low. Low. I didn't say it. Reject the null. You are right. The p-value here is low. Reject the null. You guys got it. If the p-value here is high, just let it fly. Now I want someone to tell me. You have to put in the chat both answers for this. we're going to test something right here with different versions of the test again. So we have here version A and version B. And we have here pass and we have here fail. Sorry, there's a lot of people fail right there. I want you to do the chi-squared test of independence. And I want you to tell me both the p-value for this and the chi-squared. So you can get maxed out on extra credit. You can answer either one. You must tell me the chi-squared on this, and you must tell me the p-value on this. This is a very good theoretical question. So you can tell me either, you have to make sure I don't just type a number because I won't know which one you're saying. Tell me the p-value or the chi-squared on this. Or the degrees of freedom I'll even accept. The p-value is 1. Sneh, you're right. The p-value is 1. The p-value is 1 for this. What is the chi-squared and what are the degrees of freedom? The p-value is 1. You are totally right because these differences are most likely by random chance. The degrees of freedom are 1. Abby is right. Degrees of freedom are 1. The degrees of freedom are 1 because this is a 2 by 2, so it's 1 degree of freedom. Who knows the chi-squared? No one said the chi-squared yet. The chi-squared is basically the discrepancy we see. So what's the chi-squared on this? I know that, Rachel, you'll see how I know the p-value here in a second when I know the chi-squared. What is the chi-squared on this? Utang is maxed out. Utang is right. The chi-squared is 0. So the chi-squared is 0 because we see no differences. Do you notice how there's no differences right there? So the lowest we can get for differences is 0. So with a difference of 0, then what we see, or something more extreme, would have a probability of 1 because chi-squared is always shaded to the right. Huge note to take right there, the chi-squared is always right shaded because we're looking at differences more extreme than our difference. So this is the chi-squared test of independence, and we notice that we observed no discrepancy. There's no difference right here. Everything was what we expected, because if you were to draw over here the distribution of what this looks like just pass fail, it would look identical to that. So all the cell chi-squareds would be what? I want to see in the chat. All of my cell chi-squareds, if I solved for every cell chi-squared, every single cell chi-squared would be what? Nice job, Rebecca and Summer. Every single cell chi-squared would be 0. And then what do I do to all of these zeros when I find them? When I find all the cell chi-squareds, I sum them up. And what do you get when you add up all the zeros? You would get 0. And that would be your chi-squared test statistic. And what does this tell me? This tells me that all the differences here that I see between A and B, which are none, are probably just due to random chance. So what would you say here? That somebody passing and failing the test is independent of the version they took, or you think it's not independent? What do you guys think? Someone passing or failing the test is independent or not independent? It's independent, Brian. Amazing job. It's independent because remember the null was that these two are independent and you would not reject the null. And look at that. The two being independent means that you passing and failing wouldn't matter on which test you take, or at least like the probability would not change. Now, you don't have to have this be perfectly flat, but this is like the most extreme example where we're like, well, we definitely don't reject the null. There's no evidence. It seems like these two are independent. You know, we retain the null or fail to reject the null, and we would say we don't have any evidence. We've got one more end to the final example, and then we got one last example. Whenever we see differences that occur, I should mention this, in your jump output, here's your chi-squared test statistic, and here's your p-value. Please take a note. That's the chi-squared test statistic. That's the sum of all the cell chi-squareds. So this value right here is the sum of all the cell chi-squareds, and this one is your p-value. So that is your p-value, and then the one to the left of it is the sum of all the cell chi-squareds. I like that right there, William. And so where do you notice the differences are? What car should someone buy if they only want to get regular maintenance? If someone only wants regular maintenance, what car do you think they should get? What car do you think they should get if they only want regular maintenance? Toyota, you're right. Brian, you're maxed out again. I think you're already maxed out. Utang, great job. Because the Toyota, if we look at the graphic right here, if we go, given someone has a Toyota, they are more likely to only receive regular maintenance. So that's 4 Toyota cars. Is there stat lab tomorrow morning for the project? You bet. 10 to 12 tomorrow morning, I'll be doing stat lab for the project. The last example is a very happy example right here with Swedish men and cancer. Yay! Great way to end the last major topic. So we have here Swedish men and cancer, and we sampled 6,272 Swedish men. So what do we know right there? I know, fun topic, huh? And we see here, I need someone to write the null and alternative for this. What is the null and alternative for this? I need someone to give me the null and alternative. Fish consumption. Always remember, when you see this, just put it right there. Just go, boom, there's my answer. Like, don't do that, but tell me what it means. Does anyone know? You get maxed out if you know it. Fish consumption is independent of prostate cancer. You got it right there. Both Snay and Sydney, great job. And Rachel, all of you are maxed out right there. And so you know how to do it right there. You know how to write your null and alternative. Madison, you're also maxed out right there. And Elizabeth and Abby and Rachel and Summer and Marina and Rachel and Austin and Hannah. And we're done, Abby. Okay, we're good. Okay, so we need to check our conditions. I think I already copied this one over right here. So when we check our conditions right here, we would have the following. We have condition 1 that these men were randomly selected. Condition, which I guess they were, as long as the problem says they were. I mean, if we're doing a research, we need to make sure we do that properly. Condition 2 is less than 10% of all Swedish men were selected. I think it's fair to say that this is less than 10% of all Swedish men. So I would say that there's at least 62,720 Swedish men, so we're probably good on that. And then condition 3 is its count data. Well, both of these are categorical variables, so it passes count data. Condition 4 is that we need at least 5 successes and at least 5 failures. Well, watch this. The smallest number here is this, and the smallest number in the columns is this. So we've got smallest row total and smallest column total, and 124 is a row total. So we go row total times column total divided by grand total, and we would get the following answer, because that's the expected. It's already solved for us right there. So we have this right here equals 9.21, and we do pass. The smallest expected cell count is greater than 5, so they're all greater than 5. It's got some here that are blanked out that you can work for, and you can see if you can solve. So, you know, check them out, see if you can solve it, but this is just like a practice slide. But we see here that the smallest expected cell count is greater than 5, so they're all greater than 5. Streamlabs is so quick sometimes, and sometimes it's so slow. I don't know why. Here we are. We need to take, once again, the Pearson chi-squared test statistic and find the p-value from it. So I need someone to help me out. How many degrees of freedom are in this graphic? So let me see. I see there's a question too. Will all this be given to us on the test? Yes, we'll mostly give it to you. We might ask you to solve for cell chi-squares or things like that. We won't have you solve the whole thing. How many degrees of freedom does this have? I've only got a few more. Ah, careful. Don't worry. That's a mistake. Don't worry. Oh, no. Don't worry. Everyone's saying it's all right. We've done it. We've tricked everybody. Julio, nice job. You got it. Because this is a what by what. How many categories are here? There's 4 and 2. So it's a 4 by 2. Does everyone see there's only 2 categories for prostate cancer? So do the hand trick. This is always a great way. 4 by 2, reduce it down. How many degrees of freedom are there? So let's see the chat start to fill with how many degrees of freedom there are. Everyone's getting it right now. It's a 4 by 2. Be careful. People look at it. Don't take a screenshot now. And they think it's a 5 by 3. It's a 5 by 3 that changes your answer. But it's a 4 by 2, unless I'm miscalculating. It's a 4 by 2. So 4 by 2 should have just 3 degrees of freedom. And we can, well, it's not solved for us, but it's 3 degrees of freedom. And so now we go over and we have 3 and 3.677. We go back to our applet right here. Oops. And we type in 3.677 and 3 degrees of freedom. And there's the p-value right there of 0.299. So the p-value is high. I should just let the null fly. Don't reject the null. So I'm going to fail to reject the null. And look at this. Do these look independent or do they look dependent? Does it look independent or dependent? Does the differences between men, Swedish men, and the amount of independent, you are right. And don't always judge it by the graphic. Don't look at the graph and be like, well, but it does look independent. So it does follow what we would expect, that it looks pretty independent. And that does it. We have done 2 examples. We've done a lot of great work. That's it for the major part. I will be giving out some awesome extra credit next class. Let me bring back up the video. And if you guys want, if you're leaving class now, check out this video right here. I know, yeah, so check it out. And there we go. And so check out this video right here. Ask your questions. The test will be very similar to the last one. Like the video, comment on the video. You don't have to watch the videos. No one's required to do anything. Can you please work through the polling and gender questions in chapter 19 homework? Yeah, we can do that. That'd be awesome. So let's do the polling and gender question. That's going to be a jump problem. I'll probably go, can we help chapter 17? That's due tomorrow. Yep. So we will do, I think Neely's got the first question, and we'll do a few chapter 19. And so I'm going to go grab probably just a quick snack or something, and I'll be right back here. So hang out for just a moment. It's the end of class. If you're leaving, go check out the video. Remember, the more you like videos, the more you comment on them, that helps out the channel. You're not required to do anything, but it's awesome. I appreciate when you guys do it. So I'll be back here. Can we go over 40 from the project I saw off Star's video, but I was still confused? Yeah, we'll do that at the very start here, Abby. And then we'll do Neely's question. Then we'll hop to chapter 17. So the order is going to be Abby's question. So we can do a very quick thing on the project. And then we'll go to Neely's. And then we'll go to the next one. So, oh, you got a Chegg ad? I guess that's all right, right? It's education. So I could actually limit it so you don't get Chegg ads. But it does it by like who you are and what your what your age group you're in. So like, oh, as a college student, we're gonna advertise Chegg to them. So you don't I mean, unless you want to click ad, don't click an ad. So that's my suggestion. So awesome stuff right there. I think I can limit it. So maybe I should make it so Chegg isn't on there. I'll go in and start limiting ads. If you guys ever get any weird ad like that, tell me. Or an ad you don't think should be on there, talk to me because I can control certain ads. So there we go. Okay. I'll be back here in just a moment. So see everybody soon. Bye.
turn the project in early.
Hey everybody, we're back. So let's see. There were some project questions to start, so let's pull up project stuff. Oh my gosh, we got so many things open. So we're going to pull up project stuff here to start. I think people wanted 4E. So let me go and get the project. So we need to go to the Stats 1 webpage and talk about 4E. So if you're here for the project, ask the questions in the chat related to the project. Project 3, 4E. So we want to do 4E on the project. Where it is? Here it is. Let me download it again. Open it. Here we go. So we'll talk about 4E here. I try not to answer questions too specifically. I try not to give away the answers. It's hard not to. Here we go. So if you're here for 4E, and then we're going to do, we're going to do Neely's question next, I think that's the order of operations. So let's see. Hey, what is up? Good to see you here, William. Got some Rick and Morty. So we are back. What is the null for question number 4? Question number 4, I don't think you has, well, it's using the previous question. So when you look at 4E right here, in the context of your research on engine life, what would a type 1 error mean? And we're going to do that here soon, Molly. Great question. We will be doing that very soon. And we'll do 4C after this too. So can anyone remember what you wrote out for the null and alternative right here? So you need to know, and great question. Someone said, what is the null? So did you watch the other video, John? Did you watch that? Because I've got them in the other video too. So I might focus more on homework here in a moment. I will be streaming tomorrow morning too. So we'll do a little bit of project, and we'll probably go to assignments. Be careful. Wait. There we go. Neely and Jay, kind of combine what you have right there. So Neely, make sure that it's mu, because we're testing the mean, and you are right. Can a null be greater than? Yes. The null will have 3 possible signs: less than, greater than, or not equal to. So we always do some value like p mu, or mu1 minus mu2. So we always do p, mu1, or minus mu2. And then we set the value on the other side of it to be equal to a certain value. Okay, cool. We'll do that next here, John. Great. Thank you for looking over, and we'll do that here next. So when you talk about this, Neely and Jay kind of have it together on what it needs to be. It needs to be mu. It needs to be mu, and then the hypothesized value is 3,600. So we're saying that the null is that the mean is equal to 3,500, the true mean. Does that make sense? Is everyone on board with me right there? I don't want to write too much out. I don't want to people just watch the video and be like, that's the answer to this question. And then we'll be doing that here soon. Lauren, you got it. Oh yeah, Neely wants that one too. I'll look at that in a second here, Juan. I'll look at that in a second here. This one wants to know a type 1 error. So in a type 1 error, we have to, and this is very, very careful. I've corrected a lot of people's wording on this because it's very easy to make a mistake. So I'm going to do a kind of example like I did yesterday. So if you think about your professor, they would assume that you're not cheating. Now you have to slow it down. And here's what I ask you to do whenever you do context. So you bet. We got it, Oliver. Whenever we do context right here, I want you to tell me what a type 1 error would mean. And I want you to say it to me like I don't know statistics. So you can kind of say like a type 1 error is when the null is true and we reject it. Now let's practice. In a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. This is a 1, this is a T, this is a 2, this is an F 2 times. So once again, to repeat, in a type 1 error, the null is true, but we reject it. In a type 2 error, the null is false and we fail to reject it. So what is a type 1 error if your teacher is trying to see if you're cheating or not? What is a type 1 error if your teacher is trying to see if you're cheating or not? Any ideas? In a type 1 error, the null is true. So what is true? But you're going to reject that. You're going to believe what? What would a type 1 error be in this scenario I've written out right here? Does anyone have any idea what a type 1 error would be in this scenario? Any ideas? Any ideas? No ideas? Someone's got to tell us. So let's practice. In a type 1 error, the null is true. This is true. This right here is true. Like, I'm not saying I think this. This is literally true. It is true that you are not cheating. Great job, Abigail. So you are not cheating. That is true. But what is someone going to do to the null? And Jay got it right. Someone is falsely accused of cheating. Exactly. So you reject that you are not cheating when they are really not. Correct. Yep. And then so combine what you have right here, because I think right there, great answers, Kelsey and everyone. Because Jay said someone is falsely accused of cheating. That's about the easiest way to tell someone what's going on here. So when you think about this company trying to upgrade, what decisions are they going to make if they make a type 1 error? Like, yes, we can talk about the null is that the mean is equal to 3,600 and the alternative is that it's greater than 3,600. But what does a type 1 error mean? Like, if they reject the null, what are they going to do for a type 1 error? What's the company going to decide to do when they maybe really shouldn't? I'm kind of really saying the answer here. But does that make more sense? Like, the company's going to reject the null and decide to do something when maybe they really shouldn't. And that's the kind of context we need to give it. Like, a type 1 error could be very costly to the company. I'm dropping huge hints here. But does everyone kind of maybe get, does that help the people who are maybe stuck on it a little bit? Like, the company's going to reject this. Because remember, in a type 1, the null is true, but they're going to reject it. So whatever you wrote right here, they're going to reject this, but this was actually true. They're going to say they have evidence of this. So with your teacher, they're going to say, I reject that you're not cheating. I have evidence that you are cheating, but it was true that you're not cheating. Does that make more sense to everybody right there? I hope that helps out. I don't want to say the answers to the question. I literally swallowed. Wait. Oh yeah, I'm back. Okay. Here we go. So someone is accused of cheating when they are not actually cheating as a type 1. A type 2 error would be that somebody is, the null is false, but we fail to reject it. So if the null is false and we fail to reject it, it is false that they are not cheating, so they are cheating, but we're going to fail to reject the null and say they're not cheating. A type 2 error would be someone cheating and getting away with it. So a type 2 error in this scenario would be cheating and getting away with it. Watch this magic trick again. Here we go, right here. Back. Hair is getting so crazy long. What if I go a whole nother year without cutting my hair? It's so crazy. Okay. Is not statistically significant. Does that mean it's likely due to random chance? Yes. If it's not statistically significant, it's likely due to random chance. Yeah, I think we did 4E really well. So I think people are understanding 4E pretty well. I think there was a call for 4C. So let's look at it. The null, and so Jay, the null always has the what sign. The null always has the what sign. The null always has this. What does the null always have when we write in statistical notation? You got it, Kelsey. Nice job helping out there. Kelsey, million points. The null always has the equal sign. So the null has the equal sign. So that should be a big hint right there. The null has the equal sign. Great job right there. Awesome, Jay. Thank you so much. And thanks for asking it again. Sorry if I miss a question. I try to hopefully not miss any. This one right here is the confidence interval one. So a confidence interval can be used to perform a two-tailed test. Any value outside the interval is rejected at an alpha level 1 minus the confidence interval. Are you able to reject this value? So I like doing an example here where I talk about, can you do the question? Yes, we can do that here soon. And so I'm going to tell you that I think a Hard Knocks pizza will cost between $10 to $20. A Hard Knocks pizza costs between $10 and $20. So what values would you reject? Can someone give me a value that you would reject? If I think a Hard Knocks pizza costs between $10 to $20, what is a value you would reject? Oh, it's so good to hear that, John. What is the value? 25. You're exactly right. You would reject 25. So if you were to make a confidence roll here where you had from 10 to 20, so we'll do it here with space pen. 25 would fall outside that interval, and it would also be a value that you would reject. You would reject 25. It kind of works this way. A statistician might start arguing with me. I know it works better when I draw it like this, but I do know it technically be, let me see, if we hypothesize 25, then we would land below it. Yes, it would technically be down there. Don't ask why. It deals the way that the test is done. But it would just be an analogous side to it. It would still be the same distance away. So it has to do with the standard errors, if you're wondering. And so what do we see right here? That any value outside the interval, if this is a 95% confidence interval, is like doing a two-tailed test with what alpha level? Any confidence interval, how can you find the alpha level of the test? Any confidence interval is like a two-tailed test with this alpha level. What is going to be the alpha level for this right here? What is going to be the alpha level for this? Any ideas? Does anyone know? I'm stuck. I forgot it. I keep forgetting things. I need your guys' help. Does anyone know how we could get? You're right. It's 5%, 0.05 alpha. Alpha can be written as a percentage, or a lot of times you will see alpha written as a decimal, but it's like 5% type 1 error. And so this is the alpha level right here. And we see that we could reject that value because it's outside the interval. So all you have to do is look at your interval. Ate some Pop-Tarts and swallowed the wrong way. And so we get right here. Can you also briefly go over which number to use for 4B? Is this 4B? Let me see here. Interpret your 95% confidence in context of the problem. Whoops, wrong. I was totally on highlighter. Watch that tape again. I was on highlighter. I don't know what's going on right here. So when we do this right here, we would use the 95% confidence data. So the numbers you will use, I'm going to do a totally different thing than you guys are doing. We have the haircut data right here. Thank you, Mark Rober. He was doing online classes for a while. Like he was doing just random, maybe he ran out of ideas, but it's pretty cool. Mark Rober, great guy, doing some really good educational stuff. And there are videos on this. If you're wondering, I am doing it a little quickly. So the 95% confidence interval is located right here. So I am 95% confident the true mean age, I am 95% confident the true mean age of people who came to get haircuts is contained in the interval 30.13 to 33.07. You forgot a lot? Are you sure you could? What did I forget? Oh, did I forget a lot? What did I forget? I totally forgot. What did I forget, Abby? Oh, I forget a lot. Oh, I see what you're saying. You're saying, I do forget a lot. I see what you're saying. I was like, I forgot a lot. I was thinking like a lot was something I forgot. I do forget a lot. I don't know. I need your guys' help. I don't know. They're saying Brian can't teach stats anymore because he can't remember anything. He's always asking his students questions. So you guys gotta help me out because I don't remember this stuff anymore. I need your guys' help with these equations and stuff. So I like that right there. For question 3, do we need to have a histogram and box plot or pick one? For question 3, you will be doing this right here. So you will get the histogram and box plot. You will take a graphic just like this right here. Does that make sense, Caroline? Caroline, you will take a graphic similar to this, and that is what you will get, and that is what you will get right there. I know, Abby, they're gonna hire my students to teach for me. They said, Brian, your students know more than you. We don't know how that's possible, but we're gonna have Brian's students teach. Yeah, awesome, Abby. Great. I mean, Caroline. I think we're gonna head over to chapter 17 homework. Are there any more questions about the project? There's the project video, and I will be streaming project help tomorrow morning. So I will be doing tons of project help tomorrow morning, going through every question people have. Maybe I'll just start from the beginning and do very similar things to the project and kind of talk through it and take questions from people as we do it. So can we do chapter 19? I think so. I think we're gonna do. What did I say we're gonna do? I think did we do a video on chapter 17 yet? Let's do a 19. I think people wanted to see the political affiliation one because that one is best done in jump. And great job on everyone who's ahead of the game because I think tomorrow night chapter 17's due. And so we will. And thank you everybody for liking the video. How many people do we have right now? We got 55 likes and 29 viewers. Thank you so much. We go here. I'm almost there. I'm pulling up the assignments right now as we do it. Go into here. Wrong button. Okay. Chapter 19, we're going to do the chapter. Is it quiz or homework? Where's the political affiliation one? Need help with the chi-squared. And chapter 19 is hard. Which one is the political affiliation I was on? Quiz or homework? Let's see. I might have found it. Made it go away. That's such a big thing right there. There we go. Epidural. Wait, found it. That was it. Okay. Here we are on a chapter 19 assignment. We'll go to chapter 17 here in a second. So let's take a look. It's on both of them. Awesome. Let's get it done. Let's learn how to do it. Okay. So we only do the chi-squared test of what? We only learned the chi-squared test of what? I need help. I forgot everything. There we go. I swear, you guys can rewind the tape. I wasn't coughing earlier. I just literally don't know how to eat because it was like, I've got 2 minutes. I'm going to eat Pop-Tarts and healthy and, yeah, sarcasm. And didn't eat properly. Don't know how to eat. I failed. So, I'm totally good, I swear. Rewind the tape. I was good for a long time. Um, write an alternative hypothesis right here. Okay, what do we do? We've got gender and political party. What do we do with gender and political party? Gender is blank of political party, or political party is blank of gender. What will the null be? Gender is this of political party. The null has to be independent, and the alternative will be is not independent. So the null is independent, the alternative is not independent. You just go gender is independent of political party, gender is not independent. And probably people are watching this, and just to realize it literally goes back to every time you write a null and alternative, you put independent. Maintenance is independent of type of car someone owns. Maintenance experience is not independent. And then you go right here to the previous one, and you literally look at right here, someone's survival on the Titanic is independent of their class. Someone's survival on the Titanic is independent of their class. So is not independent. So might have messed it up. Someone's survival on the Titanic is independent of their class. Someone's survival on the Titanic is not independent of their class. All you do is use independent between the two, and then for the alternative, you use not independent. So make sure you know that trick. It's a really good trick for writing the null alternative, and most of my Pearson questions follow that trick. If I see one that doesn't, I'll explain why, and then we can tell you the answer. Are the conditions for these inferences satisfied? It's count data because it's categorical. Be careful they switch the orders of yeses and nos. Are these randomly selected people? Sure, I'll assume that your poll was random. I wish you said random, but I will assume that it was random. And now here we get to the tough one. This is one that people will do too quickly. People will just say yes, probably, and it probably is met. But truthfully, what you have to do if you really want to solve this is you have to know if the expected cell counts are all greater than what? You have to know if the expected cell counts here are all greater than what? I have to know if all of the expected cell counts are greater than what number 5. Nice job, Abby. So I have to go here, and I have 87. These are not the expecteds. These are not the expected. And I'm making sure I'm doing math right. These are the totals. And that is going to be 116, which will help me out with this. That's going to be, I should do it in the calculator and get it wrong. That's going to be 84, and that's going to be 99, and so that's 215. Let's double check some math right here, make sure we got it. My 5s look horrible, they always do. And so we have 215. I'm going to go back in time and teach Brian how to write. It's not going to happen. So let's make sure I've got these right. 40, 50 is the easy one. Okay, that's right. 47 plus 37 plus 15, that's right, and then all the other ones are right, I'll assume. Okay, so we're good to go right here. I'm just checking the other mathematics. Okay, we have now the totals, but where would the smallest expected cell count be? Does anyone know, like male Democrat or female this, where would the smallest expected cell count be? Expected cell count is row total, which these are, times column total, which these are, over grand total, which this is. Where would the smallest expected cell count be? I only need to see if that one's greater than 5. Where would the smallest expected cell count be? Which one? Who would it be? Where's the smallest row and where's the smallest column? This is a good way to check. You just have to do smallest row and smallest column. Now be careful because you might think it's independent females. Yes. And it's not due to this. That's not why it's the smallest expected. It's due to this and this. Watch out. I've seen people just go to the one that has the smallest number in it. That's not why it's the answer. It's coincidence. It's just like, well, I guess it is that. But it's due to the 99 being smaller than 116 and due to 41 being smaller. These are the two smallest number. The number on the bottom is always the same. So the two numbers on top, we try to make them as small as possible to see if we have here enough expected cell count. And that's going to be 99 times 41 divided by 215. I'm trying to do it in my head, but my head just can't today. I won't. It's not worth the time. We got to do it. So that's 4,100 divided by that, 4,100. It's going to be like 8.7. I say 8.7. I did that a little quick. I say 8.7. You guys know we always got to solve these in our head. Oh, I was way off. That's what I get. It's 18. We're good, though. It's actually it's close-ish to the number, 18.87. Do I pass the expected cell count condition? Do I pass the expected cell count condition right here? The answer is most definitely yes, because I have at least 5 expecteds for each one of these. Every single one of these is at least 5, so we definitely pass it. So we are good to go on expected cell count. Find the p-value. Now, this is where people are going to get stuck. Now, do not do this by hand. Do not work this whole thing by hand. Here's what you want to do. Is you want to copy this data into your clipboard. Don't copy it to Excel. You want to copy it to the clipboard and do Command-C. Okay, we've copied the data now. I've hit Command-C or Control-C on a PC. It's fine. I'm using a PC and I say Mac stuff. You want to go into here into Jump. And inside of Jump, you want to go to File, New, Data Table. Okay. Is everyone with me right now who's solving this problem where you have to put it into Jump? You want to go to File, New, Data Table. Once you get to a new data table, you're going to have a whole new thing right here. And we're going to expand it. Now, here's where the mistake can happen. Pause. Don't click inside there yet. Don't do anything. If you've clicked inside there, restart. Because that's where a mistake can happen. You want to go here and you want to go to Edit, Paste with column names. Make sure you have not clicked inside of there. If it didn't work, do a new data table and try this again, but don't click inside there. I usually see people open a new data table and they just click right inside of it. I'm like, no, you've changed how it's working. So we go paste with column names and we're good. Now, what you should notice here is this is quantitative and this is categorical. If that is that way, you've done it correctly. If it's not, open a new data table and paste with column names again. So once again, all I'm doing is file new data table and paste with column names. I know the shortcuts, so I can do it a little bit quicker. I'll show you the error way. If you have the following, you've done it very improperly. Don't try to fix it. Just start over. There's a way to fix it, but it's way more work than you want to do. Because all you have to do is new data table and paste with column names and you'll be good. So the way on the left is correct. This is right and this is wrong. If you get this, you've done it improperly. Slow down the video, rewind, and make sure you paste it in properly, and you will get a data table that looks like this. Once you have this data table, we need to go here to Tables, and we need to go to Stack, and we need to click all the categorical ones. So you can click through them, you can add them in there, and now we've stacked the data. So we're going to go ahead and click OK right here. The data has now been formatted for us to use. We could have manually typed this in too. It takes about the same amount of time, at least if you're first learning it. But if you notice right here, we have political party. So let's call this, or that's gender actually. So we have here someone's gender, and then we have party label. So we'll just call this party. And helps it make a little more sense. And I'm going to call this right here frequency, F-R-E-Q. You don't have to change the names of these, but this will help in a moment because these are what these are. This is your X variable. Does someone's gender explain their political party? And now we can go to analyze fit Y by X. So when we go to analyze fit Y by X, we ask if someone's gender explains. You see how we can say gender is explaining political party? And then we have to put in the frequency over here because that's how many were in each group. So the frequency goes into the frequency, which is just the counts. And then we're seeing if gender explains political party. We click OK, and we get the following graphic. Now, what a lot of people will do, I'll show you the bad graphic. Here's the bad graphic to get, is people will get the following graphic that looks like this. This is the wrong graphic. This means you've done it incorrectly and you did not put in the frequency. The frequency will actually give the numbers for each group because right now it's just reading all this right here instead of reading the counts, which are the frequencies. So the counts are the frequencies. This is the wrong graphic. This is the right graphic. So if you saw the graphic I just showed, you did not put in the frequencies. Here is the correct graphic, and here is the p-value, and there is the chi-squared. So the chi-squared is 4.139, which is not that big of a chi-squared. There are 2 degrees of freedom because this is a 2 by 3 or 3 by 2, whichever you want to say it, which reduces down to 2 degrees of freedom, 1 times 2. Remember our tricks from earlier today, or if you're watching this video later, that there are 3 here, or excuse me, 2, almost made a mistake, 2 here and 3 here. So that reduces down to 2. Remember, 2 by 3, 2 times 1. So that's all it is right there. So the degrees of freedom are found. There's 2 degrees of freedom. We know how it's found. We have the Pearson, which is the sum of all the cell chi-squareds, which if we want to look at cell chi-squareds, we can do the following. We can go here. We can put in the expecteds. If you remember that expected I found earlier, the expected was 18.879. There's that value. So I was correct. And it is the smallest. And then here's all the cell chi-squareds. If I were to add together 1.2, 0.79, 0.23, 1.02, 0.68, and 0.995, what would this add up to? What does this number plus 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 this number equal up to? Anyone have any ideas what those numbers would equal up to if I add them up to? If I add up all the cell chi-squareds, what would they add up to numerically or conceptually? All of these cell chi-squareds would add up to what? What is 1.2 plus 0.8 plus 0.23 plus 1.02 plus 0.68 plus 0.1995. What is that up to? If you do the math, what would that up to? There's silence. What does anyone know? Does anybody know? Abby, I've forgotten. I do not know. So these are all the cell chi-squareds. And adding up all the cell chi-squareds would get us the Pearson chi-squared test statistic right here. So if you were to add up all these numbers on the bottom, which are the cell chi-squareds, you would get 4.139. So we get the Pearson chi-squared test statistic of 4.139. Now we're going to know we got it correct if we do see our p-value in here. The p-value we hope to see is 0.1263. And they didn't carry all the decimals. We did, apparently. Hopefully everything's right here. And now the p-value is high. We're going to use an alpha of 0.05. Do I reject the null or not reject the null? Reject the null or fail? My p-value is high. Just let the null fly. So since my p-value is high, I'm going to let the null fly, and I'm going to reject or fail to reject the null. My p-value is high. What will I do? Oh, no, Abby, we can check back on that here in a moment. Since my p-value is high, I am going to fail to reject the null, and there is not evidence. So when the p-value is high, you do not reject the null, and there's not evidence. When the p-value is low, you reject the null, and there is evidence for the alternative. So we do not have evidence. Let's check out. Yes, we got 100. Okay, let's go look at what happened wrong here, Abby. Abby, does your data, let me look at the original data frame. Do you have this right here, Abby? And Neely, did that help out? Hopefully people working on this, that worked for everybody. Abby, do you currently have 2 red columns and 2 blue columns? Can you get to this point right here, Abby? Are you good on this? Do you have 2 red columns and 2 blue columns? How are you doing on this? Okay, you got to this right here. Now go to tables and go to stack. So go to tables and stack. On tables and stack, I want you to click all the blue columns. Do you see this right here? Tell me when you're good. Be like, I'm good on this, I'm good on this. Do you have all the blue columns now in there? Only the blue columns. Just do all the blue columns. Tell me, and then you'll click OK. Tell me if you're good on this. You'll put in all the blue columns, and you'll click OK. Oh, I'm so sorry. You got that right there? Awesome. So does it now look like this here? Does it now look like this? If you're now to here, we don't have to do much else. Are you now onto this area right here? Have you gotten to this part? If you have, we're going to go to Analyze. We're going to go to Analyze Fit Y by X. And with Analyze Fit Y by X, we're almost there. With Analyze Fit Y by X, now all we're going to do is going to put this one here and this one here and there. How are you doing on that, Abby? Are you good on that? Is there another one you want me to do, Neely? I'll start doing some chapter 17 here in a moment. But is there another one you want me to do after this, Neely? I'll do maybe 2 more on here. If there's another one you want me to do. Be like, do the such and such problem. And tell me if it's homework or quiz. We'll do like 2 more on chapter 19. Then we'll do a lot of chapter 17. Chapter 17? Yeah, we'll do chapter 17. Yes, you got it. If you have this, it should work. Make sure you have this here, and this here. Oh, that's the big thing. Yep. And then you'll get this. Awesome. You're good to go. And then we'll do one more. I don't know if anyone... So chapter 17. A lot of people want chapter 17. You got it. Nice work there. I guess we might head over to chapter 17 because we will do chapter 19 after next class. I will do as much as I can in chapter 19, but let's start doing chapter 17 here. Have we done a video on chapter 17 homework? Have we done a video on chapter 17 homework? Have we done a video on chapter 17 homework? I do not have 60 emails. Tell me I do not. I do. And my email box is almost full. Oh my. That's fun. Okay. Okay, hopefully it doesn't. We'll see what happens. I'm scared. Okay, let's do chapter 17. Homework or quiz? Chapter 17, homework or quiz? Call it in the air. Which one will it be? And then we'll come back here. We'll come back. So let's do the homework first. Let's do the homework. Who wants saying that we have? And then we'll do... Is there a specific one you want on the quiz? People want quiz. Okay. And... So let's do chapter 17 quiz. People are saying quiz in chat. If you guys are here, you get to say which ones I do. And hopefully my email box doesn't fill up. I mean, like, literally, because I've space. I should have just bought it. So let's see here. Okay, we got chapter 17 quiz right here. Let's do it. I'm trying to think, did we do a lot of these in last week's video? Did we? I feel like we did a lot of these. I'll do it. I'll do them all again, but I feel like we did chapter 17. We might focus more on chapter 19 after this because they're all in last week's video. But people are here, so you guys, yeah, we did a lot of these. So call which question you want. A lot of these are in last week's video, but I will do them for the people who are here live. Which one do you want me to do? Do the serial question. Julia wants serial question. You got it. And then sports reporter's next. Oliver and Julia wants serial and then sports reporter. So let's go here and find the serial question. And let's take a look at the serial question, then sports reporter. Okay. So we have adults versus children's serial, and then scores on standardized tests. Cool. We'll do all of these right here. Let's do it. So we have right here the serial question. This one is a jump question 100%. Like, don't work this one by hand. You can do it in the TI calculator or in jump. In the TI calculator, you will need to enter in 2 lists. So you'll enter in a list for the, you'll enter in a list 1 for children's serial. You'll enter in a list 2 for adult serial. We can do it inside of jump also. I'm copying the data. So we're just going to copy the data right here with Control-C or Command-C. We copy the data, and then we go over to jump, and we open a new data sheet. So this is done by going to File, New, Data Table. File, New Data Table opens the new data sheet right here for us to work inside of. We're going to go to Edit, Paste with Column Names. So, and then we'll do manually to say Paste with Column Names. So we've got the data pasted in here with column names. And so now we're going to go to Tables, Stack, and then we're going to click both of these columns right here. So I'll pause right here, make sure to slow down the video or pause, but you just have to get the data into jump and get it stacked, and you will get the following. So you want to see that it looks like this. Now make sure you have the variable types correct. If you didn't paste with column names, it will not paste in the correct way. So slow down the video and make sure you follow each step. I'll show it again real quick. 1, go to a new data table. So all I did is File, New Data Table, and we're in a new data table. 2, paste with column names. Don't paste with column names. Start over if you pasted, paste with column names. 3, go to Tables and stack them and double click both of these right here. Now you'll get a new data sheet with the type of serial and with the quantitative amounts someone has. If you've done this, you have the data properly in here. We can now go to Analyze Fit Y by X, and we can put the label as the X and the data as the Y. Remember, this is a quantitative variable that we're analyzing over 2 different groups. We click OK, and then we click the t-test, and it'll actually do the confidence interval for us. Now, I might not go through it fully in this video, but it is in the last video that you should know all of this output right here. You should know every bit of this output right here and what it means, that this difference right here is Y bar, it's Y bar children minus Y bar adult. The standard error is the equation for the standard error. You didn't see label and data and analyze. Here, wait. You go here and you go to fit Y by X. Are you under fit Y by X? Which part are you on, Oliver? Did you get to this right here? Did you get to... I think it was the last video. I think we did it last class. And you'll see comments down below. You got it, Oliver? Awesome. And so I think it was last class, and you'll see a lot of comments on which thing to watch. So, oops, I put that in the wrong spot. That goes here. And we go here, and we go to t-test, and we've done it. So there is the t-test. And here is the interval for us. The interval goes from 31.33 to 39.86. And I think that was it. Children's cereal have on average between lower rounding more than adults. Let's find out. I'll check it. So 31.33, 39.86. And it wants 2 decimals, 2 decimals. Awesome. I got afraid. I thought I get some. I thought we did this also. Maybe I feel like I'm going mad. I don't know. I swear we did these ones. Of course, I've done these problems like 100 times. But there should be comments below the videos. And it was during last class. Like, it'd be Thursday last week. Or did we do it in office hours? If you can't find it, Sydney, feel free to ask. The sports one is next. Let's do the sports one, the baseball players one. So we want to do the base. Here we go. Sports. Here we go. So we've got football and baseball. And feel free to ask. Like, if you guys can't find it, yeah. I want you guys to get as much help as possible. You're here, so you get the help. And then we'll start doing chapter 19 after we do as many of these as you guys want. So let's do this right here. We need to take this data, and this is what we will use. Now, right here, we have to make sure we know the notation. We have, let's bring it into a new worksheet. Whoa, where'd I go? What's going on? It's not the alternative we want. Want that one. More on that in a moment. Baseball is the first one it says in the problem. So we have here, baseball is going to be mean 1. So baseball, oh my gosh. Baseball is y bar 1, and this is y bar 2. This is n sub 1, n sub 2, s sub 1, s sub 2. So will you work on any of the BS470? Yeah, Evan, we'll have to do that. We'll do that later, Evan. You got it, Evan. Let's do that. So I'll do that towards the end here. So come back in a little bit, Evan. You got it, Evan. I know I said I'd do that earlier today, so you got it probably like 6:30, 6:45-ish in about an hour. You got it, Evan. You're welcome. Thank you so much. And so we have here y bar 1 minus y bar 2 over s1, that's right, ish, over square root s sub 1 squared over n sub 1 plus s sub 2, n sub 2, there we go. And this is equal to a t with a certain amount of degrees of freedom. So all we have to do now is plug in our numbers. So this is a little math intensive right here, because if you notice, I've clearly labeled everything I need to put in. So I'm going to go ahead and start solving this right here to solve out the equation to get my t statistic. So the t statistic right here will be, let's see here, s sub 1 squared is 4.07, and we'll do the square of that. We'll divide that by n, which is 32. So I'm going to have to put this as a marker right here. I have to paste it because I need it. So that is the number right here. If you notice, I have to copy paste these things just to make sure I keep track of them. This is this right here. So I just solved for that. And I guess we'll be fine because I've copied it. And then we go s2 squared, which is 2.76 squared divided by 33. And then we add it to the other thing. Okay. So I've now found out the standard error, and I don't think I've square rooted it yet. Square root. What I literally just solved for, this number right here, is this. I just solved for the standard error. So now that we know the standard error is 0.8 or 0.9 something, we know the standard error is 0.86. We did square root it. Good, we're good to go. We can then do the difference. So all I need to do is the difference between the two means, which is going to be 27.68. I'm just doing y bar 1 minus y bar 2 minus 2655. We divide by that. We get a z-score of like 1.4, 1.3. Should have guessed that. T-score. Sorry, didn't say z, said t. Then we're going to take this t-score and we're going to bring it back over here to the assignment. Now we're trying to see if baseball players are older on average. The question says we want to see, are professional baseball players older than professional football players? And since baseball players are mean 1, we're looking for evidence that their mean is higher than the mean of professional football players. So is there a positive difference right here? Is the difference positive? The null will always have the equal sign. The t statistic was computed, and now we get the fun of doing this. There's the t rounded to 2 decimals. We get to guess the p-value. It's a tough one to guess. 3 decimals. I did this last week. I can do it again. So it's a greater than test. It's going to be around 10%. It's going to be very close to 10%, the p-value is. And I'll show you here how I got it in a second. So the p-value is going to be about, it's a little more than 10%. So we should get this last one right. I might get this one wrong. No, this one up here I might get wrong because I guessed it. That is a guess. That is a pure guess on my part. And then we'll do chapter 19 soon after this. You got it. We're going to do more 17 until we exhaust this, and then 19 next. So what do we do here? Am I going to reject the null or fail to reject the null? Here is my estimated p-value, and I'll show you how I got this in a moment. But will I reject the null or fail to reject the null? I need your guys' help. Will I reject the null or fail to reject the null? I'm not even going to read their answers yet. Will I reject the null or fail to reject the null? What will I do? Will I reject the null or fail to reject the null? Here's the alpha. Here's the p-value. Will I reject or fail to reject? Will I reject or fail to reject the null? What will I do? Here's my fail to reject. You're right. The p-value is high. Just let it fly. I fail to reject. There is not evidence. I fail to reject. Okay, now do remember I guessed the p-value. I'm going to show you how I got in a moment. Did I get the p-value right? Nope, I got the p-value wrong. I was going to put in that. Would that have gotten it right? So it's got to be a little bit bigger. Ooh, I'm going to take 2 more guesses. Really? It's so close to this. Is it really going to be like this? Went the wrong way on it. I said about 10%. You know what I should have just guessed? I said it's about 10%. I should have just guessed 10%. I was like, it's about 10%. I should have just went with what I said. If I'd said 10% and guessed that, I would have been right. Okay, so how in the world is Brian getting this? Well, one, I've done these problems a lot, so I know how p-values really work. But here's what we have to do. We have to go here to 2 sample t, degrees of freedom. 2 sample t, degrees of freedom calculator. Okay, so I'm going to put this in the chat right here. Here's Charlie Quick's 2 sample t, degrees of freedom calculator. And so in the chat, we have to go right here. And so if you see this website right here, this is the 2 sample t, degrees of freedom calculator. What do the degrees of freedom tell us? They tell us which t we are using. So we have to look at our problem, and we have to take this information. Sample size of 32, sample size of 33. 32, 33. Standard deviation of 4.07 and 2.76. 4.07 and 2.76. Now I know the degrees of freedom are 54.34. So now that I know the degrees of freedom, I have to go to statdistributions.com t. And so I bring over my stat distribution and I type in 54.43. So if you remember properly, that was the degrees of freedom I got. So I go back here, I put in the degrees of freedom, and then I'm going to put in my t statistic. My t statistic was 1.31, and I plot to the right of it. So it's a tiny bit less than 10%. So does everyone see the steps right there? Let me put the t distribution in the chat. Let me repeat these steps for you when you have to solve for the p-value from a test. The steps are as follows. Look at your problem and find out all of your sample sizes, which are right here, and your standard deviations. So we've got our sample sizes and our standard deviations right here. I am then going to take this information and let the solver solve the equation by putting in my sample sizes and my standard deviations and getting the degrees of freedom. This only tells me the shape of my t distribution. So here is the shape of my t distribution. Like if I change this right here, it'll change it to look like that, but that's not the degrees of freedom it has. It just tells me which t I am using. So once we find the t distribution we're using, we enter in the t-score for it, and then we get the p-value out of it. Who feels like you cannot figure this? Oh no, we will figure that one out. We will do that. We will figure that one out. We will get that done. Does this make sense right here? How do you know it is right tail? Great question. It is right tail because the question had us see if it is greater than. So since this is shading, this is to the right, we will shade to the right. If we had done less than, we would shade to the left, and it would be left tail. If we had does not equals to for is it different, we would shade both sides. So just to repeat, this is the does not equals, this is the greater than, this is the less than, and this is the, generally I use this for confidence intervals. So if it says build a 90% confidence interval, I would type this right here to build a 90% confidence interval. Oh no, we'll do one more chapter 17, then we will do that one right there, Neely and Abby. So thank you for hanging out, Neely and Abby. We'll do one more 17. Researcher collected, same quiz. Cool, let's do researcher collected. A researcher collected. What did the researcher collect? Yes, you got it. A lot of people. Researcher collected water samples. Cool. Okay, so we got it right here. A researcher collected water samples, and they're gonna see the differences between the amount of the pH level in certain rain levels in 3 locations. They've got L, M, and S location. Now, close your ears if you want, but this would be better analyzed by an ANOVA, which would tell us the analysis of variance in here. But we're going to do a 2-sample t-test by comparing the L location versus the S location. Now, what is a quick trick we can do to know the answer to this one? The blank has the blank. What is a quick trick we can do when writing statistical notation for a null that we know we'll get the right answer every time on this one? If we know this trick, we know we get the right answer. It makes this question very easy. The null has the what? The null always has this. We never put it anywhere else. What does the null have? The equal sign. You're right, Kelsey, right there. Nice job. The null has the equal sign, so we got that one correct. What are our assumptions and conditions? They're blending randomness with independent, not independent, independence assumption. This right here is that they were random. Then we have here that they're nearly normal. I wish they said less than 10%. My Pearson, you need to up your game. You need to put less than 10%. That's also what we're assuming too. But it's kind of an infinite population. It's rain. So we're looking at the pH level of like water in locations. So they can't really oversample. They can't take all the water, but I wish they put less than 10% in there too. What conclusion would you draw from this? Well, what's the p-value? My p-value here is very what? My p-value is very, 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 very what? We'll do one more. This is a very short one. But what is my p-value right here? We're going to reject the null because the p-value is low. P-value is small, so I reject the null. And if we reject the null, is there evidence for the alternative? I'll extend 2 seconds there, Connor. So the p-value is low. I reject the null. And is there evidence for the alternative? Would there be evidence for the alternative? Yes or no? If we reject the null, that means that yes, we have evidence for the alternative. So there is evidence for the alternative. So there we go right there. The notes are so, and I always dislike how my Pearson does this with the notes because our course is through their book and everything. The notes at one point use 25 and 100, and then another point they use like 15 and 40. And then we'll do that right there. So the biggest thing, and this is about the project specific. So, and for mine, just to answer Sydney's, I would reject the null because the p-value is low. There is evidence. But if you fail to reject the null, there is not evidence. Bingo. So right there, Sydney, great question. If you fail to reject the null, there's not evidence for the alternative. So does that make sense? If you do not reject the null, you did not have enough evidence for the alternative. So your p-value would be high. You let the null fly. You don't reject it. Does that make sense, Sydney? And so the biggest thing, and this is the shades of gray of statistics, Connor, is there's so many ways to see if data is nearly normal. And in the project that they're doing, the data will look really unimodal and symmetric. It'll look even better than this. And there'll be barely any outliers. So you could do a goodness of fit QQ plot, you're right. And you could do, they changed it. I don't know if I have the latest one, but everyone's getting a different test nowadays. People are sending like, what's this? I need to update my jump on this computer. I don't know if people got like the latest one, because maybe they have jump, I think jump 16 is out in trial version. I don't know if I have jump 15 or 16 on here, but this fails the goodness of fit test, but we're not testing individual observations. We're testing the distribution of the mean. And since I would say this right here, I'm basically giving away an answer. The sample size here is 232 for the amount of haircuts. This is a very large sample size, so the central limit theorem would state that the n is large enough such that the distribution of means is nearly normal. So I would even say that this sample size of 232 is way large. You could use 40, you could use 100, but we would only need a very large sample size if this was very skewed. It does have outliers, but it doesn't have extreme skew to it. So when you look at it, you look at the sample size, you say, well, the sample size is 232, so the distribution of the mean, there seems to be a lot. Yeah, there are a lot of outliers, but with 232, the distribution of the mean will be nearly normal. And this goes back to the central limit theorem, because here's the craziest thing that I think blows people's minds. The hardest thing about this to remember is that we're not talking about a single distribution, or we're not talking about the distribution of individual observations. We're talking about the distribution of like all of them. We're talking about the distribution of the mean. So let's see right here. Let's give it a shot. My brain's just like fried today. Central limit theorem applet. Couldn't think of the site. So here's the biggest thing, Connor, right here, is even if you have a really skewed distribution, even with a sample of 25, if it's not heavily skewed, when you look at the distribution of the mean, if we keep doing this and do distribution of the mean, we'll eventually see that the distribution of the mean will be even more normal and tighter, and this is the central limit theorem in play. Now you still see, well, there's not even really a skew to it, you still might see a little bit of buildup on this side, but the distribution of the mean is what we're interested in analyzing. Does that make more sense right here? So my distribution right here, this distribution is the top or bottom one. Like, is it this distribution I'm talking about, or is it this one? Like, the one that we see right now, the one I see, is it the top or the bottom one? Like, the one I'm currently seeing in jump, is it the top one? Yep, exactly. Distribution of the mean is the top one, you're right. So the one you currently see right now on my screen is the top one. That was weird. Jump to the screen. The one you currently see is the top one. It wants to snap. It's because I've got it between screens. The one you currently see is the top one, but the one that we actually are interested in analyzing is the distribution of the mean, which is more theoretical. And then we could use the central limit theorem, which is a theoretical thing. It's a theorem, so it's true. And so the distribution of the mean is going to be nearly normal because as n gets larger, the distribution of the mean gets more tighter and more normal. And so we can analyze the mean with ways like the t-scores and the z-scores because those are based on a distributional analysis. Does that make more sense there, Connor? Why this distribution might look bad, but we're actually interested in the distribution of the mean. So it deals with things like the central limit theorem. And my sample size is 232. So just imagine this had a button here that said like 232. And then we could look at the distribution of the mean for a sample size of 232. That's a huge concept. Truthfully, it took me like a year of teaching to be able to be like explaining it. And hopefully I've explained it so people understand it now. But it's so weird because it's theoretical. You don't see this distribution. It's like an idea of like random samples of size 232 will produce distributions. That's awesome. I'm so glad to hear that. Thank you so much. A study examined. You got it, Connor. I mean, Oliver. There we go. You got it. Let's do the study examines. A study examines. Is it this one right here? We got it. Let's do it. We're analyzing the fat content of beef and meat hot dogs. And what do we notice? We notice right here. I think we did this after. I love the timestamps. People put in the timestamps. Because even I can't remember. I can't remember which ones are between. Boop. So when you analyze this right here, I want you to think about what this interval is telling us. This interval right here, we can write it in a different kind of way and think about another example. Let's do mu Darren minus mu Brian. And this interval right here is going to be 20 through 10. Okay, so I play my brother in basketball, and I want to estimate the true difference in a game of 20 on how many points what is the point difference at the end of the game. I want to estimate the true difference between how many points Brian scores to how many points Darren scores. I want to estimate the true difference. So what does this interval mean? Who's usually winning at the basketball games? What would you say? This person scores this many to this many points more. If you want to write like the other interval, we can because it has the lower number first. So I play my brother in basketball a bunch. I play him in 20 games of basketball, or 25, any number you want. And then what does this interval tell you about the difference between the points Brian and Darren score in the game? Who's scoring more points? Think the interval's positive, so what does that tell you? Who is scoring more points when we look at the difference between what Brian scores and Darren scores? Who's scoring more points? Any ideas? We need someone in chat to tell us. Who is scoring more points in the game? What does this interval mean? Oh, you only have to pick Darren or Brian. Awesome. We'll do that real soon here. I think we might hop to that right next, Abby. So you got it. Neely and you, we got this. So who is scoring more points, Darren or Brian? Yeah, we'll do that one since you've been here, Sydney. We'll do that, and then we'll switch chapters right after that. So we'll do Sydney's question, then we'll do the next one. It actually would be Darren. Good guess there, Oliver. Good guess. It would be Darren because think of this. I want you to tell me what this interval solves out to right here. Darren scored 21 points and Brian scored 6 points. So what does this solve out to right here? Awesome. We'll do a standardized test next. Remind me. So does everyone see right here that right here, Darren beat Brian by 15 points. And you notice that we have right here what would be the center of the interval. Does everyone see this is a difference of 15? Now, I'm not saying that this is the true difference, but this is what we observed in a sample. So in a sample of a bunch of games, Darren was getting 21 points on average, because he's always winning the games, and Brian was getting 6 points on average in the games. And then that would be a sample difference of 15. Does that make sense? How the difference we observed between Brian and Darren is Darren on average was getting 21 points in a game. So I'm talking about this down here. So we observed a difference of 15 between Brian and Darren in the game. And then what's our best guess of the true difference? So our best guess of the true difference is that the true difference between Darren and Brian is somewhere between Darren scoring 10 to 20 points more than Brian. Does that make sense there, Oliver? Our best guess of the true difference is that Darren beats Brian by 10 to 20 points. Now, what if we were to change the interval and it were to look something like this now, what would this change about the interval now? There's only one change I need to make. If all of a sudden now in our sample, Darren was scoring 6 and Brian was scoring 21, the interval would now be what instead of what? If this was changed right here, what would change about the interval? There's only one small change I need to make that now that Brian's scoring more than Darren. The interval for the difference would now be what? If the second person has more, you're right, you got it. And these would be negative. And right here in the center of it is the estimate of the difference is negative 15, because that's the center of the interval. And can you tell me the margin of error of this interval right now? So this is the difference right here. And what's the margin of error of the interval? What is the plus or minus on the interval? What is the plus or minus on the interval? Which is a good practice. If you figure out the center of that interval and the margin of error, I'll figure it out. Well, there you go. Nice job, Oliver. You got it. That's the margin of error of that interval. And you see I can figure out the margin of error of this interval by averaging the two numbers together. So I take these two numbers, I average them, and that's the center of the interval. It makes sense because it's like 2 to 6 is 4 is the center. And then the margin of error should be 2.35 because I can take the upper minus that and get that right there. Once again, we should always remember, it's very important to us to remember that when we build an interval, good, I'm not going to cover my head here. Here's how an interval works. We have a center, we have an upper, we have a lower, and you're seeing it right here with literally the same sort of formatting. I'll draw it above it. Here's the lower, here's the center, and here's the upper for this interval right here with the negative 10 to negative 20. And every one of these is a margin of error. So the margin of error is half the length of the interval. So we get a lot of good stuff calculated right here. Do I have a sneeze button? When you think you have to sneeze, you don't have to sneeze. So let's go back and do the rest of the question. So since this interval is positive, which of these has more fat content? Beef or meat? Since the interval is positive, which of these have more fat content? Beef or meat? Since the interval is positive, which has more fat content? Beef or meat? Since the interval is positive, would the first number be bigger or the second number be bigger? Since the interval is positive, the fat content for beef is probably higher. Beef, you are right. Nice job, Huan, right there. And what does the fact that the confidence interval not contain 0 mean? Well, just think back to my Brian versus Darren example. We don't think the difference between these two people is 0, so that means we think there's a difference. So your first interval is negative. If your interval is negative, then that means the second one was higher. So if your interval is negative, meat had more because it would be a small number minus a big number and give you a negative. That's like our example right now. We're currently showing where Brian had more points than Darren. Do you see how Brian in the sample, Brian had 21 points on average and Darren had 6 points on average? So now, and this is never going to happen. He'll beat me in basketball every day. He'll just like drain threes. I'd play my brother growing up. I would guard him. No, so I mean, he would drain threes on me, but we would play basketball against like everyone in our neighborhood, and then my brother would get like 2 3-pointers off because they'd think the first one was luck. He would bring the ball back. You bring it when you're on one basketball rim, so you bring it back, and then no one would be guarding him because he was way out, and you had the line for the 3, and he would just like be like 3 feet back off the line. He'd just be like boom, and he'd just like hit a 3, and they'd be like lucky. And then no one would guard him again, and he would like go back. Like next time he'd go back and he'd hit it, they'd be like, okay, next time someone's on that guy. We can't let that guy just hit threes against us. He'll hit those threes, but he was very good at hitting threes. He was probably like, I don't want to say 60%. I don't know if that's very good, but I definitely know there was instances where he would just hit a 3 and people were like, okay, you got to put some man on him. You got to have him guarded. You can't drill it in. I'm so bad at basketball. He would always win. I'm bad at baseball. I'm bad at basketball. I can run. That's actually the one sport I beat my brother in. I beat him in running. So and he didn't wrestle. Wrestling, cross country, swimming, and track were my sports. Darren was like, he did cross country, basketball, track. I don't think he did anything else. He didn't do wrestling. He didn't do swimming. I only did swimming 1 year. What does the fact that the confidence interval does not contain 0 means? It means that there is a difference because we're saying that we believe that beef hot dogs have between 1.7 to 6.4 grams for fat more, and we're pretty confident that's a big confidence interval. So there is a difference. It is significant. And once again, this would relate to the project question where we say 97% confidence is the same as using a 3% alpha level on a two-tailed test. We check our answer, and we did great. Standardized test question. Let's find that standardized. Is this one it right here? Is this the question right here? I think we found it. Let's try it out. What is the margin of error for this interval? I need some help for some margin of error formulas. What is the margin of error for this interval? So when we do the margin of error, we have to go back to our cheat sheet right here. The margin of error for an interval is half the length of the interval. So does everyone see right here where I've got my margin of error? I'm going to highlight it again. So we can write some formulas right here. We just need to figure out this distance or 1/2 of the whole distance. So what are 3 formulas I could write? Well, if you look at my formula 1, 2, or 3, let's write them out here. The first formula right here would be upper minus center. I did it wrong. Upper minus center equals margin of error. There we go. The second formula is going to be center minus lower equals margin of error. The third formula is going to be upper minus lower, 1/2 of that equals the margin of error, half the length of the interval. So subtract and then divide by 2, you got it. That's exactly right. So you don't need to memorize these. If you understand how they work mechanically, you should be good. That's kind of our goal always, is not to memorize, but understand how they work. So we go upper minus lower, and here's where I think people make a mistake, is that when you do upper minus lower, you have to do 1/2 of it. So we go, I did it. This is what I was going to say. You have to add it. Now you might think, why is Brian adding these numbers? Bright lights, as Kyle would say, bright lights. I'm adding these numbers because the second number is negative. So upper minus lower divided by 2, when you do a positive number minus a negative, you have to add it. So 3.893 and minus 2.09. And the minus cancel, so you actually add it, and then you subtract it, or you divide by 2, sorry. So when you divide by 2, you're getting half the length of this interval. I got 2 separate answers, I believe, so I'm going to double check my work. 3.893 plus 2.093 divided by 2. Okay. I think I must have mistyped something the first time. I'm glad I redid it. Double check your work, double check your math. Especially TI calculators are great that show you what you enter in. So the margin of error, if we made a 99% confidence interval, so Sydney, if you go from 98 to 99, what would that interval do? If you go 98, 99, what would that interval do? 98 to 99, what would that do? It's usually go 68, 95, 99.7, get bigger. So the margin of error would get larger because the critical value increases, and the margin of error would increase as the critical value increases. This one right here is one where I made a mistake. I do remember doing it. I just did it like last week, and this is my 3rd time doing it. Yay! Don't worry, I'm here to help you guys. But I did make a mistake the 2nd time doing it because I didn't read it properly. You may have heard me earlier talking about we're testing the mean. When Connor and I were talking, we were talking about testing the mean. So now we're comparing 2 means. So do we care about a student in a class? Do we care about a student or the students? No, everything will increase. The margin of error will increase as the critical value increases. Yes. Because the interval will get wider. The margin of error and everything gets wider on the interval. We can double check. If you go from a 99 to a 98, everything will decrease. The margin of error will decrease. The critical value will decrease. So do we want to understand a student or students if we're talking about the mean? If we're talking about the mean, do we want to, oh, no worries, yeah. Do we want to understand a student or students? What do we want to understand? A singular student or students if we're talking about the mean? If we're talking about the mean, we want to understand what? We want to understand, I would say students. You are right. Nice job right there, Sydney. So students in non-traditional math classes are expected to score between 2.093 points lower and end up to 3.893 points higher. Good. Let me see here. Students in non-traditional. Yes, wait. Students in, yes. Okay. So you notice here the negative would mean traditional is doing better, and the positive would mean that the non-traditional is doing better. So the 3.89 right here is associated with the non-traditional doing better because it's the first number, just like our Brian Darren example earlier. We were on the video where we saw which of these two would be higher. So non-traditional is in position 1. So the positive amount right here, which is the positive amount, is associated with non-traditional being higher because it would have to be that non-traditional is higher for the difference to be positive. So we should be right. Don't click around. You'll make a mistake. I was about to. Does the result suggest? No, because the interval contains 0. The true difference between these two, the interval contains 0. The results are insignificant. So the reason is we're saying that we think the difference could be that the traditional students might do this much better to the non-traditional students doing this much better. So there's no significant difference. The interval contains 0, so possibly the true difference between them is 0. We double check and we got it right. We're on a streak today. We haven't gotten anything wrong. So let's continue on here to some chapter 19. Which one was it on chapter 19 that you wanted, Abby and Neely, if you're still here? Chapter 19. What was the chapter 19 question? I need to... My inbox is crazy full. What was the chapter 19 quiz question? Gmail should, like, if the error went from 99 to 90, would the margin of error get larger too? No. If it went from 99 to 90, it would get smaller. 99, 90. So it'll go in this way. It'll get, the margin of error will get smaller. So if it goes from 99 to 90, everything should decrease. Just make sure it's saying from 99 to 90. And if it's going from 99 to 90, everything will decrease. So Abby or Neely, which one would you like? And great job, Sydney. Great work right there. Abby or Neely, which question? Which questions? Oh. Did people say? I'm trying which one people want. The injury and the outcome. Let's do it. The injury and the outcome. You're welcome, Sydney. So, injury and war. Okay, cool. Let's do the injury and war one. We can probably get most of this done right here. So, injury and war. Wait. We just passed it. Okay. So, once again, what is our null and our alternative for this? Whenever we do the null and alternative for this, we always say the null is independent and the alternative is not independent. So some of these, sometimes they might say associated. Associated means that they're dependent or not. Associated is the same as saying things are not independent. So, but I like saying always that they are independent or not independent. So if you see right here, we always get, boom, we got it. We know that the null is that site of injury site is independent of lethal, and the injury site is not independent of lethal. So this is where we have to take our data. Will it copy nice and easy? Okay, we got it. We're going to bring it over here into jump. You know we love some jump. We're going to go to File, New Data Table, Data Table. I'm going to pause right here. So yours isn't, this might be very similar. Go over the other injury one. Yeah, we'll do you want me to, I'll do this one right here, and then we'll do that one next, Neely. So we'll finish this one, and then we'll do that one next. You got it. I'll make sure we find it. So, oh, you have outcome, right? So we'll do that next. We are going to go to Edit, Paste with column names, and we have the data inside of here. Is everyone good on this part? Is this making sense, Abby? It's going to be very similar to the one we last did. And then we're going to go to Tables, and we're going to go to Stack. Now, please make sure you have a red column right here. You have a blue columns right here. You want to stack the fatal and the not fatal right here. So now we've done this, and now we're good to go. So we basically have everything we need right now. We could label these. We could label this site, and we could label this outcome, and then this would be the frequency. You don't have to do that, but we can go right now and go to Analyze, Fit Y by X. We'll put this right here, and this right here, and this right here. The red ones go here. It doesn't matter which order you put them in. The chi-square doesn't matter if you flip the X and the Y. And then we'll put the data right down here for the frequency. We'll click OK, and wow. I think it's pretty obvious to see that if you're going to get injured, you'd rather want it in your limb. Not that that's a good thing, but injuries to the head or to the body are much more likely to be fatal. If you just look at this graphic right here, we see that head, neck, and body injuries have a higher probability of fatality than do limb injuries, which are more likely to not be fatal than other. And this is probably going to be a very significant chi-squared. Chi-squared is going to be a large test statistic here, and we see it is very large, and the p-value is very, very small. Now this is a 3/2, which means we reduce it. That's 3/2 right there. And then we reduce it down to a 2/1, which means 2 degrees of freedom. Why is it a 3/2? Body and this and limb, these are one category right here, but 1, 2, 3 rows, 1, 2 columns. So 3/2, reduce it down to a 2/1. That's the degrees of freedom formulas. Rows -1 times columns -1, and we get 2 degrees of freedom. So we would, normally if we were doing this in class, have to go to an applet, which I don't have open right now, and we'd have to plot the chi-squared on a chi-square with 2 degrees of freedom and show the p-value. But we should be pretty good to go on this now. We should be able to go down here. Oh, it wants more info. It wants the expected values. Now, you could solve all these, but guess what? We've got jump. We can go right here, and we can remove out what we don't want to see, and you could solve it by yourself, but why not just have jump show you the values? There's all the expected values right here. So it starts out with body fatal, head neck fatal, good. 53.332 decimals. So 53.33, 36.86. Oops. 29.08. Did I get that right? 80. I knew it when I said it. And does this make sense right here, Abby? Are you onto this part? Hopefully it likes all my rounding. 10 point. And then we'll do Neela's question next. And then 8.20. Hopefully I've rounded everything correctly. The chi-squared test statistic is ridiculous. It's right here. This is the chi-squared, this number, not the top one. We use the Pearson. Remember, you go to the site My Pearson, so the Pearson has your p-value. So 53.22. So 53.22, and then the p-value is going to be 0. So, how many degrees of freedom? 2. P-value is going to be 0, and then we are definitely going to reject the null. There is evidence to conclude that the site of injury is not independent. So once again, look at this. I reject the null that the site of injury is independent of what happens to you regarding the fatality or not fatality of your injury. I have strong evidence to suggest, due to my low p-value, that where you are injured will give us information, or is not independent. So that's what not independent means. It gives you information on what will happen to you because of the injury. So you look at this and it's like, well, yeah, people who are getting injured in the limb are much more likely to live. Head and neck is the worst, with body coming in a close second. Really, the body, head and neck are just horrible injuries to get. So hope that doesn't happen to anyone. We did it. Awesome stuff. I was worried about the rounding because my Pearson's so particular on your rounding. I don't like it too sometimes. So I think the other injury one is this it right here. Awesome. So here's the other injury one. So Neely, we are right here. We got the next one. Once again, we're going to do is independent, is not independent. So remember, the null is always if things are independent or they are not independent. So we have here the null being things are independent, not independent. Let's go ahead and take our data right here and go to copy. People are hit by an arrow, a ground, a rock, or a sword. What is going on right here? So we're going to copy this data. We got the data copied. We're going to go over to jump. We're going to go to file, new. You're welcome. Great job, Abby. So glad to hear that. Man, that's great job. Just, yeah, I don't know what I'm doing. Just like, yeah. So great job. I'm really proud of you guys when you get those hundreds. We're going to go to edit, paste with column names, and now we're going to have to stack these. This is the same procedure we've been doing for a lot of these. Make sure that this is red and the rest of these are blue. If they're not, slow down and make sure you get it right. Oh, you're awesome. Thank you, Abby, so much. Remember, hit that like, comment, subscribe. Yeah, all that YouTube stuff, but I'm sure you already probably have. I appreciate it so much. And you get, Abby, for you, we just get one more rainbow right here. Just all that right there. So, awesome. You guys keep asking for stuff. We always try to make it fun in here. I'm so glad everyone's here. So, let's go here and let's go here to stack. Well, thank you so much. I really appreciate you guys. Coming in here, asking for help, working on this stuff. I know it's a lot. I mean, it's a crazy world we live in right now. But when you guys get excited about it and work hard, it gives me a lot of energy to like keep helping you guys. So I really appreciate it. I like seeing those hundreds. So you guys like it too, I'm sure. We're going to go here to analyze fit y by x. We're going to put the two categorical variables here. Neely, have I done anything too quick, Neely? How are you doing, Neely? Are you doing all right on these? We're going to go click OK, and look at that. The ground and rock injuries are more likely to occur to the head, neck, and limb, less likely to the body. The swords, yep. Awesome, good job. You know, we might not pass the expected cell count condition. I think we might have an issue. It's going to be close on the expected cell count. Let's see. Where's expected? Oh yeah, we don't pass the expected cell count condition. If you notice here, the expected cell count is 2.87 and 2.95. We fail the expected cell count condition. How would you know this? A good way to know which one we fail for the expected cell count is to take the smallest row total, which is going to be ground rock, and the smallest column total, which is this one. Now, don't go right here. This is what people do. I'm going to show this very importantly right here, where people make a common mistake when finding the smallest expected cell. Very commonly, people will tell me that the smallest expected cell, makes graphically even better. People will be like, the smallest expected cell is this one or this one. Those are not the smallest expected cells. The smallest expected cell will be because of this and because of this, which makes the smallest expected cell count this one. Now, the answer is not 5 for the expected cell count. You have to do row total times column total over grand total. So, awesome. We'll do that. See, Luke's got a big question right here. So, let's go right here. And we do this times this over this. And if you notice, it's 2.879, which is what I found earlier, which right now we're looking at the counts, but we go back to here, and we look at this, and we go here. If you see that value, the expected for that one right there is 2.879 because it had the smallest row total and the smallest column total. So now that we've got the information, we know the chi-squared and all this good stuff. We have to put in all of the expected values. Oh my gosh. Neely, how are you doing on this right here with finding all the expecteds? That's so much work. We got to enter an arrow body. Okay, it follows it perfectly. So you can dual screen this right here. Does that make sense that you enter in all these values right here, Neely? Do you know how to get all these values right here? Then the chi-squared goes here, which is the chi-squared right here. Here's the Pearson. How many degrees of freedom? 4 degrees of freedom because it's a 3 by 3. Yeah, 3 by 3 would turn into a 2 by 2, and that has 4 degrees of freedom. The p-value is very low, so we would reject the null at the 0.05 alpha level, and we would conclude that there is evidence that the site of injury is associated with the weapon. So we'd conclude that there is evidence that they are not independent because we do reject the null. I reject the null. I have evidence for the alternative that these are not independent. How are you doing on this, Neely? Do you think you understand where all these values would be right here? You have to click the red arrow right here and select expected inside of jump. How are you doing right there with that, Neely? We could take another. You got it. Awesome. Great stuff. Good job, Neely. Once you know where to find this stuff, it makes it a lot easier. And I totally mean that. I know I'm not saying like, oh, it's so easy when you know how to do it, but it really is. It's like, oh, I want to get the expecteds. Let me just have jump find the counts, have jump find the expecteds. If you want to get the cell chi-squareds, you can just click this arrow and it will tell you all the cell chi-squareds. So when you know where jump hides these things, it's pretty much not saying it really does hide them, but when you know where to find them, you're good to go, and that really helps out a lot. So these are cell chi-squareds right now. Don't use cell chi-squareds for these. I think, and if you have another question, feel free to ask. I'll do more of these. I'm going to hop over to Luke's question about the sodas. Luke's question on the sodas. Let's go take a look at chapter 17. Quiz. Place questions. And soda question. Here we go. Awesome. So the first thing, remember the first thing we always do is we always mark our notation. So we're always going to mark our notation. We're going to put away R for the moment. So we're going to mark our notation right here. And what do we have going on? We have right here the different glass sizes. And we have the two different things right here. Now, one thing I don't like about this problem is they don't use the statistical notation. Well, maybe they do. I didn't look at that question completely. We'll see in a second. This is N1. This is N2. This is Y bar 1. This is Y bar 2. This is S1. This is S2. So now we know all of our notation, scribbled in there a little bit there. And now we need to know the null and the alternative. Now I do suggest this, know how to write your null and alternative. You're testing two means. So when you test two means, what's the first thing you're doing? You're testing two means. So when we test two means, we have to say that the true difference between the means, remember it's always the same thing in the first position, and then we would say is equal to some value, and I think we're trying to see if it's different. We'll look at that in a second. And then 0 is the value we're testing. There are three parts every time we do these in statistical notation. Whatever goes here for the first part always goes there. Whatever goes here for the third part always goes in the same spot. The null always has the equal sign, and the alternative will be less than, greater than, or not equal to. So let's make this look a little bit better here by just erasing this as best we can make it look with my handwriting. And so we're good to go on this. There we go. So there's our null and alternative, and the reason is they wanted to know if there was a difference between the amount people use. So did the size of the glass change the portion size? Now you would think if someone has a big glass, they're going to put more in it, but it's just asking, did the size of the glass change the portion size? So the null would be that they are the same, and that would be mu1 minus mu2 equals. The alternative would be that they are different, and that would be that they're not equals. This is the statistical notation I was writing out just a moment ago. We have to find the t-statistic and the p-value for this, so let's go back and do the statistical test. To do the statistical test for this, we need to know our formula. Once again, it's in the notes, but let's write it down right here. It is y bar 1 minus y bar 2 over square root s1 squared over n1 plus s2 squared over n2 equals the t with a certain amount of degrees of freedom. From here, we just plug in the numbers we get up above. We've already marked them for what they are. So let's start plugging in. S1 is 1.88. We're going to square that. Don't forget to square these things. Then we're going to divide that by the sample size of 24. So those numbers are just up above. If I make a typo, I will get the question wrong. I'm going to copy this number for now just to keep it in the memory. We take the standard deviation 2, and we square that, and we divide it by the sample size, and we get this. Now we're going to add to it the number I just saved, which is this, and then we're going to square root it. I have now officially found the bottom of this equation. I have now found the standard error. So the last but not least thing for me to do is to take the first mean of 5.35 and subtract from it the second mean of 6.33, and I will get the difference divided by the standard error, which is the t-score. So this solved for the t-score here of negative 1.45. So the t-score is negative 1.45. And let me make sure it is mean 1 minus mean 2. So negative 1.45. And there it is right there. And it's a 2 afterwards. It wants 3 decimals. It's being very particular. I'm going to guess the p-value, but this is a very hard p-value to guess. It's a does not equals, and it's between the 20 and 10%. It's going to be between 10 and 20%. It's going to be about 14%. It wants 4 decimals. The probability of me guessing this is so low. We're putting this in as a guess right now. Why not? A bunch of 4s. So that's a guess. That is a guess, just so anyone knows who watches this later. State your conclusion. Well, the p-value is high, so I don't reject the null. The p-value is way higher than alpha. The data do not provide evidence that it will be different. So they do not provide evidence for the alternative. So the only thing I'm worried about right now is this p-value, but let's check it. It's the p-value. So let's actually get the right p-value answer. I get 2 more guesses at it. Dang it. It's around there. It's like 14, 15%. Let's take and find out the p-value. So here's what we have to do. We have to go over to the following applet. We have to put in the information given to us in the problem, which is the sample size and the degrees of freedom. So we have to take sample size 24, sample size 30. So sample size 24, sample size 30. We have to take standard deviation 1.88 and standard deviation 3.04. Standard deviation 1.88 and 3.04. This gives us the t degrees of freedom, not the t statistic, but the degrees of freedom. So once we get the degrees of freedom, we now have to go to statdistribution.com, one of my favorite sites. And here's the thing. I'm going to put this in the chat. We have to go to Iowa applet t probably, and I'll explain why. Stat distribution does not have enough decimal places to answer this. So I'll put this in the chat here in a moment once I copy in my degrees of freedom. And let's go ahead and take this applet answer right here. So if you do remember our theme, if you're ever off by the tiniest amount, please tell me. I will fix it. If for some reason you couldn't figure out that 4th decimal, don't worry. I will fix it for you. We're going to take the t statistic we got right here, and we're going to put it in. I wish it said t right there. That's one of my problems with this applet. And then we're going to do the outside region. And it was 15.28. So I was kind of close. I said about 14%, but it was 15.28. And that right there should do it. And that's 100 now. So once again, this is the hardest part for a lot of people. Let me put if you're watching this video at this point, here is the way to get the degrees of freedom. A lot of people say, well, what's the point of the degrees of freedom? The degrees of freedom tell you which t you are using. So you have to know the degrees of freedom to know which t you're using, because it'll change the shape of it every time. So the degrees of freedom will make the t look drastically different, and you have to compute that using the formula for the proper test. This one has a complicated formula which we don't solve by hand. I'll show it in here real quick. So 2 sample t degrees of freedom formula. And let's take a picture of it right here. So here it is right here. Let me grab a screenshot of it and show you the degrees of freedom formula. The degrees of freedom formula looks like the following. We could ask you to solve this by hand right here if we wanted, but we won't. So this right here is the degrees of freedom formula that is being solved for you with the following applet. So if you notice, it's just standard deviation 1, or standard deviation 1, standard deviation 2, sample size 1, sample size 2, and it'll put it through this equation right here and get you the degrees of freedom. So the good news is we don't have you solve that because it's just busy work. You might say, isn't everything busy work? Kind of. But that's kind of not as important. And I think, do we have some, are there any more 201 questions, or do we have some 474s in here now? Do we have some 474ers in here who have some questions about, I think they're doing some support vector machines. Let me start pulling up their work right here. Who has questions? Who's next? Who has questions? Let's see. Let's see. Support vector machines. Okay. Oh, it's really? Oh, I clicked the wrong thing. Oh, dang it. That's what happens when I've been online for a long time. I clicked the wrong one. My homework won't load the connection to my R data file. I sent you my RMD if you need a reference frame. So, Aaron, it's not loading your homework thing right here? When you run this function right here, it doesn't run, like mine right there. Is that what you're getting? Which I'll fix this in a second right here. I'll show you why. Do this, go to session, set working directory, choose working directory, go to wherever you usually work out of. So go to things like downloads right here, and then open that right there. And so now it should work right here. So does that make sense right there? So double check where you're working out of. So make sure you have everything in the same working directory, because if it's not loading it in, then it must be that your files are not in the right spot. So it has to be that you don't currently have it in wherever you're working out of. Like, make sure you have this file. All good, awesome, awesome. Yeah, that's, if it doesn't load, then your working directory is not in the right spot, or the file's not in the right spot. Like, either you're not in your working directory, or you're not in, or the file's not in the working directory. One of the two things. Yes, that's awesome. We got right here a bunch of checks. We got a bunch of models. Who has questions? So many things. The telco data set. So much stuff. Might need to start answering emails soon. Might need to start. We'll see if anyone has questions. I think it's been a long day. Let's see. We'll wait another minute or two more. Who has questions? Log 10 of our models is used for normalization. Yes, to transform to create normality. So you would log 10 your variables and stuff to create normality. Response question 1, part 1. Let's take a look right here. So let me see here. Why has this problem been set up? You're predicting a log 10 of the sale prices instead of the actual sale prices themselves. Make sure to include a thing of the histogram. So if you look at this right here, the reason is it's got to be heavily skewed. So the following data type, Zillow, sale price, yada, yada, yada. And so do we currently have the train in here? Cool. And if you look at this, let's just make a histogram of it really quick. And so the original stuff I think has been, you see, it's log 10 of sale price because a house is not selling for $5.2. That's a log 10 of it. And so we're looking at log 10 prices of sale price because if you were to take these and you were to go here and do 10 raised to, you'd get the original values. So here's the way the distribution originally looked. So you see there are some houses selling for very little. And this is going to be, is everything here correct? Let me think here. I think these are $200,000 houses, or that has to be right there. 2, you can write in this, you can write 2E plus 05. It does that, of course. So you can do this, equals. There we go. So that is 200,000. I mean, I don't know. My brain's always like, wait a minute here. But that is 200,000 right there. So the 200,000 is the amount we see right there. Does that make sense right there? So these are the unlogged values, and we wouldn't want to use the unlogged. We want to use the logged values. So you can see you've got some observations right here, which if we do a summary of it. That is the minimum value. So the minimum value is that right there, 4.6, which that'd be a house that's sold between 10 and 100,000, close to like maybe 70,000, which is what we notice right in here, because that would be 100,000, and then there are some houses that are selling for less than 100,000. And if it's sold, did it sell for? Look at that, 35,000. Yeah, because that's a bin from 0 to 50,000. So that's a bin from 0 to 50,000, which really, that's what. Oh yeah, logs are. Yeah, raising stuff to the 10th power is weird. Yeah, and there's more decimals. I think it's not carrying in the background. Does that make sense with that right there, Aaron? If anyone has questions, feel free to ask. So a viable response would be throwing this to normalize the data and output. If you were to unlog the data, you would have a lot of skewness in there. It's just that the algorithms, the way a lot of these algorithms work, like support vector machine and all these things, we don't want extreme outliers to play a heavy role in our data. So if you turn things into z-scores, you won't change the outliers. Turning things into z-scores only centers and scales it. And centering and scaling means you center it at 0 and you scale everything down to a standard deviation of 1. It could be scaling up to a standard deviation of 1 if you have a very, like very, very tiny decimal data set. But z-scores just puts things to a 0, 1, so everything is kind of on the same playing field. But because you don't want something to be in thousands of units and something to be in tenths of units. But then when you normalize data via transformation, which this is, it's already been log transformed, you turn something more normal, you hope. So you take this data set right here, which is very right skew, and you oftentimes perform a log transformation on it to make it more normal. Now, it's not perfectly normal, but now if we were to simply scale this right here, you could literally take this data and scale it. So probably this will work. Let's hope this works. If you were to go to scale of this data right here, and there you go. So now it's z-scores. So you can easily scale data, but the algorithm will do this for us with the pre-proc center scale. So if you look at what we have right here, we were doing the lab, and you always see in a lot of our algorithms, where's our pre-proc? Where? Is this not the one? Put the other on. We go down to here. Here we go. Pre-proc center scale. Here is where things are getting turned into z-scores. So literally it takes this data right here, and it turns it into this data. So this data right here, which I wish I had it right next to it. So let's do that. We've already got, cool. We just need to rerun the original histogram of this. Okay, cool. So it takes this data right here and it turns it into this. So this code I have highlighted will take my data and take every single thing I'm using and turn them into z-scores. But it will not transform the data. It does not do a transformation. Z-scores are not transformations. Bin widths do look a little different here. Just ignore that the bin widths are different. It's the same distribution, just with different bin widths, but it's been turned into z-scores. So if you have your original data like this, and you do pre-proc center scale, that will turn it into z-scores. Doesn't change the shape of it, even though it might look a little different. It's just bin widths. Here's the original data before a transformation. If you were to take this original data right here, and so here is the log 10, and you were to turn this into z-scores right here, how would it look? Would it look normal? The answer is no. It will retain its original shape. So just to compare, you would not change the shape of it by turning it into z-scores. It's just going to be z-scores. So here's it while it's its normal data, here's it as z-scores. And you wouldn't want this because it's still got the skew. So you don't achieve normality by doing a transformation. You achieve yes, you do. Oh my gosh. Bright lights, bright lights. You achieve normality by doing a transformation. You don't achieve normality by turning into z-scores. Here's the normal data, or here's the original data, and here's it turned into z-scores. We have not achieved normality by turning it into z-scores. The only way to achieve normality is to do something like a log 10 transformation, which this is log 10 without being z-scored, and this is log 10 with being z-scored, which turns it to z-scores. So what do z-scores do? Like the preproc center scale, it takes your data, turned it to z-scores. What do z-scoring things not do? Turning things to z-scores do not change the original shape of the data. Does that help as a review right there, Aaron? And z-scores are used to put every variable on an even playing field, and transformations are achieved to produce normality in the data because our algorithms work better on more normally distributed data. So that's got it right there. Yay! Perfect. Perfect question, and I hopefully gave the perfect answer. You gave the perfect question. I think this will be it. I've been streaming for like we're hitting the 7th hour of streaming again. We just finished hour 6 or hour 5 of streaming. This is hour 6 just finished. I was clean shaven at the start of this, Aaron. When I started streaming today, I was clean shaven. And now look at me. I've got like 70 plus emails right now. It's kind of, I was like, oh no. So it's 71 emails. I need to go look at that probably. I swear I was clean shaven. No, I'm just kidding. But I'll be answering emails. I probably need to go eat something and answer some emails and make sure my email box doesn't fill up because maybe that's why things have stopped. But I need to go look at that and see because I was like, oh no. Sometimes it shows like I have a bunch of emails and then for some reason I click on it. It's like, you only have 40 emails. I'm like, oh, it said like 80 and now it says 40. Okay, be working hard. I guess we'll head off here. I think hopefully, I don't know if we still have anyone for 474 or anything, but email me if you're stuck. I'm going to go start answering emails now. So email me if you're stuck. I will help out. We got this. Okay, I will see everybody later. And if you have questions, feel free to ask. I thought we had another person here asking about 474, but I don't know if they're here right now. I've got to go do emails, I think. They're not here. So I will be answering emails. Maybe, who knows? Maybe I'll appear later. Who knows? It's always possible, right? See you later, Jack. So good to have you. Thank you, everyone who was here. Oh, can we do the... I like the hand starts. Don't move your hand too fast on a green screen. Okay, that's got it. I will talk to everybody later. Bye, guys and gals.